it's useful to have a little bit of understanding of certain technologies that are important to ASP.NET websites. This video series is designed for both web and application developers. If you're already a website developer, then you'll have some skills in HTML, Hypertext Markup Language, Cascading Style Sheets, or CSS. And if you're an application developer, you'll have a background in some programming language. In ASP.NET, we use all of these technologies together, along with ASP.NET's collection of server-based controls to build dynamic websites and control their behavior. You also will be using SQL, or Structured Query Language. SQL is the language that's used to communicate with a database, to send instructions for retrieving data and modifying data in the back-end server-side database tables. In terms of hardware and software, you'll need a Windows-based computer. ASP.NET is not supported on Mac OS X. And your computer should be running either Windows Vista or Windows XP. If you're running Windows XP, make sure that you have Service Pack 2 or higher. In the final chapter of the video series, where I describe how to install Internet Information Services, if you want to follow along with those exercises, you'll need particular editions of Windows. For Windows Vista, you'll need Home Premium or higher. For Windows XP, you'll need the Professional Edition. If you're using one of the Windows Server products, Windows Server 2003 or 2008, you'll also be able to follow the exercises on those operating systems. And finally, you'll need to make sure that you have enough memory. All of the software taken together, including the .NET Engine, Internet Information Services, SQL Server, and Visual Web Developer, take up a good bit of memory. Your system should have at least 1 GB of RAM to operate successfully throughout these exercises, and for the best performance, I recommend 2 GB. So, if you don't have a computer with these resources, you can still watch the exercises and get a lot out of them. And if you need to improve your skills in any of the programming technologies that I mentioned, check the lynda.com online training library for many titles that teach these skills: HTML, Cascading Style Sheets, and SQL. Just a quick word about the exercise files I'll be using. If you are a premium member of the lynda.com online training library, or if you're watching this tutorial on a disk, you have access to the exercise files used throughout this title. In the exercise files folder, I've collected some assets for you to use during our tour of building dynamic websites with ASP.NET. They include graphic files, a database script, and starting web page files for use in the sample websites that I'll be creating. I've copied the folder to my desktop, but you can put it anywhere you want. To get started with the video series, you'll need to follow the instructions in Chapter 1, where I describe how to install Visual Web Developer, and Chapter 2, where I describe how to install SQL Server and create a database that you'll need. From that point onward, you can choose to work through the entire video series, or, if you'd like to jump in at a particular point, you can use the solution folders. Most of the chapters have 2 projects, one starting project and one that's completed. You can open these chapter folders directly from within Visual Web Developer. Just select File, Open Website from the menu, and then select the website folder that you want to explore. If you are a monthly or annual subscriber to lynda.com, you don't have access to the exercise files, but you can easily follow along the instructions and demonstrations on screen, and use any files you want as you create your own sample websites. Let's get started. ASP.NET is one of a family of software packages known as application servers. An application server is a piece of software that's installed on a web server to create a dynamic application platform. The World Wide Web includes many clients and servers that are connected over the Internet. Technically speaking, they communicate using a protocol called TCP/IP. This is the protocol that connects all of the computers in the whole world together. When these computers talk to each other, they exchange messages in a format known as HTTP, which stands for Hypertext Transfer Protocol. This sort of communication is used whether you're working with a static website, that is a website that delivers static fixed web pages, or a dynamic web application, such as those that are supported by ASP.NET. A client starts the process by sending a request in the HTTP format. The client requests a web resource, which might be a web page, an image file, or text files that contain JavaScript or cascading style sheet code, known as CSS. The server responds by sending back the resource that's been requested. Regardless of whether you're working in a static or a dynamic environment, the client uses a bit of software called the web browser. Personal computers, such as those running on Windows or Mac, use web browsers such as Internet Explorer, Firefox, or Safari. There are many other kinds of web clients, though, including cell phones and PDAs, such as BlackBerries. The web server is a computer that runs a piece of software called the HTTP server. There are two major HTTP server products on the market. Microsoft's Internet Information Services, also known as IIS, which is only available for the Windows platform, and Apache, which is a free HTTP server product developed by and provided by the Apache Foundation. If you're going to work with ASP.NET, you'll be deploying your web application or your dynamic website using Internet Information Services because only IIS does a good job of integrating the ASP.NET application server. Here's how a static web page works. The web client makes a request for the resource, let's say a web page, by sending an HTTP formatted request over the internet to the server. The server responds by locating the file on its hard disk that's been requested. This is known as a static web page with a file extension typically of .htm or .html. The web server responds by sending that content back to the client. And the client, which might be a web browser on a personal computer, renders and displays the web page visually. When you move to the dynamic environment, the application server software is installed on the same computer as the web server, let's say Internet Information Services and ASP.NET. The application server, in this case ASP.NET, can communicate with the database and with other server resources. Once again, the web client makes the HTTP formatted request. The web server talks to the application server talks to the database and other network resources, and then it's up to the web server to construct an HTML formatted response, which once again is sent back to the web client. The important thing here is that the web browser doesn't know that there's an application server at work, and therefore doesn't need any additional software. It requests an HTML page, and it receives an HTML page, and it doesn't know the difference between one that's static and fixed on the server's hard disk, and one that's being generated dynamically in response to its request. There are many software packages that you can select from as application servers. If you're watching this video series, you've probably already selected ASP.NET, or you're evaluating it for possible use in your organization. Microsoft Active Server Pages, or ASP, is another option that you might select. Active Server Pages is an older version of Microsoft's application server technology. You can also select Adobe ColdFusion, a cross-operating system product that works on many operating systems including Windows, Mac, and Linux, and that uses its own proprietary language, ColdFusion Markup Language. Some developers use PHP, a completely free and open source product that once again is available on many operating systems. And for Java developers, there are many application server products available, including WebSphere from IBM, WebLogic from Oracle, formerly from BEA, JBoss, a completely free J2EE or Java-based server, and others. And finally, there's Microsoft's ASP.NET. As you'll learn in this video series, ASP.NET is an object-oriented platform that allows you to select from multiple programming languages to create a dynamic, web-based application where the client makes a standard HTTP request and the server responds by constructing HTML dynamically and sending that content back to the client. These pages can include JavaScript code, cascading style sheets, image files, and everything else that you might include in a static web page. So that's a look at the basic architecture of ASP.NET. In other videos in this chapter, I describe how to install ASP.NET along with a product called Visual Web Developer, an integrated development environment that can get you started quickly building ASP.NET-based dynamic web applications. To get started, download and install Visual Web Developer 2008 Express from the ASP.NET website. You can find this free product from www.asp.net/downloads/essential. The webmasters occasionally make changes to their website. If you don't see the page that I'm displaying, just navigate to this URL. There are a number of installers available on this page, including something called the Microsoft Web Platform Installer. This installer will install Visual Web Developer, SQL Server, and a number of other tools. But I'm going to recommend that you don't use that installer. Instead, use this one, Visual Web Developer 2008 Express Edition, SP1, or whichever is the latest version when you get to this page. Download the installer application to your hard disk, and then run it. I've downloaded the installer to my desktop. Its name is vwdsetup.exe. Run the installer. After it takes a few moments to copy some files to your hard disk, it presents an initial information screen. On this screen, it tells you about the product Visual Web Developer 2008 Express Edition, and there's an option to send more information about the setup experience to Microsoft. I'll skip that option and click the Next button. On this screen, read the license terms, and then if you agree, select I have read and accept the license terms, and also take a look at the option that allows Visual Studio or Visual Web Developer Express Edition to receive and display online RSS content. If you leave this option selected, you'll see a regular news stream from Microsoft whenever you're connected to the internet and you have the product open. On the next screen, Visual Web Developer detects whether you have certain optional components already installed, including the .NET Framework version 3.5, SQL Server, and the Silverlight Player. Since I already have these components installed on my system, Visual Web Developer goes directly to this options screen. However, if you see the options there, deselect them. In particular, do not install SQL Server from this screen. I describe how to install SQL Server and its management tool, SQL Server Studio Basic, in another video. On this screen, I review the summary, indicating that I'm going to be downloading and installing Visual Web Developer 2008 Express Edition with Service Pack 1, the SQL Publishing Wizard 1.3, and Shared Management Objects. Click the Install button, and then complete the installation by following the prompts. If this is the first time you've run the installation on your computer, you might need to reboot at least once during the installation process. Also, you'll need to download all of the files. The size of the download will depend on how many components are being installed in this phase of the process. After the installation is complete, you'll be able to open Visual Web Developer 2008 from the Microsoft menu, and I describe how to use the product in other videos in this chapter. At the end of the setup process for Visual Web Developer, you're prompted to register the product. Visual Web Developer is free, but you do need to register with Microsoft to receive a free registration key. If you don't register and you don't provide your registration key, you'll still be able to use the product for 30 days, but at the end of that period it will become disabled and you'll need to register and input the registration key to continue using it. To register, go to the Help menu once you've opened Visual Web Developer and select the Register Product menu choice. I'll show that again once I have the product open. Once you've installed Visual Web Developer and the ASP.NET Framework, you're ready to create your first ASP.NET website. Start by going to the Windows Start menu, go to All Programs, and from there, locate the menu choice for Microsoft Visual Web Developer 2008 Express Edition, and start the application. When Visual Web Developer first opens, it displays a Start page. The Start page shows a list of recent projects that you might have worked on. I created one project previously called Begin. And if you selected the option to allow an RSS feed to be retrieved by Visual Web Developer during the installation process, you'll see the RSS feed on the right. To create a new website, select File, New Website, or press the keyboard shortcut Shift-Alt-N for New. On the New Website screen, select ASP.NET Website. Set the location to File System, and then select the location of your first website. This is going to be a brand new website, so it can go anywhere on disk. I'm going to place it under the Chapter 01 Getting Started folder under my Exercises folder. I'll browse. I'll start off at my desktop. From there, I'll go to the Exercises folder. From there to Chapter 01 Getting Started. And then I'll create a new folder under that named Hello World. So notice that this is a folder that doesn't contain any assets, a brand new application. I'll click Open, and Visual Web Developer detects that that folder doesn't exist yet and offers to create it. I'll click Yes, and then I'll select a language. Each website is designated for one of the two primary languages that are used in .NET, either Visual Basic or Visual Basic.NET, or Visual C#. If you're a Java or a JavaScript developer, you'll probably be more comfortable with C#. But if you're new to programming, you might want to choose Visual Basic. I'll use Visual Basic for this exercise, and click OK to create the website and its initial page. When you create a new website, an initial page is created with a name of default.aspx. All ASP.NET web pages have this ASPX file extension. The page may open in either Design or Code view. Take a look at the bottom of the screen and you'll see 3 buttons labeled Design, Split, and Source. I'll click the Design button to see what the application approximately looks like when it's shown in the browser. Now, I'll type in the words, Hello World. I'll save my changes by pressing Ctrl S or going to the menu and selecting Save Default.aspx. Notice at the bottom of the screen, the structure of the web page is displayed, showing that there's an HTML tag, a body tag, within that a paragraph tag, and within that a span tag. You can switch back and forth between Design and Source view as you need. Notice that when I typed in the words Hello World, that those words were wrapped inside this span tag. Now, to test the page in the browser, I'll go to the menu and select Debug. Notice that there are 2 options, Start Debugging and Start Without Debugging. In order to use the page with debugging, there are some configuration changes you'd need to make at this point. So for simplicity, I'll choose the menu choice, Start Without Debugging, which you can also go to with the keyboard shortcut, Ctrl F5. The page opens in the browser, displaying the text that I typed in. Now, I'm going to right-click anywhere on the page and select View Source in Internet Explorer and show you the result. As shown in Visual Web Developer's Source View, the text Hello World is wrapped inside a span tag set. You'll also notice if you look at the source that there's a generated input object with a type of hidden and a name of __ view state. I described the use of this view state object in other videos. But if you've gotten this far, then you've successfully created your first website, your first ASP.NET page, and you've successfully tested it in Internet Explorer. Once you've created an ASP.NET website, you can then add additional pages to the website. Each page is built as an HTML file with added elements and attributes that are processed by the ASP.NET application server at runtime. You place the code either in the page itself, or using an architecture sometimes known as code behind, you can place your scripting code in a separate file. I'll first show you how to create a dynamic page using the Visual Basic language. I'm working in the existing website, Hello World. From the Visual Web Developer menu, select Website, Add New Item. The contents of the Add New Item dialog box will differ depending on what sorts of components you have installed on your system. Regardless of what you have installed, though, you should minimally have the Web Form item. A web form is an ASP.NET page. When you select Web Form, notice that the name defaults to a file name with an extension of .aspx. In this first example, I'm going to create a file that uses the Visual Basic language. I'll name the file hellofromvb.aspx, and I'll select from the language list Visual Basic. Notice the option Place Code in Separate File is selected. Again, this results in placing your scripting code in a separate file that's linked into the HTML page itself. I'll click the Add button to create the file. This actually results in creating 2 files. The main file, hellofromvb.aspx, is open on the screen, and it's shown in the Solution Explorer where I'm pointing my cursor. When I click the tree icon, I'll see that there's a second file called hellofromvb.aspx.vb. And at the top of the file, in the page declaration, I'll show you that there's a code file attribute that refers to this VB file. The contents of the VB scripting file are incorporated into the page when it's requested from the server, or as it's compiled. Now, I'm going to open the VB file by double-clicking it in the Solution Explorer. When you declare a variable, which is a place to hold a dynamic value, in a page that uses Visual Basic, you place it inside the partial class declaration. And then, when you declare it, you use something called an access modifier that declares where that variable will be visible. I'll use an access modifier called protected. I'll type in the first few characters, PROT. I'll see a list of the available items that start with that string, and then I'll press the spacebar. That auto-completes the keyword protected. Now, I'm going to put in the name of the variable that I want to create. I'll simply call it var1. In Visual Basic, You then declare the data type, or the type of data the variable will hold, using the keyword as. I pressed the spacebar, I typed the letters AS, and I see the as keyword displayed. Once again, I press the spacebar to continue. Notice that Visual Web Developer automatically uppercases the word as it should be. And then I select the data type, which in this case will be string. I start typing the name of the identifier and then press the spacebar to autocomplete it. Finally, I'm going to assign this variable an initial value by adding the equal sign and then a string wrapped in double quotes of hello from VB. In Visual Basic, that's the complete statement. Once again, I've declared a variable named var1. I've set it as protected, which I'll explain in another video. And I've set its data type to string and its value to hello from VB. Now I'll press Ctrl S to save the file, and I'll go back to the web page that uses that code file. Now, to output that value in the page, I'll place the cursor between the div tags. Notice that the div tags are inside a form. All ASP.NET pages contain this form element by default, which allows the page to be submitted to the server. In order to output the variable, I'll use this code. I'll start with a less than character, then the % character. Notice that Visual Web Developer auto-completes that code and creates an ending token to match. And then I'll put in an equals operator, which means output a value. Then I'll start typing the name of my variable, var1, and notice that Visual Web Developer already knows the name of the variable. When I see it on the screen selected, I'll press the spacebar to auto-complete the code. I'll press delete once to clean up the code a little bit, and then Ctrl S. And notice that Visual Web Developer closes up the code and makes it nice and pretty. I've saved the file, and I'm ready to test it. I'll go to the menu and select Debug, Start Without Debugging, or press Ctrl F5. And when the page is loaded, it displays the dynamic value, hello from VB. Now, I'll do the same thing in C#. I'll close the browser. Once again, I'll go to Website, Add New Item. I'll name this file Hello from C#. And I'll select that language, Visual C#, and click Add. I'm going to open up the ASPX file in the Solution Explorer panel, and then open its associated code file, which now has an extension of .cs. You'll see that a C# file is a complete class declaration, marked only by this keyword, partial. I explain more about partial classes in the chapter on ASP.NET architecture. For now, the one thing you need to know is that if you want to declare a variable and make it available to the page itself, you place it inside the class declaration, but above the page load function, which is called an event handler function. Now, I'll declare the same variable as before. In C#, the word protected has a lowercase p, and Visual Web Developer is helping me auto-complete the code as I go each time I press the space key. I put in the keyword protected, and next, the data type, which is string. Now the variable name, which once again will be var1, I assign the initial value, hello from C#. In C#, you end each statement with a semicolon, using a syntax that's very similar to Java, JavaScript, and C++. I'll save my changes, and then I'll go back to the ASPX or the page file from which this file is linked. And the code here will be exactly the same as in the Visual Basic example. I'll create a less than character and a %. Visual Web Developer automatically completes that much of the code. The equals operator to indicate that I want to output a value. And then once again, var1, the name of the variable. And then I'll run the page selecting Debug, Start Without Debugging. When the page loads, I see the dynamic value, hello from C# displayed on the page. So that's a look at how to create dynamic web pages using Visual Web Developer. Each page consists of the page itself plus a linked code file. You don't have to separate the code and the HTML markup into two separate files, but Visual Web Developer makes it very easy to do this if that's the architecture that you want to follow. When you run a page from within Visual Web Developer, you're actually requesting it from a web server. You're using something called the Development Web Server, a bit of software that's included with both Visual Web Developer and Visual Studio that allows you to test your ASP.NET pages without having to install and configure the full Internet Information Services enterprise-level web server. When you create your first website and your first ASP.NET page, and then go to the Debug menu and select Start Without Debugging. You'll see that you're opening the page in your selected web browser. I'm using Internet Explorer. If you look at the URL, or the address of the page as it's requested from the web server, you'll see that the URL starts with http://localhost. Localhost is the automatic name of a web server that's on your local system. You'll then see this bit of code, colon, and then a numeric value. The numeric value is something called a port number. When you run a web page on the internet, typically you're requesting that web page from port number 80, known as the default HTTP port. Or, if you're requesting a page using a prefix of HTTPS, which stands for secure, you're typically using a port in the background of 443. When you use the development web server, by default, the web server assigns a dynamic port number. That is, it makes it up at the moment that you start the server. And you can see what the dynamic port number is by looking at the web browser, but you can also see it by going down to the system tray in the lower right-hand corner of the Windows interface. There, you'll see a system tray icon, and if you move the cursor over that icon, you'll once again see an indication of the development server's port number. In most cases, it's fine to use that dynamic port, but in some cases you might want to set the port explicitly, so you know which port number you'll be using. I'll show you how to do that here. In order to freeze the port number for a particular website, start off in the Properties view. I've gone to the Properties view, which is down in the lower right corner, and I'm going to double-click its title bar. That causes it to float. I'll then move it out into the center of the screen, and then click and drag to make it a little bit wider. Next, I'll go back to the Solution Explorer, which is still docked on the right, and I'll click on the folder name. That is, the folder which is the name of the website, in this case, Hello World. The Properties panel updates and shows the web server properties. Notice that by default, a property called Always Start When Debugging is set to true, and a property called Use Dynamic Ports is set to true as well. I'm going to change that value from true to false, and then I should be able to click into the port number property. It takes just a moment for it to be activated, so be patient. And then you can type in any port number that isn't otherwise being used on your system. Now, when you set your own port number, you should always use a value that's in the thousands or up. And there's no way to know exactly which port numbers are used on your particular system, but typically if you use something in the 4000 range, you'll be safe. So I'm going to use a value of 4444. Now, I'm going to save my changes by pressing Ctrl+S. I'll go down to the system tray, and I'm going to right-click on the icon for the ASP.NET Development Server, and I'll select Stop, which closes down the web server. Now, I'll move the Properties panel over so I can see the toolbar, and once again I'll select Debug, Start Without Debugging. The web server is once again started up automatically, but now I'm using the port number 4444. I'll see the value in the web browser, and I'll also see it in the system tray icon for the development server. So once again, the purpose of the development web server is to allow you to test your pages using a full-blown web server, but without having to go through the process of installing and configuring the full enterprise web server, Internet Information Services. When you deploy your ASP.NET website for production, that is for use by your users, you'll want to use the full web server. IIS has a lot of tools that the development web server doesn't have, and it's really scalable, meaning it can support a lot more users at the same time than the development server can. But for convenience, you can't beat the development server during your initial development phase. Visual Web Developer 2008 Express Edition is Microsoft's free integrated development environment to help you get started quickly building ASP.NET pages and websites. I'm going to give you a tour of the interface of this product. The menu includes most of the actions that you start with, such as creating new resources, testing your applications, and so on. Most of the most important menu choices have associated keyboard shortcuts. For example, to create a new website, you could select File, New Website, or you could press the associated keyboard shortcut, Shift+Alt+N. For any particular menu choice, if you don't know the keyboard shortcut, just take a look at the menu and you'll see that there's a hint. The Edit menu includes common choices for cutting, copying, and pasting, and deleting text. You'll also find a number of options for searching for text under the Find and Replace menu choice. And under Bookmarks, you'll find that there's the ability to create a bookmark and then return the cursor to that location in a particular file or folder. The View menu includes choices to open particular panels in the interface. By default, you see the Solution Explorer, the Database Explorer, and the Properties panels displayed on the right side of the interface. But there are many other visual tools available. For example, the Error List displays a list of all of your programming problems. To open it, select View, Error List, and you'll see the Error List panel appear at the bottom of the interface. To close any particular panel, just click the Close icon. You can also move these panels around. For example, if I click on the Properties panel on its header and then drag it out into the center, you'll see that that turns it into a floating panel. I can then click and drag to resize the panel as needed. And then when I click on particular elements of the web page in the background, I'll see the properties for that particular element. You can close a panel by clicking the Close icon, and then bring it up again by either using the menu choice, or as I'll do here, by pressing F4. When you bring it back up, it will open using the same dimensions that it had when you closed it. So you can easily customize the look and feel of Visual Web Developer to make it look the way you want. If at any point you want to return Visual Web Developer to its default appearance, that is, place the panels back in their original locations and sizes, go to the menu and select Window, Reset Window Layout. After confirming by clicking Yes, you'll see that everything goes back to its original positions. There are three special panels over on the left, known as the Toolbox, the CSS Properties, and the Manage Styles panels. These three panels can be opened easily by simply hovering the cursor over the tab for that panel. Here, I've moved the cursor over the Toolbox tab, and the Toolbox panel slides in from the left. I can then navigate around, scroll up and down, and select items that I want to work with, and then I can either move the cursor off the panel and then click on the background web page, and you'll see that the Toolbox panel responds by sliding back into place. The same thing works with the CSS Properties panel and the Manage Styles panel. All three of these styles can also be pinned into place. When you click the Pin button, that makes it no longer a sliding panel, but now a panel that's pinned into place. And then once again, you can reset the window layout by selecting Window, Reset Window Layout, and confirming. There are various tools on the toolbar above the editing area. For example, if I wanted to take this text and turn it into a heading 1, I'd simply select the text, then go up to the toolbar, pull down the list of available formats, and select Heading 1 or the H1 tag. Visual Web Developer responds by wrapping that text in the H1 tag set. And if I then go down to the bottom of the editing area and click the Source button, I'll see the result that the span tag that contains the text Hello World has been wrapped inside the H1 tag set. If you're an experienced HTML developer, you'll find that Visual Web Developer helps you with a certain amount of HTML coding, but leaves most of the HTML coding up to you. Finally, there's the use of cascading style sheets. You can create cascading style sheet rules easily using the CSS Properties panel, and then apply those rules to selected parts of your web page. I describe these features at more length in the chapter of this video series about ASP.NET and visual design. Most dynamic websites built with Microsoft ASP.NET need a database, a place on the server where data can be stored and retrieved to generate the pages that are requested by the client. I recommend using Microsoft SQL Server. SQL Server is one of a class of databases known as enterprise databases, meaning that they can handle very large amounts of data and a large number of simultaneous users. There are many database products available on the market. MySQL, which is now owned by Sun Microsystems, is a free database that provides powerful relational database support. There's also Oracle, one of the best of the enterprise database class, and IBM DB2. And you can also select Microsoft Access. When building an ASP.NET website, I think that Microsoft SQL Server is your best bet, for these reasons. First of all, it's highly scalable, meaning that it can handle enormous amounts of data and a large number of simultaneous users. This distinguishes it from Microsoft Access, which is really designed for use as a desktop database by an individual user. While it is possible to build a dynamic website using Microsoft Access, and while ASP.NET does include all of the software or drivers that you need to use Access in the web environment, most developers and website administrators find that there's a very quick upper limit to both the amount of data and number of simultaneous users that you can support with the Access model. ASP.NET includes all of the required drivers not just for Access though, but also for SQL Server. And this distinguishes SQL Server from products like MySQL, Oracle, and IBM DB2. If your organization is already invested in those databases, that is, if you have an enormous amount of data already in MySQL, Oracle, or DB2, there are drivers available on the market for integration with the .NET framework. But if you're getting started for the first time with data that will be used to support a dynamic website, you'll find you'll be able to get started more easily with SQL Server. SQL Server and ASP.NET share a programming model, the .NET framework. If you're familiar with programming in Visual Basic .NET, C#, or one of the other programming languages that's supported by .NET, you'll find you're able to use the same programming skills in both environments. And finally, SQL Server is highly integrated with Windows and its security model, which makes it easy to create integration and authentication of users when dealing with secured websites. To get started with SQL Server, the first step is to figure out which version of SQL Server you need. There are many editions of SQL Server available. You can go to this web page, which is listed on the screen, at msdn.microsoft.com/en-us/library/ms144275.aspx. This web page at the SQL Server Developer Center includes a listing of all of the different editions of SQL Server that are available. When you deploy your ASP.NET website, if you're building an enormous website that needs to serve a lot of users, you might need the Enterprise edition of SQL Server. But you'll find that there are less expensive versions available as well, including the web version, which is a much lower cost edition specifically designed for deployment with websites. You'll also find SQL Server Express listed on this page. I'll be using SQL Server Express with tools during this video series. This edition of SQL Server includes both the server itself and the tools you need to manage the server, allowing you to create new databases, manage the structure of existing databases, and configure SQL Server on your system for use with your development environment. I should caution that if you're going to install SQL Server Express on the same machine on which you're running Visual Web Developer and the .NET Framework, the machine should be equipped with a minimum of 1 GB of RAM, and you'll probably find that 2 GB of RAM will be much better. You'll find other editions of SQL Server on this same page, including the Compact Edition, which is designed for mobile devices and web clients on all Windows platforms. In order to download the appropriate version of SQL Server, go to this page, www.microsoft.com/express/SQL. On this page, you'll find a simple listing of the SQL Server 2008 Express product and a link to get started. When you click through to the link, you'll be able to download SQL Server 2008 Express for free. You don't have to register. You can go directly to the download page by clicking on the download link, but if you do register, it will allow you to receive information from Microsoft about changes to the SQL Server 2008 Express product. As you scroll down on the page, you'll find a number of versions that you can select from. If you're getting started with SQL Server for the first time, choose this download, SQL Server 2008 Express with Tools. You'll receive both the SQL Server Database Engine that allows you to create databases, set up their structure, and create initial data, and SQL Server Management Studio Basic, an integrated environment for managing your SQL Server installation. After you've downloaded the application installer for SQL Server and Tools, you'll be able to install SQL Server and the SQL Server Management Console in one single installation. This is the screen you'll see when you first start up the setup application. The first step is to check your system configuration using the System Configuration Checker tool. Click the link. The System Configuration Checker looks for a set of conditions on your system and walks you through required steps to upgrade your system where necessary. Here's the result on my system. It checks consistency validation in the registry, looks for unsupported SQL Server products, and other features. Most specifically, check for the Windows PowerShell. This is a set of tools that are used by the installer. If they're not present, you'll need to download and install Windows PowerShell, which is a free download from the Microsoft website. If you see a failure indicated on this line, click the link and follow the steps to go to the Microsoft website, download the PowerShell tool, and install it. If you see a combination of past and warning indicators, you're ready to go to the next step. Click OK to continue. Now, go to the installation by clicking the installation link on the left, then click New SQL Server Standalone Installation or Add Features to an existing installation. On my system, I don't have any SQL Server instances installed yet. If you do have SQL Server instances installed, your results will differ. On this screen, the SQL Server Setup application checks for certain support rules. Once again, if you see any failures in the report, you'll need to follow the steps that are recommended to fix your system and get ready for the next setup step. If you see that the operation completed successfully, you can click OK. In the next step, the setup application installs setup support files, components that are required for SQL Server setup. Assuming you don't see any failure indicators, click the Install button. It takes a few moments to install the setup support files. After that step is completed, you're now ready to actually install SQL Server and the supporting tools. Once again, the setup application runs a few tests, and if you see any failures, click the links and follow the recommended steps. If you see a combination of past and warning messages, click the Next button, then indicate that you're going to be installing a free edition of SQL Server. Click Next again. Review the license terms, and if you accept them, click the appropriate option and click Next. On this screen, you indicate which SQL Server features you want to install. You must install the Database Engine Services and the SQL Server Management Tools labeled Basic in order to follow the tutorials in the rest of the video series. The SQL Client Connectivity SDK may be disabled, but if it is enabled, you can select it if you want to do advanced SQL Server programming. SQL Server Replication is optional for this tutorial, but I recommend selecting it. And then once again, click Next. On the Instance Configuration screen, you indicate the named instance of SQL Server that you want to install. The default name is simply SQL Express. Accept the named instance of SQL Express and the instance ID of the same name, and accept the default root directory. Notice that SQL Server will be installed in a directory named mssql10.sql express, and click Next. On the disk space requirements screen, you'll see an indication of how much disk space is required and how much is available on your disk. Make sure that you have adequate space before you continue. Now click Next. On this screen, you're going to indicate the account that's going to be used for each SQL server. Click the down arrow to select an account name, and select NT-Authority/System. The complete string may differ depending on whether you're working on Windows Vista or Windows XP, but definitely select the system account. You shouldn't need to provide a password at this point. The SQL Server browser should use the same account name. Click Next. Now indicate the authentication mode. By default, you use the Windows authentication mode, meaning that you're authenticating based on your membership in the Windows security framework. Instead, you're going to select Mixed Mode, which means that you're going to allow both Windows authentication and SQL Server authentication, where you log into SQL Server using a username and password. The SQL Server System Administrator account has an automatic name of SA for System Administrator. You'll need to enter a password at this point, and the setup application wants you to use a strong password that consists of both letters and numbers. I'm going to use a password that's easy to remember, a password 123. I recommend that you use the same sort of password for your local system development, but make sure you use a stronger password that includes special characters and a mixture of upper and lowercase characters on an actual production installation of SQL Server. I'm going to click Add Current User. I'm logged in as a user named ASP.NET ESST for Essential Training on my machine. This Windows user will have unrestricted access to the SQL Server database engine and all of the database that are installed in it. Now click Next. Select options as you like for usage and error reporting to Microsoft. I'm going to leave those options turned off. And click Next again. Next, the setup application determines if the installation process is going to be blocked in any way. Assuming that you get a pass on all of the tests, you're ready to click Next one more time. Check the summary of all the installation options that you've selected, and then finally, click Install to start the installation process. You should now be able to walk away from your computer and allow the installation process to complete. When it's complete, SQL Server and the SQL Server Administrator, the basic version, will have been installed, and you should be ready to set up a database for the first time. If you have any problems with the installation process, check the tech support options on the Microsoft website for SQL Server Express installation. Once you've installed SQL Server 2008 and SQL Server Management Studio, you can start to manage your SQL Server installation. There are two aspects to this. First, to start and stop SQL Server, you can use the Windows Services panel. To get there, go to the Control panel. I'm opening the Windows Start menu on Windows Vista. From there, I'll go to the Control panel. Now select the Classic View. From the Classic View, select Administrative Tools, and from there, double-click on Services. This is the panel where you can turn services on and off, and configure whether they start up automatically when you turn your system on. I've expanded the Services panel to full screen. Now, I'll scroll down to the SQL Server section. You'll see that there are many services that are installed during the SQL Server installation. This is the primary one, SQL Server. Notice that after you've installed SQL Server, it's configured to start automatically. If at any time you need to stop SQL Server, to regain memory for example, or just to clear its own memory, you can select the service, and then go up to the toolbar and click Stop Service and then restart it, or you can simply click the Restart Service button. You can also double-click into the service, and that will open up the configuration screen. Here, you can indicate whether you want the database to start automatically upon system startup. Again, by default, it starts up automatically, but you can change that to manual, and then when you want to use SQL Server, you'll need to open the Services panel and start it yourself. I'll leave it set to its default setting of automatic, and I'll cancel out of this dialog box and close the Services panel. The other aspect of managing SQL Server is learning how to use SQL Server Management Studio. To open it, go to the Windows Start menu to All Programs. From there, go to the folder Microsoft SQL Server 2008. And from there, select SQL Server Management Studio. If you use the application frequently, you might want to add a shortcut to your desktop or to the shortcuts list at the bottom of the screen. When Microsoft SQL Server Management Studio first opens, it looks for an SQL Server installation. On my system, it automatically found the SQL Express instance on my machine, where the machine name is David MB Pro. If you don't see your server listed, you can ask the Management Studio to browse for it. Click the down list and select Browse for More. In the Browse for Servers dialog, open the Database Engine list, select your instance of Microsoft SQL Server, and click OK. Each time you do this, a new entry will be added to the list of servers that you'll see. So for example, on my system, I see my server listed twice. There's no problem with that, as long as you have the syntax correct, the name of the machine, a backslash, and then the name of the instance of SQL Server. Once you've selected the server, you then indicate how you want to authenticate, that is, how to log in. The default is Windows Authentication, which means that the user account that's running SQL Server is actually used to log in the background. Alternatively, you can use the username and password of the system administrator that you set up during installation. When I choose SQL Server Authentication, I then log in with the system administrator username, which by default is SA. And then I enter the password that I created during the installation process, which on my system was password123. So whether you authenticate using Windows or SQL Server Authentication, you should now be able to click the Connect button and see your server listed in the Object Explorer panel on the left. Within the Object Explorer, you can open the Databases list, and you should see an item there called System Databases. Because we haven't added any user databases yet, you won't see any actual user data. There are also categories for security, server objects, replication, and management. I'm going to be showing you in other videos how to create a brand new database and how to restore a database that's provided to you from another SQL Server installation. After installing SQL Server and connecting to it for the first time from SQL Server Management Studio, you're ready to create your first database. The name of the file is mybookstore.sql. It's a text file that you can open in any text editor. The file uses a database named mybookstore, defined at the top of the file. And then it looks for 4 database tables called authors, publishers, titles, and users. For each of these tables, if the tables exist, it first deletes them, which is an operation in SQL called dropping the table. In the next section, it creates new versions of the tables. For example, this code that I'm selecting creates the table users and defines its structure. I'll turn word wrap on so that you can see all of the code that's involved. The users table contains a column called user ID, which is the primary key, known in SQL Server as an identity column. An identity column is an integer column that auto-increments. That is, each time a new record is added to the database table, the database assigns the next available numeric value. There are also columns called username, user password, and user roles, which are variable character or string fields that can hold up to 50 characters each. The next table is called titles. The titles table once again has a primary key, which is an identity column, this time named title_ID. It contains 2 columns called pub ID and AU ID for author ID, which are integers, a column called title, which can contain a string of up to 80 characters, the price, which is a money value or a currency value, the pub date, which is a date time, and a notes column, which is a variable character or string field containing up to 200 characters. Once again, this table has a single column primary key, the title ID. Below the code to create that table, you'll find a series of insert statements. Each insert statement creates one record in the titles table. Continuing farther down the file, you'll find code to create a publishers table. Pub_ID, which is the primary key and again is an integer identity column, and pub name, a variable character column containing up to 40 characters. And then once again you'll find a set of insert statements that add the data. And the last table is called authors. The authors table contains a primary key named AU_ID, using the same type and rules as all other primary keys in the database, AU name and AU name, which are variable character fields, phone, address, city, state, and zip, which are all variable character or character columns. Once again, there's a single column primary key based on the AU ID column. And below that, a set of insert statements to add the data. So here's how you'll use the SQL file if you have access to it. I'll first reopen SQL Server Management Studio. I'm working in Windows Vista, so it's a little bit easier in Vista to find the application. I simply type in part of the application name, Management Studio, and when I see it appear at the top, I select it. If you're using Windows XP, you'll need to go through the All Programs menu tree. This time I'll show you an alternative approach to connecting to your database. Instead of using the actual machine name, this time I'm going to connect using localhost /SQL Express. And I'll use Windows authentication rather than SQL Server authentication. I'm still connecting to the same database server as I did in another video though. And I'll click the Connect button. Once the database is open, I'll then take a look at the databases list and show that there are no user databases currently created. Now, to create my first database, I'll right-click on Databases and select New Database. I'll name the database My Bookstore. When you create a new database in SQL Server, you'll be creating 2 files. The primary file, which contains the data, and the log file, which tracks changes to the data for backup and restore purposes. In the Database Files section, you'll see that the actual names and locations of the files are listed. They're created automatically under a data folder under your SQL Server installation folder's MS SQL folder. The name of the file will match the name of the database. The primary file will have a file extension of MDF, and the secondary or log file has a file extension of LDF. Click OK to create the database. Now you'll do some SQL scripting to create the structure and add the data. Go to the toolbar and click New Query. That opens up an SQL query window. Now I'll return to the SQL file and once again open it in any text editor. I'm using TextPad. Now I'll select all of the code in the SQL file by pressing Ctrl-A, and then I'll copy all of that content to the clipboard. Now I'll return to SQL Server Management Studio, and I'll paste all that SQL into place. In the next step, I'll run the SQL file, which will result in creating all the tables and adding all of the data. I'll go to the toolbar and click Execute. It takes less than a second for the operation to happen. Now, to check the results, I'll go to the database listing over in the Object Explorer, and I'll open it up, and I'll open up the list of tables, and I should see the 4 tables listed that were defined in the SQL file: authors, publishers, titles, and users. Notice that all 4 tables have a DBO prefix. DBO is the schema, or the database that owns those tables. It is possible in an SQL Server installation to have more than one table with the same name, but they must be members of different schema. If you don't specify a schema in your SQL file, DBO is used automatically. But you'll see in my SQL file that the DBO prefix was in there. Now I'll check the structure of the data. I'll open up dbo.authors, and then I'll open the columns list, and I'll see all of the columns that were defined in the SQL file are listed there. And finally, I'll check the data. I'll right-click on the table name, and I'll choose Select Top 1000 Rows. In the center of the SQL Server Management Studio interface, I'll see the resulting SQL statement that would retrieve the data, and then below that I'll see the actual data that was retrieved in a data grid. You can also edit the data from this interface. For example, you can right-click on the table, and then select Edit Top 200 Rows. And then you can actually go into the data and make changes, and your changes will be saved right back to the database files. So that's a look at how to create the SQL Server database if you have access to the exercise files. If you don't have access to the exercise files, you'll need to create the tables yourself. For example, you can go to the Tables item in the Object Explorer, right-click and select New Table. And if, for example, I were creating the Authors table, I would type in the name of the column, AUID. I would select the data type, which in this case is INT for integer. And then, assuming that this was a primary key and an auto-incrementing or identity column, I would come up here and click Set Primary Key. And then down here in the column Properties, I would scroll down to the section labeled Identity Specification. I'd open that up, and then I'd set the property isIdentity to Yes. And to create a variable character field, I would click once again into the list of columns, type in the name of the column, select the data type, which will be varchar. Notice that it defaults to a size of 50, and then if I want to change the size of the column, I would go into the General Properties in the Column Properties panel and change the length, let's say from 50 to 40. After you set up all of your table structure information in the grid above, you then save the table. I'll click on the Save icon in the toolbar, and notice that I'm prompted for the name of the table. I'm not going to save this new table because I already have my tables created. But again, if you don't have access to the exercise files, this is how you can create the tables using SQL Server Management Studio. You can then edit the tables and add your data directly through the SQL Server Management Studio interface. Once you've created your database through SQL Server Management Studio, you're then ready to work with it from within Visual Web Developer 2008. Open Visual Web Developer, and then create a brand new website. You can create it anywhere on disk. I'm going to create it under my exercise files area. From the menu, select File, New Website, select ASP.NET Website from the Templates list, and then set the website location. I'll create a new website called SQL Server under the Exercise Files ch02 SQL Server folder. The language can be either Visual C# or Visual Basic for this exercise. Click OK to create the brand new website. As with all brand new websites, you'll have a single file called default.aspx, which has an associated file with either a .cs or a .vb extension that contains the page's code. Now, to connect to your database, go to the Database Explorer window. By default, this appears on the right side in the tabs associated with the Solution Explorer. Then go to the toolbar and click the button labeled Connect to Database. You can also right-click on Data Connections and select Add Connection from there. Either way, you'll go to the Add Connection dialog box. If you instead see a prompt to choose a data source, select Microsoft SQL Server, and then click Continue. You can click the refresh button and try to connect to your database automatically, but you might find from within Visual Web Developer that all you see is the name of your computer. Notice that if I pull down the list, I see David MB Pro, which is the name of my computer. Instead, you'll want to type in the server name and the SQL Server instance manually, and use localhost rather than your actual computer name to make the database connection more portable between computers. I'll type in localhost, then a backslash character. Make sure you're using the backslash and not the forward slash, and then the SQL Server instance name, which is SQL Express. Notice this time that I'm typing it in all lowercase. The instance name is not case sensitive. Next, you'll indicate whether you're using Windows authentication or SQL Server authentication. If your copy of SQL Server is on your own computer, as is the case here, you can use Windows authentication. If you're working with an SQL Server installation on another system, such as an SQL Server database that's rented from an internet service provider, you'll need to use SQL Server authentication and pass in your username and your password. I'll use Windows authentication. At this point, you should be able to see a list of the databases that are available through your copy of SQL Server. Go down to the label, select or enter a database name, and click the arrow to see a list of available databases. And there's the database that I've already created called My Bookstore. Now, if you don't see that database listed, you should go back to the previous videos in this chapter and follow the directions to create the database. If you do see the database, though, select it. Now, click the Test Connection button, and you should see the dialog box indicating that the test succeeded and that you're connected to the database. Click OK to clear the dialog, then click OK to save your database connection configuration. From within the Database Explorer, you can take a look at the structure of your database. Now here's a little tip about working with the panels on the right side of the Visual Web Developer interface. Notice that on my screen, which has a resolution of 1024 by 768, the amount of visual space I have to work in is fairly limited. You can improve that situation by reconfiguring the panels on the right so that they slide out in the same way as the panels on the left. The easiest way to do this is to go to the menu and select Window, Auto Hide All. Notice that all of the panels on the right are now turned into tabbed panels, just like the ones on the left. You can now move the cursor over the appropriate tab, such as the Database Explorer, and then you'll have a lot more vertical space to work with. And if you like, you can even drag out the width of that panel, and now you can see everything you need to see. I'll open up my connection, and I'll show you that it has the list of tables. I'll open up the table list, and there are the 4 tables that are available in the database: authors, publishers, titles, and users. From the Database Explorer, you can right-click and select Show Table Data, and Visual Web Developer will query the database table and show you the results. Close that window and then move the cursor over the tab again. You'll see the Database Explorer slide out. Then go to the Authors table again, right-click, and select Open Table Definition. In Visual Web Developer, you can actually manage your SQL Server table structure in the same way as you can in SQL Server Management Studio. You can add columns, change column properties, and again do everything that you can in the Studio interface. The only thing that was important to do in SQL Server Management Studio itself was to actually create the database. But then once it's created, you can do everything else from within Visual Web Developer. Finally, I'll go back to the Database Explorer one more time and show that there are many more categories that you can create. For example, you can go to the Views and create pre-built queries. You can use stored procedures, functions, and everything else that's available in SQL Server 2008. After defining your database connection, you can then use Visual Web Developer to create and test SQL queries. To do this, go to the Database Explorer panel. I've previously configured my Database Explorer panel so that it slides in from the right. Then, go to the database connection, right-click, and select New Query. In order to query the database, you define which tables you're going to query. The table structure of this database connects the titles table to both the publishers and the authors table through keys or joins. Double-click on the titles table first, and you'll see the titles table added in the background. Then double-click on publishers and on authors. You'll see the publishers and authors tables added, and you'll also see that connections are made between the tables automatically. These connections are made because the names of the columns in the tables match each other, and Visual Web Developer picks that up and decides that it can join the columns during the query's execution. Now, close the Add Table dialog and take another look at the diagram of the query. You can drag the table icons around as you need to, and also resize or even close the different panes of the query interface. The next step is to indicate which columns of the tables you want to include in your query results. For example, I'd like to display the title of each book, so I'll click the checkbox next to title, and I'd also like the book's price, and scrolling down a bit, the book's publication date. You can vertically expand the size of the panels if you're not able to see all of the columns. Now, I'd also like to include the publisher's name, so I'll check that option, and I'll also select the author's first name and last name. Take a look at the SQL code that's being generated in the third pane, the SQL pane. It's a select statement, which retrieves the title, price, and pub date from titles, the pub name column from publishers, and the author's last name and first name, and then joins the tables on the appropriate columns. Now, to test your query, go to the toolbar and look for the icon with the exclamation mark. This is the Execute SQL button. Click the button, and then in the bottom pane, which is your results pane, you'll see the data that's retrieved from the database. Now let's make a little change. Instead of retrieving the data in its natural sort order, I'd like to sort it in order by price. So I'll go to the row that represents the price, and I'll change the sort type to ascending, so that I'm listing the books from least expensive to most expensive. If you select more than one column in your sort, you'll also need to select a sort order. Now take a look at the resulting SQL, and you'll see that an order by clause has been added to the SQL statement that causes the data to be returned in that order. Once again, execute the SQL statement, drag upward so that you can see the results, and you should see that the data is returned in ascending order by price. The purpose of the query interface is to allow you to model and generate SQL statements. You can't actually take these SQL statements and automatically add them into your code. Instead, you'll just need to copy and paste the SQL code that's been generated and use it in your code as needed. But Visual Web Developer 2008 Express Edition helps you do this easily. If you're fairly new to SQL, you'll find that this is a great learning tool. And even for those web developers who are fairly experienced with the SQL language, you'll find that creating SQL code with simple joins and so on is made much speedier by the use of this visual tool. After you define a database connection in Visual Web Developer, you can then present data easily in any ASP.NET page. I'll be working with the file default.aspx, which was created automatically when I created the new website. First, with default.aspx in code view, I'll click into the title element within the head section, and I'll put in a title of author list. Then within the div tag, I'll add an h1 tag set, and within the h1 tag set, I'll once again type in author list. Then I'll look at the page in design view. Notice that the author list heading is displayed on the screen. Next, I'm going to press enter. This results in creating a new paragraph in the page. Now, to actually display the list of authors on the page, all I'll need to do is drag the authors table from the Database Explorer into the page. Visual Web Developer will take care of everything in the background. I'll go to the Database Explorer. From there, I'll open my list of tables, and I'll locate the authors table. And I'll click and drag the authors table and drop it inside the paragraph. After a moment, I'll see a grid view appear. A grid view is a rendering of an HTML table that dynamically presents the data. I'll describe in detail how to use a grid view in other videos, but for now, I'm just going to save and test the page. I'll save the file, then I'll go to the menu and select Debug, Start Without Debugging, or press Ctrl F5. Visual Web Developer starts up the development web server and runs the page and displays the data automatically. You'll see that all of the columns from the database table are displayed: the primary key, the author's first name and last name, and so on. Now, I'll describe some of the things that happened in the background when I dragged the table into the page. I'll close the browser, and first let's take a look at the code that was generated in default.aspx. I'll click on Source View, then go to View, Full Screen. so I can see as much code as possible. Notice that I created something called a grid view. The grid view generates the HTML table code that's presented by the browser. A little further down, I'll find a little bit of code that generates something called an SQL data source. The SQL data source describes how I'm going to retrieve the data from the database server. And most importantly, it uses something called a connection string. A connection string is a definition of the location of the database and a description of how I'm going to connect to it. And you'll see that an automatic connection string called myBookstore connection string 1 was generated by Visual Web Developer. This connection string is defined in a file called webconfig. I'll go back to full screen and go to the Solution Explorer and open the web.config file. I press Ctrl F, that opens up the Find and Replace dialog, type in connection and click Find Next, and then close the Find and Replace dialog. You'll see that a new element called connection strings has been added. And then within the connection strings element, there's an add element with the name of myBookstore connection string 1. And then the definition of the database and how I'm connecting is right here. It says connection string equals data source equals localhost / SQL Express, initial catalog equals myBookstore, which is known in SQL Server as the database name, and integrated security equals true. Integrated security is what's known in Visual Web Developer as Windows authentication, meaning I don't need to provide my username and password to authenticate and use the database. Once the connection string has been defined once in the web.config file, it can then be used throughout the rest of my website. It doesn't have to be defined new each time. And it's also important to note that even though I had previously defined the connection in Visual Web Developer, the connection was only defined for this particular website when I dragged my first bit of data into my first page. Until then, the database connection information was being managed by Visual Web Developer, and it will now be available to all the websites that I use as long as I'm using this copy of Visual Web Developer and I'm logged in as myself on my copy of Windows. The pages that you create in ASP.NET websites are known as web form pages. Unlike conventional web pages, these are always built as data entry forms, which post back to the server for server-based processing. For all of the demonstrations in this chapter, I'll use a set of files that's in a website that's a part of the exercise files provided with the video series. When you create a brand new ASP.NET page, you have the opportunity to either include all of the scripting code for the page in the page itself, or to separate the content into two files, one, the HTML page, and two, the code file. In this demonstration, I'll create a page that includes its own scripting code. I'll start by selecting Website, Add New Item. I'll select Web Form from the Templates list, and I'll create a new file called pagewithcode.aspx, and I'll set the language to Visual C#. Now for this page, I'm going to deselect the option Place Code in Separate File, and click Add. The page is created. With the page in Source View, I'll click into the title element and type in Page with Code, and I'll do the same thing in the div tag inside the form. Notice that the page is created with a set of form elements with the run at attribute set to server, meaning that the page is enabled for server-side processing. Within the div tag, I'll create an h1 tag set. I'll type in less than character than h1, and when I close the tag, the end tag is provided for me. And then once again, I'll type in the text, Page with Code. Now, I'll switch to Design View, and I'm going to add two controls to the page. I'll press Enter to create a new paragraph. Then I'll go to the toolbox, and I'll drag in a label from the Standard section of the toolbox, and I'll place it inside that paragraph that was just created. This is a web form control. Each web form control can have a unique identifier. With the control selected, I'll go to the Properties panel. I'll scroll down to the end and I'll find the ID. And I'll change the ID of the label control to My Label. I type in the ID and then press Enter to save the change. Now, I'll click right after the label in that paragraph and press Enter, and that creates another paragraph. I'll go back to the toolbox, and this time I'll drag in a button control. The button control is essentially a form submit button. When the user clicks it, it causes the page to be posted back to the server, and any server-side code that I want to include in the page will be executed. With the button control selected, I'll go back to the Properties panel, and I'll locate the text property. I'll change the text property of the button to simply click me and press enter. Notice that in the design view on the left, that change is reflected immediately. Now, to make something happen, I'm going to double-click on the control. When I double-click, Visual Web Developer automatically generates a method or a function called button one click. The structure of the function is already appropriately constructed to react to the click event that happens when the user clicks the button. When the user clicks that button, I'm going to react by executing a little bit of server-side code that changes the text property of the label, like this. I'll type in MYL and I'll see my label listed in the list of available objects. I'll press the dot character to autocomplete it, then I'll start typing TEXT for text, and I'll see the text property with an uppercase T listed there. I'll press the spacebar, and then I'll put in an equal sign, which in C# is the assignment operator, and then I'll complete the programming statement with a literal string of value set at server. And then I'll complete the statement with a semicolon. Let's take a look at all of the code and see how it works. I have the function called button1_click. If I scroll down and take a look at the button component, I'll see that it has a run@server attribute, which means that any code that's being executed is executed at the server level rather than in the browser. And then an attribute called onClick, which names the function that's going to be called, button1_click. I'll save my changes, and I'll run the page by selecting Debug, Start Without Debugging. When the page first appears, the label displays its default value of label. I'll click the button, the page is posted back to the server, and when it's returned, the text property of the label is changed to the literal string value set at server. So that's the basic architecture of a web form page. Each web form control that you place on the page has features that can execute certain code at the server level. Not all code is capable of being executed at the ASP.NET server level. There are certain features that must be executed by the browser. Typically, those processes are written in JavaScript code rather than in C# or in Visual Basic. Only the server is able to execute programming instructions in those two languages. It's also important to note that in this particular page, I'm including the scripting code in the page itself rather than in a separate code file. Some developers prefer putting their code together this way. Other developers prefer to create their pages always with separate code files so that they can separate their HTML markup and their scripting code into two distinct files. Each time you create a brand new ASP.NET web form page, you can select either a page with scripting or a page with a code file, and you can make your choice of programming language. In this demonstration, I'll create a page with a separate code file, and this time I'll use Visual Basic. I'm still working in the website Create Pages that I opened previously. From the menu, I'll select Website, Add New Item. I'll select Web Form from the Templates list, and this time I'll set the name as Page with Code File, and set the language to Visual Basic. I'll select the option Place Code in Separate File, and click Add. Because I said I wanted to create a separate code file, Visual Web Developer created both the ASPX file and the associated file pagewithcodefile.aspx.vb. If I rename the primary file, Visual Web Developer will rename the associated code file for me. It also manages this attribute, the code file attribute, which is built into the header of the page. This is how the two files are linked together. Now, I'll go through essentially the same set of steps I did in a previous video. I'll add a title. I'll click into the title element in the head section and type in the text, Page with Code File. I'll click into the div tag section. I'll add an H1 tag set and type in the same text. And then I'll go into Design View. In Design View, I'll press Enter. I'll go to the Toolbox panel and I'll drag in a label control. I'll place it inside the new paragraph. And then I'll go to the Properties panel, scroll down, find the ID property, and change the ID of the label to My Label. I'll then click right after the label control and press Enter. Go to the Toolbox and drag in a button control. With the button selected, I'll change its text property to Click Me, and then I'll double-click on the button control. This time, the event handler function is created using the Visual Basic language and it's created in the separate code file, pagewithcodefile.aspx.vb. As in the previous exercise, I'm going to be executing this code on the server. So I'll execute the following code. I'll type in the beginning of the ID of the control, my label, then press the dot character. Visual Web Developer auto-completes the ID of the control, and then I'll select the text property and press the spacebar, and then I'll put in the equals assignment operator, which is the same for Visual Basic as it is for C#, and I'll type in the text, executed at server. This time I won't put in the semicolon because I'm working in Visual Basic, which doesn't use that character to terminate a statement. I'll go back to the page and save the changes by pressing Ctrl S. Then I'll go to the menu and select Debug, Start Without Debugging. When the page first appears, it displays the initial value of the label control, simply label, and when I click the button, that results in posting the page to the server, and the label control shows the text executed at server. So you're using essentially the same sort of code. The button control dispatches a click event. You react to the click event by executing server-side code, which modifies the values of various other web form controls. What differs between pages is which language you're working in and whether you build your pages using code in the page or using an associated code file. Throughout the rest of this video series, I'll be using pages with associated code files. I prefer to keep my HTML code in one file and my scripting code in a separate file. And I think you'll find that that's the best way to create your own websites. It makes it very easy to know what kind of code you're working with at any given point, and it reduces the amount of scrolling up and down you have to do when you're doing your coding when you need to make changes or fix your bugs. When you build a data entry form using an ASP.NET web form page, you can choose between standard HTML controls and ASP.NET server controls. In this video, I'm going to demonstrate how to create a data entry form using ASP.NET's web form controls, which allow you to react to particular events using server-side code. I'm going to open a file called authorform.aspx that's a part of the Create Pages website. This file contains a simple HTML table with 2 columns and 4 rows. The first 3 rows have labels in the first column, and I'm going to be adding controls to the form, placing them in the second column. If you look at the file in source view, and I'll open it up in full screen view so we can see as much code as possible, you'll see that there's a certain amount of style code up at the top in the head section, and then within the body tag there's a form created by Visual Web Developer when the page was created, and then the HTML table that contains the table rows and table data cells. That's all there is in the file so far. Now, I'll go back to Design View, and I'll get out of full screen view so I can see all of my panels. I'll open up the toolbox on the left and then pin it into place by clicking the little pin icon. That causes the toolbox to be pinned on the left, and then I'll unpin the Solution Explorer and the Properties panel so that I reclaim that visual space over on the right. Now, it'll be easy to drag controls into the environment. I'm going to be using a text box control. This is the ASP.NET server control that's the equivalent of an HTML text input control. I'll drag the text box into place, dropping it into the first row, second column. When you're working in Visual Web Developer's design view, you can easily resize the control just by clicking and dragging. I'll set the text box's width at 200 pixels. Now, I'll go to the Properties view and assign an ID. Down at the bottom of the Properties view, I'll assign the ID as fname input. Now I'll do the same thing for the last name control. So that the controls are exactly the same size, I'll simply copy this control to the clipboard, place the cursor in the second row, second column, and paste. Then I'll select the new control that I've just created, and if you look right above the control, you'll see a visual indicator that the new control's ID was assigned as fname input 0 to distinguish it from the simple fname input. Now, with the control selected, I'll go to the Properties panel, and I'll change the ID of this control from fname input 0 to lname input. I'll create a text box for the date of birth. I'll drag and drop the control, I'll press F4 to go to the Properties panel, and I'll change the ID to DOB for date of birth input. Finally, I'm going to add a button to the form. I created this HTML table originally with 4 rows so that I'd have a place to put the button and make it align right under the other controls. I'll drag an ASP.NET button control into the form, and I'll drop it into the 4th row, 2nd column. Once again, I'll go to the Properties panel. I'll change the text of the control to Submit, and that changes automatically in the design view when I press Enter. I don't need to worry about the ID of the button. I don't care about its data, so I'll just leave it with its default of button 1. So now I'll save and display the form in a browser. I'll press Ctrl S to save, then I'll go to the menu and select Debug, Start Without Debugging. When the form opens on the screen, you'll see that it has 3 controls. The labels and the controls are properly aligned because they're wrapped inside HTML table rows and columns. I'll be able to click into the controls and type values in. But right now, the form isn't really doing anything. When I click the Submit button, the form is submitted to the server, and when it comes back, the controls are still displaying the data that I typed in. That's one of the ways in which the ASP.NET web form controls differ from basic HTML controls. ASP.NET is tracking the data that the user types into the controls, and when the page is returned back from the server, it repopulates the controls for you automatically. If you're curious about how the form is actually constructed in order for the browser to be able to interpret it, you can right-click on the browser and select View Source. That's assuming, of course, that you're using Internet Explorer. If you're using another web browser, the technique for viewing the source will differ. Take a look at the code that's in the page. You'll see that the text box controls that I created in ASP.NET were interpreted as HTML input controls, and their values were automatically populated as the page was returned to the browser when I clicked the Submit button. So that's basically how you create a data entry form. In other videos, I'll show you how to process the data from the form when the user submits it using server-side code. Once you've created a data entry form using ASP.NET Server controls, you can then process those controls using server code written in either Visual Basic or C#. In this demonstration, I'll use a file called usingpostback.aspx that's a part of the Create Pages website. You'll see that it already has a data entry form consisting of 3 text box controls and 1 button. I'm going to use 3 additional controls to echo the data that the user types into the text boxes and display that data on the screen when the form is posted. I'll start by creating a panel container. A panel is an ASP.NET server control that gets translated as a div tag set in the rendered HTML. I'll go to the toolbox, locate the panel, and drag it and place it in the page underneath the HTML table. Now, I'm going to add 3 label controls. Once again, I'll go to the toolbox. To make this a little bit easier, I'll pin the toolbox, and then I'll drag in my first label, and I'll place it within the panel. With the label selected, I'll go to the Properties panel, and I'll change the label control's ID to fname label. Now, I'll click right after the label control inside the panel and press Enter. Notice that the cursor only goes down a single line. When you're within a panel container and you press Enter in Visual Web Developer, it creates a line break or an HTML break tag rather than a paragraph. Now I'll drag in another label and place it under the first. I'll set the ID for this second label to lname label, and then I'll repeat the process, once again clicking after the label control and pressing Enter, dragging in a third label, and I'll set the ID of this label as DOB label. Now, to process the data when the form is posted, there are 2 possible approaches. One is to use the click event of the Submit button. I'll do that in this first demonstration. I'll double-click the Submit button control, and that creates its associated event handler for the click event. The name of the event handler function is button1_click, and Visual Web Developer leaves the cursor inside that function so that I can start to code. Now I'm going to pass the data from each of the web form controls to the associated labels. For the first name, I'll use this code. fname label.text equals fname input.text. Notice that because I'm programming in C#, that I'm always placing a semicolon at the end of the line. I'll unpin the toolbox so I can see more of the code. And now I'll take that line of code and I'll copy it to the clipboard by pressing Ctrl+C. and then I'll paste it in by pressing Ctrl V a couple of times. And I'll modify the second and third line as follows. For the second line, I'll change the ID of the label to lname label, and the ID of the input to lname input. And for the third line, I'll change the label to DOB label, and the input to DOB input. I'll come back to the page, save the changes by pressing Ctrl S, and then select Debug, Start Without Debugging. I'll click into the first name control and type David, the last name, Jones, and I'll pass in a string which is a valid date of 5/1/1960. I'll click the Submit button, and you'll see that the page is sent to the server and then returned to the browser, and the label control text properties are reset to the values that the user typed in. If you look at the source code that was returned to the browser by right-clicking anywhere on the page and selecting View Source, and then you scroll down to the section that's displaying those labels, you'll see that each of the three labels was interpreted as nothing more than an HTML span tag, and the value that the user typed into the form control, that is the text box, was populated into the span tag by ASP.NET. Now, as I mentioned, that's one approach that you can use to handle postback data. Here's a second approach. I'm going to close the text editor that opened up and then close the browser, and then go back to my code file. You can also handle postbacks in the page load function. The page load function automatically loads when the page is loaded into the browser, both for the first time and when it's interpreted during postback. You can determine programmatically at runtime whether the page is being processed as part of a posting to the server by referencing a Boolean property that returns true or false called isPostback. So, for example, if I wanted to move this code from the button one click event into the page load event handler, here's how I'd do it. I'd place the cursor inside the page load function and start with an if statement. Then within a pair of parentheses, I'd check the value of the isPostback property. Then I put in a pair of braces underneath the if clause. And now I'm going to take this code that right now is in the button click event, and I'm going to cut it, and then I'm going to paste it into the conditional if statement so that that code is only processed if the page has been posted to the server. I'll go back to the main page file and press Ctrl S to save the changes. Then once again run the page, starting without debugging. As the page loads the first time, notice that the label controls show their original or default values, simply the word label. But now if I type values in, such as Mike Smith, and a date of some kind, and then I click Submit or press Enter, once again you'll see that the label controls are updated. There's another available approach for getting data out of a server control and displaying that data on the screen using server-side data binding. Data binding is a particular syntax style that allows you to refer to a property of a server control and display or otherwise use that property in another server control. For this demonstration, I'll be using the file using databinding.aspx and its associated code file. Notice that in this version of the file, the panel at the bottom of the page contains three labels named fname label, lname label, and DOB label. I'll select that code and then take a look at it in source view. Notice that it's an ASP panel, a server-side container, that's translated into a div tag, and then the markup that you see is a combination of conventional HTML markup, such as these strong tags with the text first name, and server controls, such as this label control with an ID of fname label. Here's how you implement data binding. You place the cursor inside the attribute that you want to modify, and then you refer to a control and its property wrapped in data binding syntax, which looks like this. You start with a less than character and the percent character, and then a pound sign or a hash mark. And then within those tokens, you put in the expression that refers to the ID of the object and its property whose value you want to pass in. For example, I'd like to display the value of fname input.text. Notice that in this context, you won't get code completion. Visual Web Developer isn't able to provide that information to you, so you just need to make sure that you're spelling the IDs and properties of the objects correctly, and make sure that you're following them exactly because they are case sensitive in this context. Now, I'm going to copy that expression, and I'm going to paste it into the last name version. I'll click into the text attribute for the lname label and paste in. And then I'll change the ID of the object that I'm listening to lname input.text. And I'll do the same thing for the date of birth. And I'll change the input control that I'm listening to for this expression to dob input.text. and I'll save the changes to that file. Now, in order to activate the data binding, you must call a method called databind, which you typically call as the page is loading. So I'm going to go back to Design View, and then I'll double-click anywhere on the page, and that takes me to the page's page load function, which is the event handler function that's triggered as the page is loading. And here's the code that you call within that function. It's very simple. Page.databind. Notice that databind is a method or a function call, and you must put in the parentheses at the end. If you don't put in the parentheses and you try to run the page, you'll see errors. Now I'll return to the page and save the changes, and I'll run the page without debugging. And as the page loads, you'll see that the literal labels toward the bottom of the page are displayed, but the label controls aren't displaying any values. Now I'll type values in. I'll type in a first name of Mary and a last name of Smith, and a date of birth of 5/1/1970. I'll click the Submit button, and there's the result. The data binding expressions are read only because the databind function or method was called. So you can use data binding expressions to pass data from any server-side control to any other server-side control. Once again, all of this is being interpreted as just everyday HTML. If I view the source that's returned back to the browser and scroll down to the bottom of the page, I'll see that the text is being rendered as simple span tags. The IDs of the server controls are intact and are passed to the HTML span elements, but as always, by the time this code gets to the browser, it's just generic hypertext markup language, or HTML. The two primary languages that are used in ASP.NET, Visual Basic.NET and C#, are syntactically very different from each other, but they both use the underlying .NET class library, the set of components that enable your web applications. When you're first learning a programming language, it's useful to have a testing environment, a simple application to which you can add arbitrary code and that displays the results of running that code. In this chapter, I demonstrate how to use critical aspects of the two programming languages. This is what the web form page looks like. It has a heading, a text box, and two buttons labeled Run Code and Clear Console. Let's take a look at the source code. I'll open the code up to full screen by pressing the keyboard shortcut Alt-Shift-Enter. Notice that within the form, there are two panels. A panel is a server-side control that translates as a div tag, so you can easily force content to be stacked one on top of another. Within the first panel, there's a text box with a text mode attribute of multi-line. This allows the text box control to display multiple lines of text. And then within the second panel, there are two buttons with IDs of Run button and Clear button, and they each have an on-click event handler that runs a function. In these pages, the scripting code is in the page, rather than in a separate code file. So the script code goes toward the top, and notice that the script tag has run@= server attribute, meaning that it contains server-side code rather than client-side JavaScript code. Each of the two pages, the C# and the Visual Basic version, have a function called output. The purpose of the output function is to append a value to the current text property of the text box with an ID of output text. Notice that it uses a += operator. This is called the increment operator, and it adds a value to the existing value. And then an expression called environment.newLine is used to add a carriage return line feed combination at the end of the line. So each time the output function is called, it will add the line to the text box and then go down to the next line. In the current version of the C# page, the Run button click function calls this function output and passes in a value of Hello World. And then when the user clicks the Clear button, the text property of the text box is set to a blank string. So that's all the code in our testing environment. Let's give it a try. I'll run the application without debugging. I'll click the Run Code button a few times, and you'll see that each time I click the button, I'm appending a value to the existing text box control's text property. And then when I click Clear Console, that results in clearing the text box. Now, I'm going to be using this page as the base for all of my exercises. So before I leave it, I'm just going to go back to the Run button click function, and I'm going to remove the call to the output function. And this will be the base file that I copy for each exercise. Now, I'll close that file, and I'll press Alt-Shift-Enter again so I can see my panels. And I'll open up the Visual Basic version. Let's take a look at this one in full screen. The markup code in the Visual Basic version is exactly the same. It has the same two panels, the text box and the two buttons. The IDs are the same, and the click events are the same. But notice that the syntax of the scripting code is a little bit different. In Visual Basic, a function that doesn't return a value is called a sub or a subroutine. The subroutine output is marked with protected sub at the beginning and end sub at the end. The code within the function is almost exactly the same as the C# version. The exception is that there's no semicolon at the end of the line. I'm still, however, using environment.newLine to represent a carriage return line feed combination. The run button click event still calls the output function, passes in a text value of hello world, and the clear button click event still sets the text property to a blank string. I'll run this version of the page without debugging. I'll test it by clicking the run code button a few times, and I'll clear the console. Then I'll close the page, and as with the C# version, I'll remove the call to output from the click event so that I can use this as the base page for all of the other exercises in this chapter. So if you don't have access to the exercise files, create your version of this page using the code that I've displayed on the screen, and then for each exercise make a copy of that page so that you can go through that particular exercise. All programming languages support the concept of a variable, a place to hold data in memory during the execution of a bit of programming code. I'm going to describe how to declare variables in both C# and Visual Basic, and talk about data types, how to designate what type of data a particular variable can hold. The .NET framework is strongly typed, meaning that when you declare a variable, you always declare what kind of data it holds. The syntax that you use for this is different between the two languages, C# and Visual Basic, but the concept is the same. I'll start with the file programmingc#.aspx. I'll open the file, and then select File, save programmingc#.aspx as, and I'll name the new file simplevars c#.aspx. Make sure you add the file extension .aspx. Visual Web Developer won't do it for you. When you declare a variable, you can place it either inside a function or outside a function. When you place a variable inside the function, the variable expires, that is, it disappears from memory, when the function is finished executing. In C#, if you want to declare a variable that's local to the function, you place the cursor inside the function. Then you start with the variable's data type. I'll start with string, meaning this is a string variable. And I'll name the variable local var. When you type in the variable at first, you might see a squiggly line as shown on my screen. The squiggly line is an indication of a possible error. I'll move the cursor over the variable name and see the message the variable local var is declared but never used. This is just a warning from the Visual Web Developer editor that it's detected a potential programming problem. If you know you're going to use the variable, you can ignore the error. If you simply want to declare the variable but not use it yet, put in a semicolon. On the other hand, if you want to set the variable's value, continue with an equals operator, and then set its initial value. In this case, I'm setting it to a literal string of my local variable. So when I put in the semicolon at the end of the line, that completes the statement. Now, I'm going to output the value of the variable using the output function, and I'll pass in local var. Notice that Visual Web Developer already knows the name of the variable. So, that's my code. I'll save the changes and run the page. I'll click Run Code, and I'll see the value of my local variable displayed in the text box. I click the button and run the server-side code as many times as I want to, and then I'll clear the console. Now, I'll do the same thing in Visual Basic. I'll open the file programmingvb.aspx, and I'll save it under a new name, selecting File, Save As, and I'll name this file simplevar_vb.aspx. The rules for scoping, that is for variable visibility and lifetime, are the same in both languages. When you declare the variable inside a function, the variable is local to the function and expires when the function is finished. In Visual Basic, you declare this sort of variable using a keyword dim. Dim stands for dimension, and it declares the variable using what's called the default scope. Within a function, the variable is being declared as local to the function. In Visual Basic, you then follow with the variable name. I'll once again name the variable local var, and then you set its data type using the as keyword. I'll put in the word as, and then the data type of string. As with C#, you can now set the initial value of the variable in the same statement, or you can leave the variable for later use. I'll set its initial value once again as my local variable. And then on the next line, I'll output the value of the variable by passing it into the output function. I'll save my changes and run the page, selecting Debug, Start Without Debugging. I'll click the button to run the code, and I'll see that I'm executing the function successfully. Then I'll clear the console, and I'll close the browser. So once again, the rules are the same for the two languages. When you declare the variable within a function, it's local to the function. You use the dim for dimension keyword in Visual Basic, whereas in C#, you simply declare the variable by putting in its data type and then the variable name. You declare data types in either C# or Visual Basic using distinct syntax styles. The underlying data type, however, is the same. The system data type is listed in the left column of this chart. For example, the string value is something called system.string, and it actually represents a class definition in the .NET framework. In C#, you declare the data type using the word string, all lowercase, and in Visual Basic, the word string with an uppercase initial character. Boolean values, which are used to represent true or false values, again, are represented by the class system.boolean. In C#, you declare that data type with bool, all lowercase, and in Visual Basic with the word boolean with an initial uppercase character. There are a number of numeric data types available in the framework. Here are the most commonly used three data types. An integer, defined as a 32-bit integer, is represented in the system as int32, in C# as lowercase int, and in Visual Basic as integer with an uppercase I. A floating number is represented as float in C# and single in VB, and a double number, which has greater precision, is represented in all lowercase in C# and with an initial uppercase character in Visual Basic. There are many other built-in data types in the .NET framework, and each has their equivalent syntax in C# and in Visual Basic. Check the .NET documentation for more complete examples. When you declare a variable, its data type can either be a simple value or a complex object. Simple values include data types like those I showed in a previous video, including strings, booleans, and numeric values. Complex objects are instances of classes. In object-oriented terminology, a class is a definition of a bit of software, and when you create an instance of that class, it's called an object. In this demonstration, I'll show you how to declare an instance of a class or an object in both C# and in Visual Basic, and the particular type of object that I'll use is a date-time value. This is represented as the date-time class, and you use the same class in either language. I'll start with C#. I'll open the page programmingc#.aspx, and then I'll save it as object-c#.aspx. Then I'll place the cursor inside the Run button click function, and I'll first create an instance of the datetime class using the following syntax. I'll start with datetime, and then I'll assign the variable name as dt for datetime. When you instantiate or create an instance of a class, you use the new keyword. This new keyword is used in both Visual Basic and in C#. And then you call a function that has the same name as the class itself. This is known as the constructor method of the class. I'll use datetime, and I'll follow it with an opening and closing parenthesis. Now I'll output the value of the datetime object using my output function. The datetime object is a complex object. For most complex objects, if you want to turn it into a string, you call a function or a method of the class called toString. So I'll pass in dt.toString. I'll save the changes, and I'll run the page. I'll click Run Code, and I'll see the results. Notice that when you create a new instance of the datetime class, it automatically represents the first day of the first month of the first year at midnight. If you want this same object to represent the current date time, the syntax looks a little different. I'll close the browser and return back to the function code. Now I'll create another datetime object, once again setting the data type of datetime, and I'll call this one nowDT. The datetime class has a property called now. This is known as a static property. You refer to it as a member of the class definition itself, rather than as a property of an instance of the class. When you refer to a static property, it looks like this. And notice that the now property is displayed as an available member of the class. The now property is not a function, it's a property, and so you don't put the parentheses at the end. I'll call the output function again, and I'll pass in nowDT dot toString. I'll save the changes and run the page again. I'll click Run Code, and you'll see that the first date time, which was instantiated using the new keyword, represents the default date time, the first month of the first year, and so on, whereas the version of the datetime object that's created from the now property represents the current date time, and you see the date and the time on which I recorded this video. Now I'll do the same thing in Visual Basic. I'll open the page programmingvb.aspx, and I'll save the file as object_vb.aspx. I'll place the cursor inside the Run button click function, and now I'll declare an instance of the datetime class using Visual Basic syntax. I'll start with dim, meaning that it's a variable that's local to the function. I'll put in the as operator, and this time, instead of using datetime, I use the Visual Basic version of this variable, which is simply date. Then the rest of the code looks pretty much the same as in Visual Basic. I'll use the keyword new, and then I'll use date as a method. Then I'll output the value of the DT object. In Visual Basic, you don't need the toString function, so I'll just output DT. And I'll run the page, click the Run Code button, and this time you only see the time. So now, if I'd like the same level of functionality as I had with C#, instead of using the Visual Basic date object, I'll use the underlying .NET Framework object, which in Visual Basic is known by its fully qualified prefix, system.datetime. So, I'll set that as the data type, and I'll call the appropriate constructor function. Then I'll go to the call to the output method, and I'll add dt.toString. I'll save the changes and run the page again, click the Run Code button, and now I'm seeing the same results as I did in C#. I'll follow the same pattern to get the current date and time. I'll type in dim, dt now as system.datetime, and once again I'll use the now property of the datetime class, system.datetime.now. And then I'll output the toString version of that object, dtnow.toString. I'll save my changes and run the page. And you'll see once again that I'm showing the date time on the server at the moment that I run the page. So that's a look at how to use the system.datetime class in either C# or Visual Basic. The .NET Framework contains thousands of class definitions. Once you understand the basic syntax of working in ASP.NET, expanding your ASP.NET programming skills is largely a matter of learning about new classes and how they work in your programming language. Both Visual Basic and C# support the concept of looping, executing a bit of code multiple times depending on a particular condition. I'll demonstrate two kinds of loops, for loops and while loops in both languages, starting in C#. I'll open the file programmingc#.aspx, and then I'll save the file under a new name of loopingc#.aspx. A for loop is a loop that executes multiple times and uses a numeric value so that you can increment the value or decrement it each time through the loop. In C#, you use a for loop by creating the keyword for, and then, starting with an opening parenthesis, you put in 3 expressions separated with semicolons. The first expression declares a variable and sets its initial value. I'll create an integer variable named counter and set its initial value to 1. Then after a semicolon, I put in a Boolean expression. This expression will be evaluated each time through the loop, and as long as it's true, the loop will continue. When the expression is false, the loop will terminate, and the code will jump to after the loop. I'll use the expression counter less than 3. Then finally, after the second semicolon, you say what you want to do each time through the loop. And I'll use an increment operator, the ++ operator, which means add 1 to the current value of that variable. After the for declaration, you put in a pair of braces, and any code that you place between the braces, the code block, will be executed once for each time through the loop. I'll use the output function that I've already created, and I'll output the value, the value of counter is, and then I'll append the value of the variable using the plus operator, which in C# is how you concatenate values together. I'll save and test the page. I'll select Debug, Start Without Debugging. When the page opens, I'll click the Run Code button, and you'll see that I output the value of counter twice. When the value of the variable matches 3, though, the loop is terminated. So that's how you create a for loop. Now let's take a look at how to create a while loop. I'll press Alt-Shift-Enter to expand to full screen so I can see all of the code. I'll place the while loop after the for loop. I'd like to use the same variable, that is the counter variable. But right now, the counter variable is going to expire when the for loop is completed. In the .NET framework, when you declare a variable inside a looping construct, it means that that variable expires when the code block expires. I'll fix this by moving the declaration of the counter variable above the for block. Notice I'm not setting its default value, I'm only declaring it. And then I'll go down to the for block and remove the data type from the variable declaration. Now I'm just using the variable that was already declared, and the variable will still be available after the for loop is complete. I'll move the cursor after the for loop, and I'll put in a while loop. In a while loop, you place a Boolean expression between a pair of parentheses. I'll set my Boolean expression to a value of counter greater than 0, meaning that I'm going to loop as long as counter is at least 1. Then I'll copy and paste the output call. So I'm outputting the value of the counter. And then, this is very important, you are responsible for changing the value of the variable. If you forget the next step, you will have created an infinite loop. That is, there's nothing in the while construct to actually change the value of the expression or the variable. So each time through the loop, I'll use the expression counter minus minus, meaning decrement the value by 1. I'll save the changes, and I'll run the page. When I run the code, I start off in the for loop going up by 1. When I hit the value of 3, the for loop terminates, and then I get into the while loop, and I walk back down the values 3, 2, and 1. So that's looping in C#. Now let's do the same thing in Visual Basic. I'll open the file, programmingvb.aspx. I'll save the file as loopingvb.aspx, and then I'll create the same sort of code. Just as in the C# version, I'll start by declaring the variable. I'll use the dim keyword, and then counter as integer. Now I'll be able to use that variable in both the for loop and in the while loop. Here's the syntax for a Visual Basic for loop. You start off with the keyword for. Notice that the initial character is uppercase in Visual Basic, then the variable name, and then the initial value with the assignment operator, the equal sign. Then you put in the to keyword and indicate how high you want to count. When I press enter, Visual Web Developer automatically puts in the keyword next. In a for loop, you start off with the for declaration and you end with the next declaration. Now I'll call my output function. Once again, I'll start with a literal value, and then I'm going to concatenate the value, which in Visual Basic is done with the ampersand character. So that's the completed for loop. Now I'll do the while loop. The while loop starts off with the keyword while, and I'll use a Boolean expression as in the C# version, where I'm looping as long as the counter is greater than 0. A while loop ends with the construct end while. Now I'll once again copy and paste my output command. I'll select the command, press Ctrl-C, place the cursor within the while loop and press Ctrl-V, and then again, in a while loop, you are responsible for modifying the counter, and in Visual Basic, you can't use those simple increment and decrement operators of plus, plus, and minus, minus. So instead, you say counter equals counter minus 1. So there's your for loop and your while loop in Visual Basic. I'll run the page, selecting Debug, Start Without Debugging. I'll click the Run Code button, and there's the result in Visual Basic. So the capabilities and functionality of the languages is the same, but the syntax that you use is different between Visual Basic and C#. As your ASP.NET web pages become more complex, it's useful to be able to break out functionality into separate subroutines or functions. Once again, both the C# and Visual Basic languages support this feature. I'll describe here how to create a function and how to call it using both languages. I'll start again with C#. I'll open the file programming.c#.aspx, and then I'll save it under a new name, selecting File, Save As, and I'll name the file functions.c#.aspx. When you declare a function in C#, you start with an access modifier. The access modifier determines the availability of the function. If you're placing the function in the same page in which it's called, you can declare it as private if the function should be available from both this page and from any pages that are derived from this page, that is, in object-oriented terms that are subclasses of this page, you should use the access modifier protected. And if you want the function to be callable from anywhere in the application, you can use an access modifier of public. There are other access modifiers available, but those are the three that are typically used most often: private, public, and protected. In this example, I'm going to be calling the function from within the same page, but because I might want to use this page later on as the basis of another page, I'll typically use the access modifier protected. So I start off with the protected keyword. Next, I indicate the data type of a value that the function is going to return. If the function is simply going to take some action but not return a value, you put in the keyword void with a lowercase v. But if the function is going to return a value, you use the data type in this position. I'm going to create a function that returns an integer, so I'll use the int data type. Next, you put in the name of the function, which I'll call add values. In C#, you always put in parentheses at the end of the function name, regardless of whether the function can receive values. This particular function is going to receive two values, or arguments. I'll name them val1 and val2, and I'll data type them both as integers. So I'll use the C# syntax, int, then the name of the variable, val1, then a comma, and the second argument, int again, and val2. And then I'll close the function signature by putting in the closing parenthesis. After the function signature, and within the braces, you put in the code that you want to execute. Because I said that I was going to be returning an integer, I must return a value. And you do that with the return keyword. I'll return the result of this expression, val1 plus val2. Notice that you don't need parentheses around that expression. You can put them in if you prefer. Also notice that the plus operator in C# is used both for mathematical addition and for concatenation of strings, which I've already done in other videos. This is called operator overloading, the reuse of an operator for more than one purpose. So that's my custom function, add values. Now, I'll go up to my testing function, run button click, and I'm going to declare a variable called total, once again an integer. And I'll get its value by calling my add values function. Notice that Visual Web Developer already knows that the function exists and offers it in the list of functions that I can call. And after the cursor is on the function, I'll type in an opening parenthesis. Visual Web Developer auto-completes the function name. And I'll pass in two integer values, 5 and 3, separated by commas. Next, I'll use my output function and display the result. I'll start with a literal string, the total is, and then the plus operator to concatenate the result, and I'll output the value of the variable. I'll save my changes and run the code. I'll click the Run Code button, and I'll see the result, the total is 8. So in C#, when you declare the function, you put in the access modifier, the data type, and the function name. Then you declare the arguments, or the parameters that you can pass into the function, in a comma-delimited list, and each of the parameters gets a data type as well. If your function is declared as returning a value, you must return a value, otherwise the compiler will complain. Now let's do the same thing in Visual Basic. I'll open the file, programming VB, and I'll save it under a new name, and I'll name the new file functions.vb.aspx. In Visual Basic, you declare functions differently depending on whether they're returning a value or not. For functions that are not going to return a value, you declare them using the keyword sub for subroutine. These are the kinds of functions that I'm already using. The output, run button click, and clear button click functions don't return values, they just take certain actions, and so we use the sub keyword. If, on the other hand, you want to create a function that does return a value, you use the keyword function. The access modifier rules are the same as for C#. You can create subroutines and functions that are protected, public, and private. Typically, if you're going to use the function within the current page, you use protected. So I'll start off with the access modifier, protected, and then I'll put in the keyword function. Next, you put in the name of the function. I'll name it add values again. And just as in C#, you declare a list of the values, the arguments that you want to accept in a comma-delimited list. For each argument, you can receive it by reference or by value. There are certain more complex rules that apply to certain data types. In this case, I'm going to be receiving variables by value, which means that if I change the value within the function, it won't affect the value that was passed in. I'll name the argument val1, and I'll declare its data type as integer. So that's the first variable. Now, because the amount of code is going to be fairly wide, I'd like to add code on the next line. In Visual Basic, you can't just go down to the next line like you can in C#. You have to explicitly tell the compiler, I'm continuing on the next line. You do that with the underscore character. I'll declare the second argument, once again saying that I'm receiving the argument by value. I'll pass in the name of the argument, and once again, set up the data type. At the end of the function declaration, you then declare the data type of the value that's going to be returned. I'll use the keyword as, and then integer. So in C#, you declare the data type of the function before the function name. In Visual Basic, you declare it after the function name. When I press enter, Visual Web Developer automatically puts in the ending code for the function, which is the words end function. Now, just as in C#, I'm going to return a value. So I'll put in the return keyword, which is done with uppercase R, and then I'll return the value val1 plus val2. So there's my completed function. I'll go to the run button, click function, and I'll use it. I'll declare a variable named total. I'll set its data type to integer, and then I'll call my function add values, and I'll pass in literal values of 5 and 3. Then I'll output the results using my output function, and once again, I'll combine a literal string, the total is, and then I'll concatenate the total variable using the ampersand. I'll save the changes, and I'll run the page. I'll click the Run Code button, and once again I see the result, the total is 8. So let's review again some differences between C# and Visual Basic. In C#, when you declare a function, it's always a function. The syntax is pretty much the same regardless of whether you're returning a value. If you're not returning a value, you use the void keyword before the function name, and if you are returning a value, you put in the specific data type. In Visual Basic, if you're not returning a value, it's called a sub or a subroutine. And if you are returning a value, it's called a function, and you declare the function's return data type after the function and after the arguments using the as keyword. Regardless of which language you're using, you use the return keyword to return a value, and as always, in C#, you include the semicolon at the end of the line to terminate the statement, and in Visual Basic you don't. Finally, to point out one other very critical bit of difference between Visual Basic and C#, in C#, white space, such as line feeds and tabs, are pretty much ignored. In Visual Basic, the end of line is taken as the end of the statement, unless you explicitly indicate that you're continuing on to the next line using the underscore character, known here as the continuation character. When working with programming, it's useful to be able to see what's going on inside the application at runtime. Visual Web Developer provides a powerful debugger, and the .NET Framework itself provides additional tools, both of which allow you to see what's happening by either adding code to your page or creating what are known as breakpoints. In this video, I'm going to describe the use of tracing, the ability to output information to the web page at runtime. This is a feature of the .NET Framework rather than Visual Web Developer, the tool, and so it's done completely with code. I'll start off with the file loopingc#.aspx. In this file, there's already some code that's doing some looping, with a for loop and a while loop. If you didn't do the previous exercise where this file was created, you can create a new file now using a for loop or a while loop. I'll save this file under a new name, selecting File, Save loopingc#.aspx as, and I'll name the new file tracing.aspx. The concept of tracing will be the same regardless of whether you're working in C# or Visual Basic, so I'll only demonstrate it with a single file. In order to use the tracing capability, you must turn it on first. You can do this either one page at a time, or you can do it globally for your entire website in the web.config file. I'm going to demonstrate turning on tracing for just one file. I'll go up to the top of the file, to the page declaration, and I'll add in an attribute, trace equals true. By default, the tracing capability is turned off. Now, I'll save, and I'll run the page, selecting Debug, Start without debugging. As the page starts up, it displays the code, and then at the bottom of the page, a whole bunch of information is dumped onto the screen. You can find out what's going on as the page is loaded by looking not just at the messages, but also at the timestamps, the numeric values. If, for example, a page is taking a long time to load, you can trace and find out where the time lag is happening by comparing the numeric values. As you scroll down, you'll see a lot of information, including the timing, the tracing, and you'll also see something called the control tree, which shows you what kind of objects are a part of the page. Down toward the bottom, you'll see a listing of different variable types. I describe how to use some of these variable types in other videos in the series. There's the headers collection, which lets you see what kind of information is being sent from the browser to the server, and lots more information. So that's how you turn tracing on. Now let's take a look at how you can use this feature and create your own custom messages. I'll close the browser and return to the page. I'll press Alt-Shift-Enter to go to full screen. And then I'm going to take out the while loop in this version of the page. I only need the for loop to demonstrate this. And within the for loop, I'll place the cursor after the call to the output function, and I'll use this code, trace.write. Trace is the name of a class that's always available to you. As you can see in the pop-up help, the trace.write function receives a number of arguments. The only one that's really required in this context is the string, the first argument. And I'm going to pass in a value which is the same as I'm passing to the output message. The value of counter is, and then I'll append the value of the counter variable. So now I'll be writing to the trace section at the bottom of the page. I'll save my changes, and I'll run the page. When the page first loads, I see the trace information for the initial load. Then I'll click the Run Code page, and I'll see the value of the counter is 1 and 2 in the top section. That output is being handled by my custom output function. But then if I scroll down, I'll see in the trace section the same information. Notice that I see timestamps indicating how long it took to get from one phase of creating the file to the next phase. So once again, if you're having performance problems in a page, the trace functionality is a great way of tracking down where the delay might be happening. As I mentioned, you can also turn tracing on for the entire website. You do this in the web.config file. I won't go through those steps here, but if you do need to turn tracing on for the entire site for some reason, you can do it through a centralized mechanism. Another tool that you can use when you're doing programming in either Visual Basic or C# and you want to see what's going on inside the code is to set breakpoints. A breakpoint is a way of marking a bit of code so that when you hit the breakpoint, the application is suspended for a moment. As long as the breakpoint is active, you can then inspect the values of variables and other aspects of your application state. For this demonstration, I'll start with the file loopingc#.aspx. This file already has the for and the while loops inside the run button click method. I'll save this file under a new name, naming the new version breakpoints.aspx. You can set a breakpoint on any line of code. You can do this in a couple of ways. One approach to creating a breakpoint is to right-click on the line and then select Breakpoint, Insert Breakpoint. You'll see that results in selecting the code and highlighting it. And you'll also see a really large graphic on the left side of the screen in what's called the gutter area right next to the line numbers. You can also set and clear breakpoints just by double-clicking on that area. So I've double-clicked and you'll see that the breakpoint is gone. Then I'll double-click again and you'll see that the breakpoint comes back. Now, when you set a breakpoint, you then have to turn on debugging. By default, an ASP.NET website that's created in Visual Web Developer has debugging turned off. But in order to use the breakpoint and suspend the page as it's running, you have to turn debugging on. You can do this through the web.config file explicitly, or you can get Visual Web Developer to do it for you just by telling Visual Web Developer that you want to debug the page. Here's how you do it. I've already set a breakpoint on the for loop. I'll set one on this line with the while loop as well. So now I'll be hitting the breakpoint right before I output the value of the counter variable in both loops. Now I'll go to the menu and select Debug, and now for the first time I'll select Start Debugging. Visual Web Developer detects that this website is not configured to run in debug mode, so it asks me whether I'd like to modify the web.config file to allow debugging. There's also an important note that before you deploy the website to a production environment, you should turn debugging off. I'll use the default selection to modify the web.config file and click OK. Visual Web Developer also detects whether script debugging is turned on or off. If you want to debug your client-side code, you should turn the script debugging on. Here, though, I'm only debugging server-side code, so I'll say yes, I want to continue debugging. It takes a moment for the page to be rebuilt and then appear in the web browser. The first time you go into debugging in this context, you may see that the web browser doesn't automatically take focus. If that happens, just click the browser icon down on the taskbar. Now, I'll click the Run Code button, and you'll see that I hit the breakpoint in the for loop. The current line that is being suspended is highlighted in yellow, and you'll also see the breakpoint listed over on the left side. Down at the bottom in the Locals panel, you'll see a listing of all available arguments. The counter variable, which was declared inside the function, is listed there with its initial value of 1. Now, to continue executing the code, I'll go to the toolbar and click the Continue button, which is a little arrow pointing to the right. Each time I click, it executes the code until it gets to another breakpoint. And keep your eye down here on the counter variable, and you'll see that each time I click the Continue button, the counter variable is updating. I'll continue again, and now I'm hitting the breakpoint in the while loop, and I'll click it again, one more time, and this time, because I've gotten out of all the loops, I'll see that the browser comes back and shows me the result of the code. Now, I'm going to execute the breakpoint one more time to show you one very important thing. I'll clear the console and then run the code again. I'll continue a couple of times, and you'll see that I've hit the output function twice. I'll press Alt-Tab and switch back to the browser, and show you that the output doesn't appear in the browser because until you've completed executing the entire page, the content doesn't get sent back to the browser. I'll press Alt-Tab again and switch back to Visual Web Developer. I'll click Continue, Continue again, and one more time, and now I come back to the web page in the browser because its code has been completed and all of the response has been sent back to the browser and is being displayed appropriately. So that's basically how you use breakpoints. You place the breakpoint on the line that you want to suspend on while the page is running, and then when you hit the breakpoint, you'll come back to Visual Web Developer and you'll be able to use the Locals panel to inspect the data. There are other debugging panels available as well. The Watch panel allows you to put in arbitrary expressions up to a certain point and see what their values are. And you can also use the call stack, the immediate window, and the output panel, which you see regularly, but which has more detailed information when you're in debug mode. When you're done debugging, just close the browser. And when you come back to Visual Web Developer, it automatically removes those additional panels and shows you the original window layout. As with all good programming languages, both Visual Basic and C# support the ability to add comments to your code. You can use comments to document features in your code that otherwise might not be easy to figure out, or to temporarily block certain code from executing. I'll demonstrate how to add comments in both languages. I'll start with the file loopingc#.aspx. This page already has the functionality to execute a couple of loops, a for loop and a while loop. I'll save the file under a new name, selecting File, Save As, and I'll name the file comments.c#.aspx. You can comment code in C# in one of two ways. You can either use beginning of line comments, which are double slash characters, which prevent code from executing from a certain point of the line to the end of the line, or you can use block comments. A block comment starts with a slash and an asterisk, and ends with an asterisk slash. For example, let's say that you wanted to add a comment above the run button click function to describe what it does. This would be best served as a block comment. So I'll place the cursor above the function, I'll put in a /*, and then I'll type in some comments such as, this function walks up and down a variable. Notice that when I press enter at the end of the line, Visual Web Developer automatically puts in an asterisk. This is a visual trick. If you have a long comment that's a full paragraph, placing the asterisk at the beginning of every line is just a way of visually indicating to the developer that the comment is continuing. But in order to actually complete the comment, you must end with the * character. Notice that Visual Web Developer color codes this sort of comment in black. So that's how you create a block comment. Now here's how you create a beginning of line comment. You can actually do this with a keyboard shortcut. I'm going to select the while loop. And then I'll go to the menu and I'll select Edit, Advanced, and notice that you can comment and uncomment the selection from the menu. I'll comment the selection with the menu choice. And you'll see that when you use the menu choice or its associated keyboard shortcut, you're using beginning of line comments, the / combination. Now to uncomment that same code, I'll press Ctrl-K. Notice at the bottom of the Visual Web Developer interface there's a message. Ctrl+K was pressed, waiting for second key of chord. A chord is a combination of keyboard shortcuts, one after the other. So now I'll press Ctrl-U, and that removes the comments. Ctrl-K, Ctrl-C to add the comments in, Ctrl-K, Ctrl-U to remove them. I'll go ahead and leave them in the final state of this application. I'll save the changes, I'll run the page without debugging, and now when I run the code, I'll only see the output from the for loop. I won't see the output for the while loop because it's commented out. Now I'll do the same thing in Visual Basic. I'll open the file, loopingvb.aspx. I'll save the file, naming the new file commentsvb.aspx. And I'll place the cursor above the function, Run button click. I'll expand to full screen by pressing Alt-Shift-Enter. Now, with Visual Basic, you only get beginning of line comments. There is no block comment. So for each line that I'd like to comment, I start off with a single quote character, and then I type in the comment. Now, if you want to add or remove comments for multiple lines, you can use the same keyboard shortcut that I already demonstrated for C#. I'll select all of the code for the while loop. I'll press Ctrl-K, and notice that Visual Web Developer adds the single quote comment at the beginning of every line. To remove the comment, Ctrl-K, Ctrl-U. And once again, I'll leave those comments in for the ending state of the file. I'll save my changes, and I'll run the page. When the page appears in the browser, I'll run the code, and now I only see the results of the for loop because the while loop is commented out. You're strongly encouraged to comment freely. Use comments to document your code or to temporarily block code from being executed when you're doing your development and testing. As your ASP.NET website expands and includes more pages, you'll find circumstances where you want to reuse code. That is, to create a file that does presentation or executes some kind of logic that you want to reuse on many pages. Candidates for this kind of control include commonly used menus, presentations of images, and anything else that repeats on many pages. For this demonstration, I'll use a beginning website and then click the Design button so you can see what the page looks like. This is the basic design for all pages in the website. There's a graphic banner at the top, a set of hyperlinks below the banner that are the menu, and then a heading 1 for the page title. If you open another of the pages, for example authors.aspx, and look at that file in Design View, you'll see that the top content is exactly the same, the image and the hyperlinks. The heading has the same look and feel, but the details of the text are different. I'd like to be able to take the image presentation, the hyperlinks, and the heading and turn them all into a reusable control that I can then call or implement in all of the pages. When you create user controls, they're going to be created as server controls. That is, they're files just like ASP.NET pages that are processed by the ASP.NET server. It's commonly recommended that when you create these controls, that you place them in a special folder under your website. I've already created that folder in my website. It's called Controls. It already has one file called Header with Props that I'll use in a different video. but for this video, I'm going to create the control from scratch. I'll start by clicking on the folder where I want the control to be placed. Then I'll go to the menu, and I'll select Website, Add New Item. In the list of Visual Studio installed templates, locate Web User Control. When you select that item from the list, you'll see that a name is set by default with a file extension of .ascx. All custom controls have this file extension, and that distinguishes them from pages which have the file extension .aspx. Just like ASP.NET Pages, though, within a control you can select your choice of language, Visual C# or Visual Basic. You can place the scripting code for the control in a separate file if you like. I'm going to keep any scripting code and any HTML markup in the same file. All I'm going to change here is the actual file name of the control I'm creating, and I'm going to name it header.ascx. And I'll click the Add button. And notice that because I had already selected the controls folder, that the file was placed in that folder. Now take a look at the top of the file. The file begins with a control declaration. It has a language attribute indicating which language is being used, C# in this case, and a class name, which you can modify if you like. And because I said that I was going to do everything in a single page, I have a script section with the runAt=server attribute. Any code that I place within that scripting section will be processed by ASP.NET rather than by the browser. Now I'm going to populate the control with some HTML markup. I'll go to the home page default.aspx and I'll look at it in source view. I'll press Alt-Shift-Enter so I can open it up to full screen, and I'm going to select just this content. I'll select the panel that contains the image and the next panel that contains the hyperlinks, and I'm going to cut that content to the clipboard. And I'll save the changes in default.aspx. I'll return to header.ascx, and I'll place the cursor after the scripting section, and I'll paste in that code. Now all of the HTML code that I need to present the image and the hyperlinks for the menu are in the server control. I'll clean up the code a little bit, then I'll press Shift-Tab to unindent the code. Because this code is no longer embedded in a larger HTML page, it doesn't need to be indented. I'll save the changes, and now I'm ready to use the header control in my page. I'll go back to default.aspx, and I'm going to look at the page in Design View, and I'll also press Alt-Shift-Enter again to get out of full screen view. Now, to place the control on the page, I'm going to place the cursor at the beginning of the home page, and I'll press Enter once to create a paragraph up above. Notice that because I had placed the cursor inside an H1 tag, that the new content is also an H1. I'll fix that later. For now, it gives me a large area to drag and drop the control. I'll go to the new control in the Solution Explorer, and I'll drag it and drop it into the heading. You'll see, as a result, that the header appears on the screen. Visual Web Developer is actually rendering what the page will look like, taking into account both the control and the rest of the content. Now I'll do my cleanup. I'll go into Source View, and I'll eliminate the heading 1 that was placed at the top of the page. Here's what the code looks like. UC1:header with a runAt=server attribute. There's some more code up at the top that I'll explain in a separate video. For now, all I'm going to do is run the page. I'll save my changes and select Debug, Start Without Debugging. When the page is rendered on the screen, ASP.NET puts together the main page plus the user control and renders it as a complete web page. You'll now be able to use this control and as many pages as you like to create a common look and feel for the whole website. Once you've created a user control, you can then use it in many pages. There are two basic approaches that you can select from. In one, you explicitly register the control in each page in which you want to use it, and then, using an ASP.NET tag, you display the control. The other approach is to register the control globally for the whole website. Here, I'm going to demonstrate how to register the file locally. As I've shown in another video, you can actually drag and drop a control into a page in Design View, and all of the required code will be generated for you, but it's useful to know how to hand code it where necessary. I'm working with the file authors.aspx, which has the same sort of markup as the default.aspx file I used previously. I'm going to place the cursor after the page declaration, but before the HTML doc type declaration. And I'll make a little bit of extra space. I'll start with a less than character and a % character, and you'll see a list of available declarations appear. I'll go down to the register declaration, and I'll select it, and then press the spacebar. You can register a control either from the source file, which is what we're working with here, or if you're working with pre-compiled code, you can register a control from an assembly and namespace. I'm going to use the source attribute because I'm referring to the control by its source file name. I'll select source, src. I'll put in the equal sign and a quote, and then I'll double-click to select pick URL. Then I'll navigate to the controls folder, and I'll choose my file header.ascx and click OK. Notice that Visual Web Developer sets the source using a tilde before /controls. The expression tilde/ refers to the root of the website. Next, I declare a tag name and a tag prefix. These can be anything I like. I'll press the spacebar and then select tag name, put in the equals and a quote, and I'll set the tag name as header. Then I'll press the spacebar again and select tag prefix, type in the equals and a quote, and I'll set the prefix as UC1 for User Control Folder 1. Notice that after a moment, all of the little squigglies that indicate errors have gone away. This is a visual indicator that says I've coded this correctly. Now I'll go down further in the page, and I'm going to select the tags that present the image and the menu, and I'll delete them by pressing the delete key. Then I'll tab in so that I'm aligning the cursor with the existing code. I'll type in a less than character and type UC, and you'll see that UC1:header is displayed by Visual Web Developer as a possible option. I'll select the item, and I'll also add run@server. That part is critical. If you don't put in the run@server attribute, then when you run the page, your header won't appear because it won't have been processed at the server level. I'll save my changes and test the page. Selecting Debug, Start without debugging. And when the page appears, it once again displays the image and the hyperlinks. I can click to go to the home page and back to the authors page, and in both cases I'm using exactly the same user control, but the details of the page below the control are different. For controls that you're going to use in many pages throughout your website, it's useful to be able to register the control globally so that you don't have to use the register declaration at the top of every page. In order to follow along with this demonstration, you must have already created a file called header.ascx in the controls folder under the website root. Open the file web.config from your website root folder. This is the file that configures your entire website. It has a pages element, which I've already scrolled to at about line 67. Within the pages element, there's a controls element, and then for each custom control that you want to use in your website globally, you put in an add element as a child of controls. I'm going to move the cursor right before the end tag of controls, press enter, move up a line, and then tab in, and then I'll place the new add tag right below the existing ones. I'll type in a less than character and select add, and then I'll select tag prefix. The tag prefix can be anything you like. I'm going to use a tag prefix of simply custom controls. Then set the tag name. The tag name can be anything you like as well. I'm going to use header to match the name of the file in which it's defined. Then finally, just as with the register declaration that you use in the local pages, I'll use a source attribute, src. To indicate that I'm getting the file from a controls folder under the root, I'll start with the tilde character, which you'll find right next to the number 1, pressing the shift key, then a slash, then controls, and then the name of the file, header.ascx. So there's all my code. Let's review it. I have the add element, which I'll align with the other add elements just by pressing the backspace key a couple of times, the tag prefix, the tag name, and the source. I'll clean up the code a little bit, just removing the spaces around the equals operators. They wouldn't hurt anything, but I like the code to look a certain way. And then I'll press Ctrl S to save my changes. Now I'll go to a page, publishers.aspx, which still has the original header content. I've already selected the text starting with the div tag wrapped around the image and the panel wrapped around the menu. And I'll delete it. And then I'll tab in, I'll type in a less than character, and start typing CUS. And you'll see that Visual Web Developer already knows that the header control is available. I'll press enter to select it. I'll press the spacebar, start typing run at, press enter, quote, and then put in server. As with all custom controls, the run at =server attribute is critical. I'll close the tag with a slash and a greater than. I'll save my changes and run the page without debugging. And there's the result. The publisher page now uses the user control. Because I've now registered the control globally, in order to implement this control on all the pages, all I need to do is to select that code, copy it to the clipboard, and then I'll be able to open other pages. For example, I'll go to the authors page, I'll remove the registered declaration from the top, I'll remove the call to the header that uses the special prefix that was created in this page only, I'll place the cursor, and then once again start typing custom controls. I'll make sure to add run@ equals server, and then I'll close the tag. And I'll run the page once again without debugging, and you'll see once again that the user control is working correctly. So once you've created the control and registered it globally in web.config, you can then use it as many times in as many pages as you like. In order to make your code more reusable, it's possible to declare public properties that are members of your user controls, and then set the values of those properties when you use the control in a page. For this demonstration, I'm going to use the existing file, headerwithprops.ascx. This is the same file that I was working on previously under the name header.ascx. Notice that it has two ASP panel components, each resulting in a visual presentation. The first panel has the image, the second one the menu. In the one page that's left in this website that doesn't use the existing control, I still have the existing content, plus I also have an H1, a heading 1, that displays a heading at the top of the page. I'd like to make that presentation a part of the control, but I'd like to make the text within the heading 1 tags dynamic, so I can change it when I use the control in a page. Here are the steps. The first part is to declare a public variable that's a member of the component. You can do this with either C# or Visual Basic. I'm going to demonstrate it in C#, but the code is much the same in VB. I'll declare variables starting off with the access modifier public. Then I'll set the data type, which will be a string, and then the variable name, which I'll call heading. Then, optionally, you can set an initial or default value by adding the equals assignment operator, and then a string that you want to use if a value is not passed in. I'll use a default string of page heading. That way, if I use the control later on, and I've forgotten to set the heading value, I'll see this default value, and it'll remind me I need to set it. Now, to present that value to the user, I'm going to combine some very simple HTML and an ASP.NET expression that outputs the value of the variable to the page. I'll create a pair of heading 1 tags at the bottom of the page. Then I'll add an output expression, starting with less than, %, and the equals operator, and the variable heading. Notice that Visual Web Developer already knows about the property and allows me to select it from the list. So that's the completed control with a public property. I'll save those changes by pressing Ctrl S. Next, I'll register the control globally so that it's available to the entire website. I'll go to my web.config file. This is the file where I've previously registered a control named header. I'm going to select and copy the add element that registered that control. I'll select the line and press Ctrl C, and then clear the selection and press Ctrl V to create a second version of the tag. I'll change the tag name to header with props to match the file in which it's defined. I'll set the source attribute to headerwithprops.ascx to reference the source code file. Then I'll press Ctrl S again, saving this file. Now I'll return to the titles page. I'll select everything starting with the first div tag set, continuing through the ASP panel element, and this time selecting the H1 tag set as well. And I'll delete all that content, because all of this content is part of the control. Now, I'll put in an instance of the control. I'll start with the less than character, and then start typing CU or custom controls. Notice that Visual Web Developer now knows about both controls that have been registered globally in the web.config file. Select the file header with props. I'll add the run@ equals server attribute, and then I'll set the value of that heading property. I'll pass it in as a simple attribute, and I'll set the heading for this particular page as title list. That's it. I'll save the changes, and I'll run the page without debugging. And now, the entire heading of my website is completely reusable. The top image banner, the menu, and the heading. And I'll be able to pass in a different text value into the heading for each page on which I use the control. So that's a basic look at how to create your own user controls, how to make them configurable with public properties, how to register them globally for the whole website, and then how to use these controls on individual web pages, passing values into the properties to customize their behavior and appearance. Designers of ASP.NET websites have access to all of the tools that modern website developers use, such as cascading style sheets, div tags, and other capabilities that are enabled by the modern web browsers such as Internet Explorer and Firefox. In older websites, pages tended to be laid out with HTML tables. You place tables within tables within tables to control layout and positioning of objects on the screen. But there were problems with this approach. Not all browsers interpreted table measurements the same, so a page that would be laid out one way in Internet Explorer might look somewhat different in Firefox. Also, when you use table containership to manage the layout and positioning of elements on the screen, it isn't possible to change that information without really restructuring the tables. And finally, the rules of layout can't easily be shared among multiple pages as they can with cascading style sheets. In modern websites, developers tend to use what we call div tags. A div tag is a block element that describes content that lays out horizontally across the screen. But div tags can also be controlled in terms of their sizing and placement on the screen using cascading style sheet rules. Cascading style sheets, or for short CSS, is used to control visual styles like colors and fonts, placement and positioning, and z-order, which determines which objects overlay each other as the user sees them. When you're building static websites, you declare cascading style sheets in a few different ways. You can place your styles as inline styles, declared within HTML elements like the span tag I show here. The style attribute declares a style rule of color with a value of blue, or FF0000. The result would be that the text within that span would be blue. You can also embed your style rules in a web page using the style tag, as shown next. In this example, a style sheet class called blue items is declared, and then that class is applied to HTML elements with the class attribute. Here's another example of the same class, but this time placed in an external style sheet, and then linked to an HTML page with the link element. Again, these are approaches that are used in static websites. When you work in ASP.NET, there are a number of approaches that you can use. All of the server-side visual controls that generate HTML for delivery to the browser, such as the .NET label control shown here, have a set of properties that equate to cascading style sheet style names. For example, the backcolor property, which is available on many ASP.NET web controls, translates into an HTML style name of background-color. Border color translates to border-color. Font-bold actually represents a style named font-weight with a value of bold. Font italic is really a font style of italic, and so on. You can apply these attributes individually on each instance of an ASP.NET control. At runtime, ASP.NET will generate the appropriate HTML. For example, the label control translates as a span element. The server-side ID that you apply to the label is translated as a client-side ID that can be addressed in JavaScript. In this case, the value of the ID attribute won't change as it translates from server to client. But the names of the properties and how they're rendered does change because it needs to be represented in a form that the browser can understand. As you see here, each of the properties that I applied to my label control is translated into a part of the style setting in the span tag. So this will work, but the problem with this approach is that if you have a number of labels that you all want to look the same, you're going to have to apply the label properties many times. So here's an alternative approach. You can combine client-side cascading style sheet code with server-side ASP.NET declarations. In this example, I've created a CSS class name, myLabels. CSS classes are always prefixed with a dot character. The markup that you see here could be placed either embedded in a page, if it was only used on a single page, within the style element, or it could be placed in an external style sheet file and linked into all pages. Then, the class myLabels would be available throughout the website. Then, for each instance of an ASP.NET control that you want to use the cascading style sheet class, you use the ASP.NET CSS class property, shown in the second code sample at the bottom. The CSS class property in an ASP.NET control translates as an HTML class attribute. So here's the generated code before and after. In the earlier example, I showed that there's a single style attribute that combines all the values of the ASP.NET properties, and in the second example, The CSS class property has been translated as the simple HTML attribute class and given the same value. Between the linking of the cascading style sheet external files into your pages and the use of the CSS class attribute, you'll see that you're combining the best of both worlds. Global implementation of visual design for the whole website using a single external CSS file, plus the use of ASP.NET server controls, which give you dynamic capability both on the client and in the server environment using your choice of programming language. In the remaining videos in this chapter, I'll show you some examples of ways that you can use cascading style sheets both in the raw ASP.NET code and how you can implement that code using Visual Web Developer. The first step in creating a cascading style sheet visual design in an ASP.NET website is to create and attach an external style sheet file. External style sheet files are simple text files that are placed in the website's root folder or in a subfolder of the root. They always have a file extension of .css. The task of actually creating the style sheet file can be done either as pure text, a pure coding exercise, or can be done using Visual Web Developer's tools. I'm going to be working with a website that already has a number of files in it. Go to the Visual Web Developer menu and select File, Open Website. Navigate to the Visual Design folder under Chapter 06 Visual Design and click Open. In this website, there are 4 primary pages. Default.aspx, which is the home page of the website, and then 3 other pages, authors, publishers, and titles. There is a server control called header.ascx, which is used by all 4 pages, which contains a number of hyperlinks wrapped inside ASP panel components. And there's also a beginning style sheet file called styles.css. The styles.css file has selectors for the body, table, and anchor elements, and a pseudo-selector called a:hover that affects anchor tags when the mouse is hovering over them. If you take a look at default.aspx, you'll see that currently the page doesn't have any links to the style sheet file. And if you test the page in the web browser, you'll see that the styles in the styles.css file are not being applied right now. You're seeing the default fonts and colors applied by the browser. So here's how you attach the external style sheet file to a page. Go to default.aspx and look at the page in Design View. Then, over on the left, click on Manage Styles. You'll see when you click the Manage Styles tab that the Manage Styles window slides out from the left. Now, because we'll be using styles extensively, click the pin icon, which will pin the panel open and also adjust the design area so we can see both at the same time. Now, click the Attach Style Sheet link. From there, look in the root folder and you'll find the file styles.css, and click OK. You'll see in Design View that the fonts change immediately, reflecting the settings in the style sheet. Now, try browsing the page again in the browser. Select Debug, Start Without Debugging. Look at the page in the browser and you'll see it has a very different look and feel. The font settings from styles.css have been applied, and if you move the cursor over the anchor tags at the top, you'll see that the menu reflects the a:hover pseudo-selector that was declared in the external style sheet. If you open the other files, publishers.aspx, authors.aspx, and titles.aspx, you'll see that this link has already been created in these other pages, so that from this point onward, any changes that you make in the external style sheet file, styles.css, will be applied to all of the pages in the entire website. Once you've created this link, it makes it very easy to create side-white design settings that are created and defined in CSS and then used in all pages of the website. Once you've declared an external style sheet file and linked it into your pages, you can then start declaring CSS rules and apply them to various parts of your web pages using standard cascading style sheet architectures. In CSS, you can declare what we call selectors. There are 3 types of selectors: tag selectors, class selectors, and ID selectors. Tag selectors apply to all HTML elements of a particular name. Class selectors apply to elements that join a group explicitly using the class attribute, and ID selectors apply only to single elements that have a particular unique ID. I'm going to demonstrate here how to declare a class selector and then add a particular ASP.NET component to that class to adopt the appearance that's defined in the class. I'll be working with the following files. First of all, header.ascx, a custom server control that displays the banner image and also a set of hyperlinks wrapped into a panel. I'm going to be modifying the panel using the external style sheet file that's linked into all pages. And then styles.css, the starting CSS file that was included with this chapter's exercise files. When you open styles.css, you should see something called the CSS outline view appear on the left. Now, if you don't see that view, go to the menu and select Window, Reset Window Layout, and Confirm, and you should see the view appear. The CSS outline view allows you to create brand new style declarations in an external style sheet. It groups the style sheet by elements, or what are known in actual cascading style sheets as tag selectors, classes, and IDs. I'll right-click on any of the elements in the CSS outline view and select Add Style Rule. Here you can add an element or a tag selector. If you pull down the list, you'll see all HTML elements listed. You can create your own class name, or you can specify a particular element ID. I'll choose class name, and I'll type in a class of menu panel. Notice that Visual Web Developer interprets that as a style declaration with a prefix of a period. In cascading style sheets, all CSS class selectors have a period prefix, and then the arbitrary name of the class that you select. I'll click OK, and that actually creates the class selector code in styles.css. Now, if you know your cascading style sheet syntax, you can just fill it in here. But Visual Web Developer will help you create it through a visual interface, a dialog box that will help you build the code if you don't know how to build it yourself. Go to the CSS outline view, click the plus icon next to classes. Go to Menu Panel, right-click, and select Build Style. This takes you into the Modify Style dialog box. Now, I'm going to set a number of properties in different categories. Notice that there are block properties that affect word spacing, letter spacing, and so on, background properties for background colors, and border properties. I'll start here in the border. For the border style, I'll leave the options same for all selected, so that I'll be setting the style for top, bottom, left, and right. And I'll choose a style of solid. Notice that in the preview pane at the bottom, you can see what the style will look like. I look at the border and think that that's a little too thick. So then I'll click under border width, once again leaving same for all selected, type in a number of 1, and then I'll leave the selection of PX there. And when I press the Tab key to tab out of the selector, the preview pane shows me the result, a much thinner border. I'll leave the border color alone, so it will use the browser's default. And I'll go to the box settings. For the box settings, I'm going to set padding for 3 borders. I'll uncheck same for all, and then I'll put a value of 5 pixels into the top, bottom, and left. I'm not concerned about the right border because there's nothing on that side. Then I'll click Position. For the position, I'll put in a width of 250 pixels. So I've set values in 3 categories. I'll review. Here are the border settings, with all border styles and widths set to solid and 1 pixel, the box settings to control paddings for individual borders, and the position settings just to control the width of the container. Take one more look at the preview and the description, and then click OK, and then look at the code that was generated in styles.css. You'll see that Visual Web Developer translated its property names and values into well-formed CSS markup. Press Ctrl S to save your changes. Now return to the file header.ascx. Go to the second ASP panel. This is the one with the ID of menu panel. And then press Enter and a tab character. Press Ctrl Space, type CSS class, and then press Enter. Put in an equals, a quote, and then the name of your new selector, menu panel. Make sure you spell the class name exactly the same as you did in the styles.css file. Press Ctrl S to save your changes. Let's go back and look at styles.css and once again make sure that the class name here matches the class name as declared in the header file. Now we'll test it with our pages. I'll open the file default.aspx. Notice I'm not making any changes in this file. I've centralized all of the code so that the inclusion of the cascading stylesheet file is in the server control and the declaration of what the class means is in the external stylesheet. I'll run the page by pressing Ctrl F5. And notice the new look of the menu bar. That's how it looks on the default page and also on the titles, authors, and publishers pages. You can extend your own sense of visual design now to the entire website, creating your own styles in the external CSS file and then linking into the styles by applying the CSS class in whichever visual controls need those styles. Website developers who are accustomed to using cascading style sheets to affect the appearance of their HTML elements might be used to using ID selectors. An ID selector is a cascading stylesheet selector that applies its properties to only one element of the page, matched by the ID. For example, In the current version of the header control, the panel with an ID of menu panel, which is wrapped around the anchor tags that make up the menu, is identified by the phrase menu panel. I've used the cascading stylesheet class of the same name, but they aren't related to each other. If I wanted to modify this panel, and I wanted to apply it using an ID selector, I would go back to styles.css, and instead of putting a period, I would put in the pound sign. Now I'm talking about the menu panel ID rather than the menu panel class. There's a problem with this approach, though, in ASP.NET that you must know about. When you declare an ASP.NET server control, such as ASP panel, and you place it within a custom control, such as this header control, at runtime, the ID is rewritten using a combination of the ID of the control in the page plus the ID of the element within the control. I'm going to demonstrate this by modifying styles.css to use the pound sign instead of the dot, meaning I'm matching by ID rather than by class. Then I'll go back to the page default.aspx and run it in the browser. Notice that the appearance of the menu, including the border around it, the padding, and so on, that I had declared using the class selector no longer applies. Here's why. I'll right-click anywhere on the page and select View Source. Then I'll scroll down to the generated code for the panel. Here it is. It's a div tag with an ID, and you'll see that the ID consists of the ID of the control instance in the page, which was header 1, and the ID of the control itself within the server control, which was menu panel. And so they're not matching up with each other. I'll close the text editor and the browser, and I'll also show you where the prefix of the ID is coming from the declaration of the ID in the instance of the header control. So if you want to use ID selectors to match up your HTML element IDs with cascading stylesheet rules, here's what you have to do. I'll go back to styles.css, and I'll modify my selector to match what will be generated by .NET, header1 underscore menu panel. I'll save those changes by pressing Ctrl S, go back to the page, and run it again. And this time when the menu appears, I see the styles kick in, including the border and the paddings that I had declared. Now that I'm matching up by ID, I can go back to the header file, and I no longer need the CSS class declaration. I'm matching up the menu selector by a combination of the top-level page's ID as it declares the instance of the server control, plus the ID of the menu panel. The problem with this approach is that you now have to make sure that you're using exactly the same declaration ID in every single page, and if you change it, you'll have differences from one page to another. So therefore, my preference when working with ASP.NET server controls, especially those that are embedded within custom controls, is to use class selectors. These won't be modified at runtime by ASP.NET, so I'll return all these pages to their original settings. I'll put the CSS class attribute back inside the header.ascx file. I'll go back to styles.css and change my selector back to a class selector. I'll save all my changes by selecting File, Save All, go back to the page, and run it one more time without debugging, and see that the design of the pages is still intact. So again, a rule of thumb, when you declare controls within custom controls, and you want to apply cascading style sheets to them on a global basis throughout the website, use cascading style sheet classes rather than IDs for the best long-term maintainability of your website. One of the primary reasons organizations use ASP.NET or other application servers like ColdFusion to host their websites is to allow integration with dynamic data stored in a server-side database. In the videos in this chapter, I'll describe how to use various ASP.NET server controls, including the grid view and others, that know how to bind to server-side data and display that data in dynamically generated HTML. For all of the videos and demonstrations in this chapter, I'll be using a database hosted by SQL Server. In a previous chapter of the video series, I described how to install SQL Server and how to import the database that I'll be using. If you haven't gone through that chapter first and you're following along on your own system, you'll want to go back to that chapter, walk through the installation and configuration process, and make sure that you've set up the bookstore database. If you're not sure whether you've done those steps, go into Visual Web Developer to the Database Explorer panel. In the default Windows setup, you can find the Database Explorer panel in the tabbed region on the right. And then make sure that you have a connection to a database called My Bookstore. The name of the connection will differ depending on the name of your computer. Mine is named David MB Pro, but the name of the database and the name of the connection other than that should look the same. And also make sure that you can see the list of tables. you should see tables named authors, publishers, titles, and users. And again, if you can't see that, make sure you've gone back to the previous chapter and walked through those exercises. If you are seeing the data correctly, then you're ready to open up the website. Go to the menu and select File, Open Website. Choose the folder Dynamic Data under CH07 Dynamic Data and click Open. The Solution Explorer panel should open immediately. Then open the file default.aspx and run the file in the browser by selecting Debug, Start Without Debugging, or pressing Ctrl F5. So this is what the page looks like initially. And if you click on each of the links, you'll see that each of the pages has an item that says what will be shown eventually. Now close the page and return to Visual Web Developer. Close the file default.aspx and then open the file authors.aspx. And look at the page in Design View by clicking the Design button under the Design region. In this demonstration, I'm going to add a grid view control that displays dynamic data from the authors table in the server-side database. I'll place the cursor in the paragraph after the text "This page will show a list of authors," and I'll press Enter to create a new paragraph. Then I'll go back to the Database Explorer panel. I'll locate the authors table, and I'll drag the authors table into the paragraph, making sure to drop it in the rectangular region shown on the screen. It takes just a few moments to display the grid view. Now, I'm going to move the cursor over the handle on the right border of the grid view, and I'll click and drag it out so it's a bit wider. Then I'll go to the paragraph above. I'll click the header that has the name of the tag, P, and that selects the entire paragraph, and then I'll press Delete to delete that content. I'll save my changes by pressing Ctrl S. I'll go to the menu and select Debug, Start Without Debugging, and you'll see that when the page is displayed, I'm retrieving and displaying the data in the grid view. So that's the basics of how you get data from the database server to the page. Now let's look at the code that was generated. Go to Source View, and then select View, Full Screen, or press Shift-Alt-Enter, and take a look at the code that was generated when I dragged and dropped. Within the paragraph tag, you'll first see the grid view control. Critical pieces that you must see are, first of all, run at equals server. This guarantees that it's treated as a server-side control. And then a number of other settings such as auto-generate columns, data key names, and so on. There's a columns element in the middle, each with something called ASP-bound field. Each instance of the ASP-bound field control declares a particular column that will be displayed in the grid view. Below the grid view, you'll see the SQL data source. This is how you define the actual connection. And I'm going to modify the data source, in particular the select command. Notice that the select command, which is shown right here, starts with select AUID and so on. I'm going to scroll sideways to the end. I'll click right after the end of the SQL statement, but within the quotes, and I'll add an order by clause, and then in brackets, I'll add AU_LName, and then a closing bracket. You'll notice in the generated code that all columns are wrapped in these bracket characters. SQL does not require them, but in a condition where a name of a column matches a reserved SQL word, the brackets ensure that this phrase is treated as the column or the table name. Now I'll save the changes, and I'll run the page again, and you'll see that this time the authors are displayed in alphabetical order by last name. Finally, I'll remove one column. You'll see that the author ID is shown on the left, and because that's a primary key column, you don't want to display it. So I'll close the browser and return to the code, and then I'll scroll back up to the grid view, and I'll remove AU_ID from the list of columns. I'll select just that bound field and press Delete. I'll save with Ctrl S and run the page without debugging again. And now I'll see just the columns. Now in other videos in the chapter, I'll show you how to affect the appearance of the grid view and also how to modify the header text that appears at the top of each column. The grid view control implements a number of features that allow you to customize the way your dynamic data is presented on the screen. For this demonstration, I'll use a file from the Dynamic Data website named authors-with-paging.aspx, and then click the Design button at the bottom of the design view so you can see its beginning appearance. In the beginning state of the file, you'll see a grid view. The grid view is displaying 7 columns from the server-side authors table. Now, to configure its behavior, I'll click anywhere on the grid view control. You should see the tab appear above the grid view control, indicating the kind of control, ASP::grid view, and its ID, grid view 1. Then, at the top right corner of the control, you'll see an icon with a right pointing arrow. When you click on this icon, that opens a set of tasks relating to the control. From there, you can configure the control's data source, refresh its schema or the list of columns and data types, edit its columns, and enable paging, sorting, and other features. I'll click on Edit Columns. From this screen, you can add and remove columns to the grid control, and you can configure each column. I'll start with AUL name, the author's last name. I'll click on the item in the selected fields list and then take a look at its properties on the right. If you scroll down to the Data section of the bound field properties, you'll see the Data field property. This value must match the name of the column as it's known when it's retrieved from the server-side database. That's how the data is displayed in the control. But other values in these properties can be set arbitrarily. The header text is one of these. The header text property determines what the user sees at the top of each column. I'll select the text and type in instead, last name. This is friendly text, text that the user can read directly. Within this properties list, each time you make a change, just press the Tab key, and that'll save the change to the underlying code. You'll see that the value you type in is also reflected in the selected fields column on the left. Next, I'll click on AUF name, and I'll set its header text to first name, and press Tab. And then I'll go through and do the same thing for each of the other columns. For all of the other columns, I'm just going to change the first character to an uppercase character, making sure to press the Tab key after each change. If you forget to press the Tab key, in some conditions, Visual Web Developer won't save your changes. After I've changed the header text for all of the columns, I'll click OK, and take a look at the display in Design View. You should see that the names of the columns are reflected in Design View now. I'll save my changes with Ctrl+S, and then run the page without debugging. And you should see that the headers that you selected are displayed correctly. Now I'll close the browser and make some other changes. With the grid view still selected, I'll go back to the task list. And this time I'll choose Auto Format. The Auto Format selection allows you to set a number of visual properties all at the same time, with some predefined schemes. You can select Colorful, Classic, Simple, and so on. I'll choose the Simple scheme, which reflects a background color in the header with a particular foreground color, and then alternating row colors. And then I'll click OK. In Design View, you should immediately see the scheme presented. You'll see the same list of columns you saw before, but now when you start the page in the browser, you'll see that the alternating row colors are implemented for you automatically. Finally, I'll show one other capability of the grid control. I'll once again make sure that I've selected the control, and now I'll go over to the Properties view, and I'll double-click the header of the Properties view to make it a floating panel, and I'll drag it out and resize it so I can see all of the panels of the grid view. One of the features of the grid view is automatic paging, that is, the ability to show only a certain number of records at a time. This is extraordinarily easy to set up. Go to the Paging category in the Properties view, and look for the property Allow Paging, and set it to a value of True. Then go to the page size, which will default to a value of 10, and reduce it to 5. When you type in the value of 5 and then press the Tab key, you should see that the grid view is shrunken down to show only 5 rows in the Design View in the background. Next, click the icon next to Pager Settings. The Pager control is a set of hyperlinks that are generated automatically by the grid view as the user is browsing through the data. By default, the Pager Settings mode is set to numeric, which results in page numbers being displayed wherever you put the pager. If you change the mode from numeric to one of the other modes, for example, next, previous, first, and last, you'll see that the numbers are replaced with caret icons. Or you can also do a combination of these settings, for example, using numeric first and last. You can also position the pager by selecting the position property and setting it to values of bottom, top, or top and bottom. I'll leave the position property set at its initial value of bottom. Then I'll close the Properties view, I'll press Ctrl+S to save my changes, and once again run the page. And the result will be that I see a list of the page numbers displayed below the grid view in the footer region. There are many other configurations that you can use with the grid view control. Explore the documentation and the properties list to see what's available and how you might be able to use this control to display your data. The grid view control, combined with the SQL data source control, can be used to create a very elegant editing interface where the user sees data listed in an HTML table and then can click a hyperlink to open just the selected row for editing. And from there, You can then allow the user to make changes to the data, which will automatically be saved to the server-side database. Most of the code that you need for this is already generated when you drag a grid view control into a page within Visual Web Developer. In this demonstration, I'll show you how to modify the code to turn editing on, and then how to block editing of particular columns. I'll work with the file authorswithediting.aspx, and then look at the file in Design View. You'll see that it has a version of the author's grid view, this time displaying just 3 columns: the last name, first name, and phone number. First, I'll turn editing on the grid view control. I'll click on the grid view control, and then open the list of available tasks. And I'll select Enable Editing. When I select that option, that changes a single property of the grid view control. Then I'll save my changes by pressing Ctrl+S, and I'll run the page in the browser. When the grid view is displayed now, it shows a new column with a hyperlink next to each row. I'll go down to a particular page, let's say page number 2, and I'll click the edit link for the first row currently displayed. And you'll see that that results in opening up the row for editing, displaying text input controls for each of the columns. I'll make certain changes to the columns. For example, I'll change Anne's name and add an E at the end, and then I'll click the update link. That results in saving the data all the way back to the server-side database. I can prove that the data was actually changed by continuing to navigate around in the pages, and you'll see that the updated change has taken or is currently displayed. Now, in certain conditions, you may want to allow editing for one column but not others. When you turn editing on for the entire grid view, by default all columns are editable. You can then go into individual bound fields and turn on a property called Read Only. When you set the Read Only property to true for a particular bound field, and then you click the edit link for a row, the columns marked as Read Only will be displayed as text, rather than displayed with an input control. And then there are some other changes you'll need to make in the underlying definition of the SQL data source object to make it compatible with your changes to the grid view. Close the browser and return to Visual Web Developer. And with the grid view still selected, I'll open the list of available tasks and click Edit Columns. Now let's say that I want the user to be able to edit the phone number, but not the last name or first name. So I'll click the last name field in the list of selected fields, and then I'll go to the Behavior category and locate the Read Only property and change it to true. I'll do the same thing for the first name. I'll click on the field in the list of selected fields, locate the Read Only property, and set it to true. And then I'll click OK. I'll press Ctrl+S to save my changes, and then select Debug, Start Without Debugging to run the page. Now this time, when I click the edit link, you'll see that only the phone number is displayed as an input control. If I cancel, my changes aren't saved. But here's the problem that you'll run into, and I'll show you the solution in a moment. I'll click the edit link, I'll make a small change to the phone number, and then click the update link, and I'll see a big old ASP.NET error displayed on the screen. The problem that you're encountering is shown down here. The message is, cannot insert the value null into column AUL name. The problem that you're running into is that the grid view control passes in what's called a null value, or the absence of a value, into the last name column. You can solve this problem by modifying the structure of the update SQL statement that's being executed when the page is updated. I'll close the browser and return to Visual Web Developer. And then I'll look at the page in source view. And I'll look at it in full screen so I can see as much code as possible. I'll press Alt-Shift-Enter. Now, I'll scroll down to the SQL data source definition. The problem is here in the update command attribute. The update statement is expecting to set the values of all of the columns in the backend database table, but I'm only passing in a value for the phone number, so I'm going to reduce the SQL statement. I'll get rid of the column value pair for AUL name. I'll do the same thing for AUF name and its trailing comma. I'll leave the phone number in, but then I'll place the cursor right before the comma after the phone number. I'll hold down the Shift key and then start cursoring over to select as much of the SQL statement as I need to delete. And I'll finish selecting text right before the keyword where. Then I'll press the delete key. Here's the remaining SQL statement. Update authors set phone equals the phone parameter, where the AUID column equals the AUID parameter. So that's how the update statement will match the structure of the grid view. I'm only going to be passing in that one value, so I don't need to set up the SQL statement to update more than that column. Then I'll go to the Update Parameters section of the SQL data sort definition. And I'll do the same thing, this time for the parameters, which are being filled in automatically from the grid view. I'll remove the AUL name and AUF name parameters, and also remove address, city, state, and zip. I'll leave the phone and the author ID, which are both needed. Now I'll save my changes, and I'll run the page in the browser once again, selecting Debug, Start Without Debugging. I'll click the Edit link. Once again, I'm only able to edit the phone number because I set the other columns as read-only. I'll make a change to the phone number. I'll change it to have a trailing number of 1111. I'll click the Update link, and you'll see that the data is successfully saved to the database on the server and displayed in the updated page. I can now page forward and back through the data display, and you'll see that the data has been saved successfully and is being displayed on the refreshed page. So, to review the steps for setting up an updatable grid view. In Design View, you turn editing on by selecting the task list and selecting Enable Editing. Then, you edit the columns. Set Read Only to True for each column you don't want the user to edit. Then go into Source View and modify the SQL data source definition, modify the SQL statement for updating the table, so it's only affecting the columns that the user is allowed to edit, and then remove the parameters for those columns that are read-only as well. And then you'll be allowing the user to modify the data directly through the grid view with minimal programming on your part. The ASP.NET Framework includes many other visual controls that are data-aware that can be used to display data using a format other than an HTML table. In this demonstration, I'll show you how to use a control called the data list that allows you to create a template for how you want each item in a dataset to be displayed. For this demonstration, I'll use the file publishers.aspx. I'll open the file and show you that it currently doesn't have any data controls in it. There's no SQL data source, and there's no grid view. I'll look at the file in Design View. I'll place the cursor at the end of the line that says this page will show a list of publishers, and I'll press Enter to create a new paragraph. Then I'll go to the Database Explorer, and I'll drag in the Publishers table from the list of tables, and place it within the paragraph. You'll see that that creates both a grid view and an SQL data source. For this demonstration, I don't actually need the grid view, so I'll click on it and then press Delete. The purpose of dragging in the table was to create that SQL data source component that's already populated with the required SQL statements to get the data from the server. Now, I'll take a look at the generated source code. You'll see that the SQL data source component is created within the visual presentation of the page. This really isn't necessary. The SQL data source component doesn't create any visual output. It doesn't actually generate any HTML. The only requirement is that it must be placed within the ASP.NET form that runs at the server. So, I'm going to click on this little tree icon to collapse the SQL data source object. Then I'll click at the beginning and drag down one line, and then I'll cut it to the clipboard by pressing Ctrl X. Then I'll move the cursor below the paragraph, but still within the form. I'll place the cursor at the beginning of the line, and then I'll paste by pressing Ctrl V. You'll see that even though the SQL data source element was collapsed when I cut it to the clipboard, when I paste it in, its code is still intact. I'll go back up to the paragraph tag, and I'm just reformatting the code a little bit to make it a little bit easier to read. Then I'll look in Design View again. So now the SQL data source component, which again doesn't generate any HTML, is placed outside the visual presentation. Now I'm going to add a data list component. I'll go to the toolbox, which I can find through the tabbed interface on the left, and I'll pin the toolbox panel by clicking the push pin icon to make it stay on the screen. Now I'll go to the data category, and I'll select the data list component, and I'll click and drag it, and I'll drop it within the paragraph. When the data list component is first dropped in, it doesn't have any output. It's up to me to select a data source, and then to start creating the template to describe how the list will present its data. I'll go to the list of tasks for the data list component, and I'll pull down the list for Choose Data Source. And you'll see that only one data source is declared, SQL Data Source 1, and I'll select it. Visual Web Developer reacts by creating a default template. It displays labels and data for each column returned in the data source. Let's take a look at the code that was generated. I'll click Source View, and then press Alt-Shift-Enter to look at the source code in full screen, and close the output panel if necessary. The data list control is described with a data source ID of SQL Data Source 1. That's how it's getting its data from the server. And then within a nested item template element, it describes how the data will be displayed. The item template can be a combination of literal text plus ASP.NET Server controls. For each server control, you'll see a text property, and within the text property, a dynamic expression, which consists of the less than characters and percents, and a pound sign at the beginning, which means that this is a data binding expression. And then within the binding expression, you'll see a call to a function called eval, and then within that, you pass in the name of the column whose value you want to present. So within the default template, I have literal strings plus instances of the ASP.NET label control for each column. I'm going to remove the literal string, the label control, and the break tag for the pub ID column. I'll select those 3 lines and then press delete. I'll remove the literal string pub name, and I'll also reduce down to only 1 break tag after the label. The result will be that at runtime, ASP.NET loops over the data that's returned from the database, and it will render 1 copy of this template for each item in the dataset. Now I'll save my changes, go to the menu and select Debug, Start Without Debugging. And you'll see when the page is displayed that it shows the list of publishers. Notice that I never show the user the values of the primary key columns. These columns are used internally to track data and join tables at runtime, but they're values that the user shouldn't have any interest in. Now I'll make one other change to the page. I'll close the browser. I'll go back to Design View. I'll click into the original paragraph with the text, "This page will show a list of publishers." I'll click on the Paragraph tab to select the entire element and press Delete. I'll save my changes again. I'll run the page by selecting Debug, Start Without Debugging, and there's my completed page for now, showing the list of publishers that my bookstore represents. When you present dynamic data on a web page using the grid view or the data list components, you can use formatting expressions to format data such as numbers and date time values. For this demonstration, I'll use the file titles.aspx that's a part of the chapter's exercise files. Let's start off taking a look at the page in Design View. In this page, there's a data list control that's bound to the SQL data source component at the bottom of the page, and the SQL data source component is retrieving data from the server-side database's titles table. Now let's take a look at the source code. You'll see that this version of the item template uses an ASP panel wrapped around a set of labels. Each of the labels is displaying a value from 1 column of the table: the title, the price, and the publication date. Binding expressions are being passed into the text properties of each of the labels. Now, I'll run the page in the browser so we can see the results so far. So in the initial display, we're seeing the title of each item, and then we're seeing the price in raw numeric format, and also the date of publication in raw date format. In this first step, I'm going to show you how to apply formatting expressions in the binding expressions that are displaying that data. I'll close the browser, and I'll go back to the page in Source View. I'll look at the page in full screen, pressing Alt-Shift-Enter. And now, I'll place the cursor inside the eval function for the price. The eval function, and other functions such as the bind function, can take more than a single argument. When you pass in a second argument, you're saying how you want to format the value. Here's the syntax that you use. Put in a comma, and then a pair of quotes. Within the quotes, put in a pair of curly braces. Now, you're going to pass in 2 parts of the expression. The first part indicates which item in the list you want to format. A value of 0 means the item at index 0. In array terms, we're talking about the first item in the array being passed in. Then put in a colon, and then you're going to indicate what kind of formatting you want. For numeric values, a string of F2 means that you want it to be treated as a floating number with 2 characters after the decimal. So again, the 0 before the colon means the first item in the list. Using 0-based array offsets, that means item 0 or item number 1 in human terms. And then after that is the string that indicates how you want to format the value. I'll save my changes and press Ctrl F5, and then show you the result that the numeric value has been formatted with 2 characters after the decimal, regardless of whether the real data has those values. So, for example, a raw number of 20 is displayed as 20.00. So to turn that value into a currency value, I'll go back to the code, I'll place the cursor inside the quotes, but before the curly brace, and I'll just put in a currency symbol, the $sign. I'll save my changes and run the page again. And there's the currency value, fully formatted. Now let's try a similar thing with the date time value, the pub date. The pubDate label has a binding expression with the eval function, and it's outputting the value of the pubDate column for the current data item as a literal string. Once again, I'll place the cursor inside the eval function after the name of the column that I'm outputting, and I'll add a comma, then quote, braces, and a close quote. As with the price, I'll be evaluating the value of the first item in the list, the pubDate. So I'll put in a value of 0, a colon, and for this first example, I'll use an uppercase D. The uppercase D means a long date, and you can see the ASP.NET documentation for other known formats. I'll save my change, and I'll run the page, and you'll see that the date is now displayed as a full date including the day of the week, Wednesday, January 1st, 2003. Now that's not really what I wanted. I wanted the short version of the date, so I'll close the browser, I'll return to the code, and I'll change from an uppercase D to a lowercase d, which in ASP.NET means a short date. I'll run the page again, and now the dynamic dates are displayed in month, day, year format. Now I'm going to apply some visual formatting to the rest of the template. I'll close the browser and return to the code. First, I'll handle the label that's displaying the title. This is the only time that this label is going to be displayed. So this is a circumstance where I'm going to use the properties of the label control. I'll set font bold equals true, and I'll set font italic to true as well. I'll save and run the page, pressing Ctrl S and then Ctrl F5, and now I'm seeing the titles appear as bold and italic. Now the prices are output as simple literal strings. So here I'll just use standard HTML markup. I'll wrap each of the literal strings with the strong element. I'll add that to price, and then I'll do the same thing for published. I'll save the change, and once again I'll run the page pressing Ctrl F5, and now I'm seeing a display that makes a little bit more visual sense. If you want to create additional formatting, you could then create a cascading stylesheet class. Say it was a class named titleDiv, and then you could apply that class to the ASP panel container that's wrapping all of the content. Another thing worth knowing about is that you can add something called an alternating item template. The alternating item template, which is also wrapped inside the data list, determines how every other presentation of data is displayed. So you could create an alternating item template that repeats this output, but for example sets a background color on that panel. So that's a look at how to apply formatting to dynamic data that's retrieved from the server. There are a lot of other options than the simple formatting expressions I show here. And again, if you want some more options, take a look at the ASP.NET documentation for all of the variations in formatting strings that are available. Dynamic websites frequently need a user interface that allows the user to modify the data in the server-side database. Data entry systems on websites typically consist of multiple pages. A list page, which displays the key columns of a particular database table, links from that list page to an insert form, which allows the user to add a new record to the database table, and an update page, which presents the details of a selected record and allows the user to make changes to that data. I'm going to start in this video by showing you how to use a control called the details view. It's similar to a grid view in that it's bound to an SQL data source, which in turn is making queries to a server-side database table, but it's designed to show one record at a time. I'll start with an existing website. Go to the menu and select File, Open Website, and select the folder Data Entry, and click Open. And then start with the file authordetail.aspx. I'll look at the page in Design View. The page currently displays a banner and a set of hyperlinks that are a part of a server-side control called header, and otherwise has just blank space. Before I use the details view, I want to create an SQL data source that points to the particular table I want the user to edit. I'll go to the Database Explorer, and if you're following along and you don't see your list of tables, just open up the database connection, and then click the refresh button if necessary. You should see the list of tables there. Then I'll locate the table I want the user to be able to modify, authors, and I'll drag and drop the table and place it into the blank space in the page. When you drag the table into the page, you get both the SQL data source at the bottom, but also the grid view. I'm not going to use the grid view in this exercise, so I'll press the delete key. That'll delete the grid view, and I'll be left with the SQL data source. Then I'll press the enter key, and that'll create a paragraph above the SQL data source, a place where I can put my new details view control. The details view can be dragged in from the toolbox panel. I'll go to the toolbox tab on the left. I'll move the cursor over the tab to cause the panel to slide out, and then I'll click the push pin icon to pin the toolbox panel and make it possible to see both the toolbox and the page in design view. Now, in the toolbox panel, open up your data category. If you're only seeing the standard category open, close it, and then click the plus icon next to data, and then locate the details view control. Click and drag details view and drop it inside the empty paragraph. When you initially create the details view, it won't be bound to a data source. So, with the task list open, which it should be automatically, go to Choose Data Source, open the list, select SQL Data Source 1, the data source that was just created, and you should see the details view control automatically display all of the columns from the database. If you don't see the columns, try clicking the Refresh Schema link that you'll see on the task list, and then you should definitely see the controls appear. Now, save your changes by pressing Ctrl+S, then go to the menu and select Debug, Start Without Debugging. By default, the Details view will show the details of the first record in the dataset. You'll notice some visual problems. First of all, in the left column where the labels appear, the labels are the same as the actual database column names. Just as with the grid view, you need to modify these values yourself. You'll also notice that the right column, which displays the data, is word wrapping. This is something you can also fix just through setting properties. So close the browser and we'll make those changes. First, I'm going to apply some simple visual formatting. Just as with the grid view, you can use the auto format feature, which applies a set of connected properties to present a particular look and feel. Click the Smart Tasks icon to open the task list, and then select Auto Format. You'll see a number of formats presented. You can click through and select the one that you like. I'm going to choose the simple format and click OK. Now I'll save my changes and once again run the page. And you'll see that the formatting is presented, but once again, I still need to fix my headers and the word wrapping. So I'll close the browser. You can fix the header text either through Visual Web Developer's visual interface or in code. Just as with the grid view, if you want to do it through Visual Web Developer's interface, go to the task list and select Edit Fields. Then, in the Selected Fields list, click on each column that you want to modify, locate the header text value, and update it. I'll type in Author ID. Notice that when I press the Tab key, that the new value is reflected in the field list. If you prefer, you can work in source code. I'll click OK to save those changes. Then, I'll click anywhere on the page to clear the task list, and click the Source button. Then I'll press Alt-Shift-Enter to look at the page in full screen. Then I'll navigate to the bound field list. I'll locate each of the header text properties and modify it. I'll change AU_LName to last name. I'll change AU_FName to delete the text. I'm placing the cursor at the end of the string and then pressing Control backspace. Then I'll type in first name. And then for each of the other columns, I'll just capitalize the initial character. I'll run the page again, and I'll show you that everything seems to be working. Now I'm going to deal with the word wrapping issue. I'll close the browser and then go into Design View. I'll open the task list and once again go to Edit Fields. For each column that I want to prevent from word wrapping, I'll click on the column in the Selected Fields list. Then I'll scroll down to the bottom to the Styles section. I'll go to the item style, scroll down a little bit further, and then I'll change the wrap property from true to false. And I'll do this on each of the columns that I want to prevent from wrapping. Notice that as you move through the columns, the bound field properties list doesn't scroll. This makes it very easy to go through and handle one field at a time. I'll click OK, and then you can also deal with the word wrapping in the labels by going into the header properties, but a simpler approach is simply to make the whole control a little bit wider so that there's plenty of space for those labels. So I'll drag that out to a width of 170 pixels or thereabouts. You don't have to be exact. Then I'll press Ctrl+S and Ctrl+F5 to run the page again. And now I'm seeing that the data isn't word wrapping. If you're still seeing word wrapping in the labels, go back to Edit Fields, go to the fields that have spaces in them, go to Header Style, and change the wrap property to false. I'll only do this on the columns where the header text has a space in the middle. Author ID, first name, and last name. I'll click OK, press Ctrl+S to save, Ctrl+F5 to run, And now when the details view is displayed on the screen, nothing is word wrapping, and the labels and data are displaying cleanly. So that's how you add a details view control to a page and control its formatting and presentation. After creating a page and adding a details view control to it that's bound to an SQL data source, and after applying whatever formatting is needed, you can then use the page to create the insert form that automatically receives data from the user and passes that data back to the server-side database using an SQL statement. For this demonstration, I'll use the file authorinsert.aspx. Open the file now and look at the page in Design View. You'll see that it already has a details view control. And when you run the page in the browser, which I'll do by selecting Debug, Start Without Debugging, you'll see that it's displaying the first row of the dataset. I'll close the browser and then make some changes to the page to turn this into an insert form that the user can type values into. First, I'll modify the header. I'll select the header control in Design View, then go to Source View. By first selecting the item in Design and then going to Source, it results in selecting the matching code when you get to Source View. Then I'll go to full screen so I can see as much code as possible, and close the output panel if necessary. And I'll change the heading attribute of the header control from Author Detail to Insert Author. Then I'll go back to Design View. Now I'll go to the control and I'm going to turn on Insert Capability. I'll click on the control, then click the Smart Tasks icon to open the task list, and I'll select Enable Inserting. When you select the Enable Inserting option, you'll see a new link appears at the bottom of the form labeled New. Save your change pressing Ctrl S, and then run the page in the browser. When you simply turn the insert functionality on, the control automatically adds the new link at the bottom. When you click the link, you'll see that the page is represented, this time only presenting the non-primary key columns. Notice that the author ID is not present now, because that's a value that will be populated by the database when a new record is inserted. The user can now type values in. I'll type in a last name of Aardvark, a first name of Alfred, and then some dummy data for the rest. Make sure that you follow the basic rules of the database, that is, that you don't type in values that are too long for the back-end database columns, and that you do type in a value for each column. So I'll type in an address of 123 Main Street, a city of Smallville, a state of KS, make sure you only type in 2 characters here, and then a numeric zip code of 5 numbers. Then I'll click the Insert link. Watch what happens. I'll come back to the display of the data, but because I haven't done anything to tell the Forms view which record to display, it's displaying still the first item in the database. But to ensure that that actually worked, I'll close the browser. I'll go out of full screen by clicking the full screen button up at the top. I'll go to the Database Explorer, to the Authors table, right-click on Authors, and select Show Table Data. And then I'll scroll down to the bottom of the table and show you that the data was successfully inserted into the database table. So how did all that happen? How is the Details View control passing the data to the data source on the back end? Well, let's take a look at the Source View. I'll go into Source View and then select View, Full Screen, and close the Output View. When I connected the Details View to the SQL data source, which I did through the data source ID, that told the Details View that when it was in insert mode, it should use elements of that data source to actually modify the data in the server. In the SQL data source control, which is down toward the bottom of the code, right down here, there's already an insert command that was created by Visual Web Developer when I dragged the table into the page. You'll see that it has an insert statement that's well-formed, and in the insert statement, there's a list of the columns that need to be inserted, the table name, and also parameters, which are represented by the @ character at the beginning of the string. And then a little further down, a set of insert parameters that define the names and data types of the values that need to be passed in. The Details View already knows how to match all this code together, how to use the insert statement that's modeled in the insert command attribute, and how to pass the values into the parameters from the Details View controls. But you'll notice right now, if you run the page again, that the page is designed to stand on its own, rather than being navigated to from a list control. So I'm going to make one change in the page to conclude this demonstration. I'll go back to Design View and select the control. I'll leave Full Screen View so I can see all of my panels. I'll go to the Properties view and double-click it to make it float, and then I'll move and resize it so I can see more of the properties information. And then I'll locate a property called Default Mode. The Details View control's default mode can be set to one of these values: Read Only, which it's set to automatically when you drag it into the page, Edit, and Insert. If you want this to be a dedicated insert form page, just set the default mode from Read Only to Insert. And you'll immediately see in Design View in the background that the Details View control now presents the form with the text input controls. Now let's test the page again. I'll press Ctrl+S to save and run the page without debugging. Once again, I'll type in some values. I'll type in a last name once again of Aardvark, this time with another value so I can see the difference between the first. And then I'll type in some other values. This time when I click the Insert link, instead of going back to the read-only presentation where I'm seeing the first record in the dataset, I come back now to the actual data entry form and I can start adding another record. And then I'll once again ensure that the data is actually getting to the database table. I'll go to the Database Explorer, locate the table authors, right-click and select Show Table Data, scroll down to the bottom, and show that the record was in fact added. So that's how you create a standalone insert form page. You add the details form, you enable the insert architecture, and then you set the default mode to insert. Now, in another video, I'll show how to take this page and a list page and bind them together so that your data entry workflow is an uninterrupted cycle, going from list control to insert page and back again. In other videos in this chapter, I've described how to use the Details View control to present a data entry form, and then how to insert data into a server-side database from data passed into the control by the user. Now I'm going to describe how to bind together a list page, such as the authors.aspx page I'm showing on the screen, with the insert form, so that the user can link from the list page to the form, and then return to the list page when they finish their task. I'll start in authors.aspx. This file currently shows a list of existing data. I'm going to create a simple hyperlink that takes the user to the author insert page. I'll click right after the table, clicking to the right of the control, and then I'll press Enter to create a new paragraph. And I'll press Enter one more time to push the SQL data source down a line, and then click above the SQL data source into the now empty paragraph. Now I'll go to the Toolbar panel. I'll move the cursor over the tab, and then I'll pin the toolbox, and then I'll locate the hyperlink control, which will be found in the standard category of the toolbox. Then I'll click and drag the hyperlink and drop it into the paragraph. An ASP hyperlink simply generates an anchor tag, and you set its values, that is the text or image it displays, and the URL to which the user will navigate through the control's properties. With that selected, I'll go to the Properties panel. I'll double-click on the Properties panel header to make it float, and then I'll drag it out so I can see the properties more easily. Notice that the default text is hyperlink. I'll change that to Add New Author. And when I press Enter or Tab, I'll see that new text reflected in the design view. Now, I'll indicate which page I want the user to navigate to. I'll go to the Navigate URL property, and I'll click into the text input next to the name. Notice I then see a triple dot button, which allows me to browse for a target page. I'll click the button, and I'll select the file authorinsert.aspx. Then I'll click OK. Notice that Visual Web Developer uses the syntax starting with the tilde character, which stands for the root folder of the website, then the slash, and then the name of the page. So now I'll test my hyperlink. I'll press Ctrl+S to save the file, and Ctrl+F5 to run it in the browser. When the author's page appears, it shows the new link. I'll move the cursor over the link and click, and I'm taken to the insert page. Now, I'll describe how to handle navigating from the insert form back to the list page. I'll close the browser and then switch to the file authorinsert.aspx. This is the same authorinsert.aspx that I used in another video of this chapter. If you didn't work through the previous video that described how to create the insert form, you'll want to do that first before going through these next steps. The insert form in its current state uses a details view to present text input controls for each column. The user types values into the column and then clicks the insert link. By default, the page simply reloads. I'm going to handle an event that occurs after the data has been inserted into the database, and I'll react to that event by redirecting the browser back to the list of data. This page was originally created with a code file. The name of the code file is authorinsert.aspx.cs. I'll go to that file and I'll add a new function. I'm doing this work in C#. If you're doing your own work in Visual Basic, you'll need to translate this code into the appropriate syntax. but the basic architecture is the same. I'll create a function with a protected access modifier, and then a return type of void. I'll name the function detailView_itemInsert. I'm going to press Alt-Shift-Enter to open to full screen so I can see as much code as possible, and then I'll scroll back over so I can see the beginning of the function. Now I'll complete the function signature. I'll put in an opening parenthesis, and then the first item that will be passed in will be an object which I'll name sender, and an event handler function like this, the sender argument is a reference to the object that actually generated the event, like the detail view. And then I'll pass in something known as an event object. The event object contains information about the event that just occurred, and in this particular event that I'll be working with, which is the item inserted event, the data type of the event object is detailsView inserted event args. So I'll put in the data type, detailsView inserted event args, and then I'll set the name of the event object as simply E for event. Now I'll put in the pair of braces. When this event occurs, the event object will have a property called affected rows. It's a numeric property, and if the insert statement succeeded, it will have a value of 1. So I'll ask the question, if e.affectedRows equals 1. This means if one row was affected in the database, and then I'm going to take that as a condition of success. I'll put in a pair of braces, and within the braces, I'll respond to that condition by calling this code. Response.redirect, and I'll pass in the location of the file I want the user to go to, authors.aspx. Notice that I'm ending the statement with a semicolon because I'm working in C#. Now, to make this function happen, I'm going to select and then copy just the name of the function to the clipboard. Then I'll go back to the page, author_insert.aspx, and I'll look at this file in source view. I'll scroll up to the Details View Controls Begin tag and place the cursor right inside the closing angle bracket. I'll press Enter, and then I'll put in an event handler attribute, which looks like this, onItemInserted. This is the name of the attribute which causes the function to be called when this event occurs. I'll put in the equals and the quote, and then I'll press Ctrl V to paste in the name of the function, and then close the statement with a closing quote. Notice that I don't have to put in the parentheses or actually call the function. The Details View object will call the function for me, and it will call it using the signature, or the number and data types of the arguments that I defined. I'll save all my changes by selecting File, Save All. Then I'll test the page. I'll select Debug, Start Without Debugging, and I'm going to type in some values. When I click the Insert link, the data is inserted into the database, and as you can see on the screen, the new data has been successfully added. Now, I'll also put in code to handle the event that occurs when the user clicks the Cancel link. I'll return back to the file authorinsert.aspx.cs, and I'll move the cursor down below the existing functions and press Enter. When the user clicks either of the links, another event called item command occurs. As before, I'll create a new function, starting with protected void, and I'll name this function detailView_itemCommand. As before, the first argument will be an object, which I'll name sender, and the event object passed in as the second argument, this time will have a data type of detailsViewCommandEventArgs. I'll select the appropriate type and give it a name of E. Then put in a pair of braces. Within the braces, I'm going to ask which link was clicked, and specifically, I'll check whether the user clicked the cancel link using this syntax. If e.commandName double equals, and then the string cancel. Then I'll put in a pair of braces, and within the conditional clause, I'll once again use the same redirect command. I'll just copy and paste it from the previous function. I'll select the code response.redirect authors.aspx, press Ctrl C to copy, click into my new conditional clause, and press Ctrl V to paste. Now, as before, I'll select and copy the name of the function that I just created. I'll save the changes to this file by pressing Ctrl S. I'll return back to authorinsert.aspx, and I'll add another event handler attribute. This one will be onItemCommand. I'll start off by typing on, then press Ctrl space to bring up a list of events, and then I'll keep on typing until I find the event I'm looking for, onItemCommand. Then I'll put in the equals character, that auto-completes the name of the attribute, put in the quote, press Ctrl-V to paste, and put in the closing quote. Once again, I'm simply naming the function that I want to be called when the event occurs. I'll save my changes. I'll return back to the list page and test the whole thing. I'll run the list page, authors.aspx. I'll click Add New Author, and this time I'll click the Cancel link, and that takes me back to the author list. So now I have a complete system for adding new data. The user clicks the Add New Author link from the list. That takes them to the form. If they type values into the form and click Insert, that adds the data to the server-side database and returns to the list. Or if they click the Cancel link, they return to the list without inserting the data into the server-side database. Websites with data entry systems can also use update forms. An update form queries the database on the server, filtering the data to retrieve just a single record, presents that data in a form, in this case presented with the Details View control, and then when the user has filled in the new data and clicked the appropriate link, the new data is sent back to the server in an update statement. You can also integrate update forms with the rest of the data entry system by linking to the form from a list page. For this demonstration, I'll be working with the file authorupdate.aspx. It begins where another video left off, using a Details View control which is currently configured for inserting data. I'll start by clicking on the control and opening its Smart Tasks list. Now, I'll disable inserting, and then instead I'll select the option Enable Editing. Then, with the control still selected, I'll press F4 to go to the Properties view. In the Properties view, which I configured as a floating panel, I'll go to the Default Mode property and change it from Insert to Edit. Notice that the default appearance of the form changes. Now, it shows the primary key, but as a read-only value only, and also displays links at the bottom for updating and canceling the data. The next step is to modify the SQL data source component so that it retrieves only one record from the server-side database and filters for that record based on a primary key value. I'll close the Properties view and then look at the file in Source view. I'm going to go down to the declaration of the SQL data source component. I'll press Alt-Shift-Enter to go into full screen mode, and then I'll take a look at the code for the select command. The select command is the command that retrieves data from the database on the server. The default select command that's created when you drag a table into a page selects all the data from the table. In this case, all of the data is being retrieved from the authors table. I'll place the cursor at the end of the SQL statement and add a filtering expression, where, and then the name of the column, AU_ID wrapped in brackets, and then an equals operator and the name of a parameter, starting with the @ character and then AU_ID. So I've created a filtering clause as part of the select statement. Now I need to tell the SQL data source object where to get the value for that parameter. To do that, I'll place the cursor after the begin tag and before the existing parameters. In fact, I can delete some of these parameters. The delete and insert parameters won't be used in this page at any point. I will be using the update parameters, so I'll leave those in place. Then, above the update parameters, I'll create a new set of parameters called select parameters. I'll type in the less than character, and then choose select parameters from the list, then put in the closing tag character, and you'll see Visual Web Developer completes the tag with an end tag. I'll press Enter a couple of times. Next, I need to indicate where the value of that parameter will come from. I'll start with ASP:, and then I'll select a query string parameter. This means that I'll be getting the value from a parameter passed in as part of the URL of the page. I'll select ASP:, query string parameter. Then I'll set the name attribute to match the name of the attribute in my SQL statement. Name equals AU_ID, wrapped in quotes. Next, I need to tell the command what the name of the query string parameter will be that's passed in with the URL. So I'll add the following property. Query string field equals, once again, AU_ID. Now, the only reason I know that's the name of the parameter is because I'm going to be creating it in the last step of the exercise. And finally, I add the type attribute, which is used to indicate what the implied data type of the value is. And I'll put in int32, matching the data type that's used in other parameters for this same column. And then I'll close the tag with / and the greater than. So I've modified the select command to include the where clause. I've used a parameter for the filter value, and then I've filled in the parameter from a value passed in with the URL, known here as the query string parameter. I'll save and test the page. When I first run the page, it shows up with no data. That's because when I run the page, the URL does not include the query string parameter that I'm requesting. I'll place the cursor in the web browser's URL field, and then at the end of the page, I'll add a question mark, and then the query parameter AU_ID, and I'll pass in a value of 2, meaning that I want to see the values for author number 2. And you'll see that when the form comes up, it shows the details for that record. I'll click up here again, and I'll change it to a value of author ID number 3, and I'll see another record show up. Now I'll go take a look at author ID number 1, Marjorie Green, and I'm going to change Marjorie Green to Marjorie Brown, and click Update. And then I'll go through the author list until I find the record and show that it's been successfully updated. There's one more thing to know about how this page is working. In the page's starting state, it had a code file that already had an event handler function called detailViewItemUpdate. The code for this function checks the affected row's property of the event object for a value of 1, and if it equals 1, it redirects back to the author's page. This matches the kind of code that was used in the insert operation that I previously demonstrated. And back in the page, if I look at the details view control, I'll see that there's an onItemUpdate event handler that's calling that function. So the structure of the details view control used for updating and the one that's used for inserting are pretty much the same. They're both using the event handlers for the updated or the inserted events, depending on which operation is being used, and they're both using the item command event to react to a click on the cancel button. So that's how you create the form. In the final step, which I'll show in the next video, I'll show you how to get to this form page from the list page and pass the query string property when the user clicks on a link or a button. When you create an ASP.NET page that's dedicated to updating records, you need to pass a query string parameter to the page as it's loaded to indicate which record you want to edit. In the video where I created authorupdate.aspx, I modified the select command for the SQL data source. I set up the select command to receive a parameter which would be used in a where clause, shown right here. The parameter has a name of AU_ID, matching the database column name on the server. And then I added a select parameters element to the SQL data source and indicated that I wanted to get that parameter from the query string using the query string parameter tag. I set the name attribute to AUID to match the name of the parameter in the SQL statement, and the query string field to AUID. Now I'll show you how to pass that value from the list page, so the user can click a button and get to the page easily. I'll go to the file authors.aspx. This is the list page that displays the existing data from the authors table. I'll click on the grid view control and then open its task list. From there, I'll click on Add New Column. I'm going to add a column that generates a hyperlink. You can actually create either a hyperlink or an actual button. They both work pretty much the same way. From the field type, I'll select Hyperlink Field. The header text can be left blank. I don't need anything at the top of the column. But then, in the Specify Text input, I'll type in Edit. That's what the user will see. Next, I'll indicate that I want to construct the URL to which the user will navigate using a data field. I'll click into the first input and type in the name of the primary key column, AU_ID. Because it's a primary key, its value will be used to uniquely identify the row the user has selected. Then I'll pass in the URL format string. I'll start with the tilde and a slash to indicate I'm starting at the website root, and then I'll type in the name of the update page, authorupdate.aspx. I'll follow that with the question mark to indicate that I'm starting the query string or the list of parameters. Then I'll put in AU_ID as the name of the parameter, an equals operator, and then brace to indicate that I want to take the value of the first data field I list in that string and pass it in this position. I'll click OK and show that the edit hyperlink is shown in display view. I'll press Ctrl S to save and Ctrl F5 to run the page. Now I can click the edit link for any of these records. I'll choose the third one, Andy Arf. That takes me to the edit form and displays the data for that single record. I'll change Andy's first name from Andy to Andrew, click the update link, and then when I return to the author list, I'll show that the data has been successfully updated. Once again, you don't have to use a hyperlink. You can also use a button control in that position. The architecture is pretty much the same, but because I'm using hyperlinks throughout the rest of the website, I've chosen a hyperlink for this purpose as well. Now, I'll show you the generated code. I'll close the browser and return to Visual Web Developer. go to the declaration of the grid view control, and show that the hyperlink was created with a control called ASP:hyperlink field, shown here. Notice that the property data navigate URL fields lists the fields that are being passed in, and then the property data navigate URL format string indicates how the URL will be built. That's shown right here. And finally, the text property indicates what the user sees. So that's how you bind the whole data entry system together. The user starts at the author list. From there, they can click the Add New Author link. That takes them to the insert page. They can then insert a record, or they can click the Edit link, and from there they can go to the Update page and modify existing data. Either way, at the end of the operation, they always return back to the list page. The final task in a data entry system is to give the user a way to delete records from the server-side database. The grid view control gives you a very easy way to do this, simply by enabling the delete functionality. I'll be working with the file authors.aspx. In this file, there's already a grid view control, which is bound to the SQL data source control at the bottom of the page. The SQL data source was created with a delete command with a parameter that allows the delete command to be filtered on a single record's primary key. To turn on delete functionality, I'll go into Design View first. I'll select the grid view and then open its task list. And I'll select Enable Deleting. This results in creating a delete column on the left side of the grid view. Now, I'm going to edit the columns so I can group the edit link and the delete link together. I'll click Edit Columns. I'll go to the Selected Fields list and choose Delete. And then I'll click the down arrow a number of times until it's the last item in the fields list. So now the user will see the Edit Hyperlink column and then the delete link. I'll click OK, and then I'll test the page in the browser, selecting Debug, Start Without Debugging. With the addition of the delete link, you'll now see that the columns are a little bit squeezed and text is starting to word wrap. You can solve this in one of two ways. You can either go to individual columns and edit their properties and set their wrap properties to false, or you can decide that on a list page, you don't really need to display all this detail. I'll close the browser. I'll go to the task list for the grid view control and click Edit Columns. And then I'll go to the selected fields and I'll remove a few of these items. I'll remove the address, the city, the state, and the zip, leaving only the last name, first name, and phone number. I'll click OK. I'll save my changes by pressing Ctrl+S, and then I'll run the page again. And now the user is only seeing those critical columns that allow them to identify the rows and get a bit of critical information such as the phone number. All of the other functionality will still work. I can click into an item and see its details in the Update page, and cancel to return to the list. But I can now click the Delete link, and that row will be deleted. And when the page refreshes, it shows that the data has been removed from the server-side database. So edit links and delete links are now placed in the rows that they're going to affect, and the link to add a new author has been placed below the list control because that takes the user to the Insert Author page. Your data entry system is now complete. In ASP.NET websites that include data entry forms, it's useful to be able to validate form entry. When users type values into data entry forms, you can use ASP.NET validator controls that are bound to the data entry form controls. You can then set custom rules on these validator controls and cause error messages to be displayed without extensive programming. For the demonstrations in this chapter, I'll use a website that's a part of the exercise files. If you have access to the exercise files, select File, Open Website. Go to the Validation folder under ch09 Validation and open it. Then open the file titleinsert.aspx. In the starting version of this page, there's a Details View control that's bound to an SQL data source. There are 4 fields that are being accepted in the form right now: the title, price, publication date, and notes. I'll run the page in the browser, and I'll type some values into the controls and show you what can go wrong. I'll click into the title and type any value, a title, and then I'll type a non-numeric value in as the price, just XYZ, and I'll do the same thing for the pub date. And I'll click the Insert link. And in response, I get a server error. The key error here is at the top. There's an attempt to take a string and format it as a number. And because I, as the user, didn't type in a numeric value, the page fails. So to prevent that issue from happening, we need to capture the problem before the data is sent to the server. In web environments, validation is handled in 2 possible ways, either with client-side validation or server-side validation. In server-side validation, data is sent to the server, and then logic is applied to the data at the server level, and then if there's a problem, an error message is sent back to the web page where it's refreshed. In client-side validation, the validation logic is handled entirely by the client. That's the kind of validation that's used in ASP.NET. Before you can apply validators in a details view control, you first have to replace any instances of the bound field component with template fields. A template field allows you to apply your own specific controls, including text boxes, pull-down lists, and most importantly here, the validator controls. I'll prepare the form for validation like this. I'll select the details view control. Then I'll open the task list and select Edit Fields. I'm going to validate two controls, the price and the publication date. First, I'll click on the price in the selected fields list and I'll delete it. And then I'll do the same thing for the pub date. Now, I'll add two template fields. I'll go to the available fields list at the top. I'll choose Template Field and click Add. For the first template field, I'll then go to Header Text and put in the old header text for the price field of Price. Then I'll click on the item again and click the up arrow a couple of times to move it back up into place. Then I'll do the same thing for the pub date. I'll add a new template field. I'll set its header text to match the old one. And then I'll move it back up into place so that my selected fields are in the same order. Then I'll click OK. You'll see in the Details View control presented in Design View that there are no longer text boxes in the data entry form. I have to replace those now with explicit templating. So the next step is to go into Source View and start to code. I'll click on the Source button and then press Alt-Shift-Enter to go into full screen. And then I'll locate my new template fields. Here's the first one. Notice that the template field is created with a pair of tags. Place the cursor between the tags and press Enter a couple of times to make some space. Within the template field, I'll declare an Edit Item Template as a pair of tags. This is the template that will be presented when the Details View control is in edit mode. Now, within the Edit Item Template, I'll declare an ASP text box. I'll give it an ID matching the ID of the old bound field and also matching the name of the database column on the server, Price. I'll put in the essential run@server attribute, and then, just in case this form is going to be used to present existing data, I'll add a text attribute, and I'll use this binding expression. I'll start off with a less than and a %, and then within the tokens a £, and then a call to the bind function. And within the bind function, I'll pass in the name of the database column, Price. Finally, at the end of the text box, I'll close the tag. Now, I'll save and run the page again. I'll select Debug, Start Without Debugging, and when the data entry form opens, I'll see my new text box, which is a part of the editing template. Now I'll go back to the code and do the same thing for the publication date. I'll select the Edit Item Template that I created for the price, and then I'll copy that to the clipboard. The code will be almost exactly the same for the pub date. I'll click into the tags for the template field for the pub date. Then I'll go to the new version of the text box control, and I'll set both the ID and the database column name in the bind function to the original name of the column, pub date. Now, I'll save and fully test the page. I'll press Ctrl+S to save, and then run the page, and then I'll type in some values. The title will be My New Book. I'll type in a numeric value this time of 15, a well-formed date of 3/1/2009, and some notes. Then I'll click the Insert link. You'll see that the form is simply refreshed with new blank values. Now, I'll go to the Database Explorer. I'll go back to Visual Web Developer and exit full screen. Go to the Database Explorer, open the Tables list, right-click on the Titles table and select Show Table Data, scroll down to the bottom of the data, and show that my new record was successfully inserted. So all this is in preparation for validation. Before you can apply validator controls to a data entry form that's presented within a Details View component, you must modify your Details View to use the template field instead of the bound field for any controls that you want to validate. Once you've modified a Details View control to use template fields instead of bound fields, you're then ready to add validator controls. Each validator control is bound to a single form control, and each form control can be validated by one or more validators. You place the validator controls in the same template fields that host the text boxes or other data entry form controls that the user interacts with to provide data. For this demonstration, I'll work with a page named Title Insert Validation.aspx. In this version of the page, there are two template fields, one for the price and the other for the pub date columns. They each have a text box control that allows the user to type in values, but currently neither is validated. I'm going to show you how to add validator controls both in Design View and through code. I'll start off in Design View. In Design View, I'll select the Details View control. I'll open its task list and select Edit Templates. I'll pull down the template list and show you that there are two sets of templates for each of the two fields that are using template fields. Each template field supports an item template for displaying data, an alternating item template that allows you to set up, say, alternating background colors, and then this one, the Edit Item template. The Edit Item template is the one that's used by default for either inserts or updates. I'll select that item for the price field, and I'll show you visually that it's showing the text box control that's already part of the template. Now I'll add the validator. I'll get out of full screen so I can see all of my panels. Then I'll go to the Toolbox panel. I'll move the cursor over the Toolbox tab and then pin the Toolbox panel into place. The validator controls are in a category labeled Validation. There are a number of validators you can choose from. I'm going to be using the Required Field Validator and the Range Validator. The first rule I'm going to implement will say that the price is required. I'll drag a Required Field Validator object, and I'll place it inside the template. Then, with the Required Field Validator object selected, I'll go to the Properties panel. I'm going to double-click the Properties panel header to make it float, and then I'll drag it out so that it's wider and easier to read. There are two critical properties that you should set. First, the Control to Validate property gets set to the ID of the form control you want to validate. If you're working in the Properties panel, you can click into the Control to Validate property and then pull down the list, and you should see the only form control that's in the template. I'm selecting the Price field. Then go to the error message. The error message defaults to the type of control, Required Field Validator, but should be customized, and this is the error message that the user will see if they break the validator rules. I'll set the error message to Price is required. Now, I'll save the changes and let's see the behavior. I'll run the page in the browser, and in the browser, I'll simply click the Insert link in the Details View control. It's a little hard to see, but the actual message, Price is required, is being displayed right under the control. I'll show you how to fix the visual problems in just a moment. But let's add a couple more validators. I'll close the Properties panel so I can return to Design View, and then I'll press Enter to move down to the next line, and I'll also add a Range Validator. A Range Validator can be used to specify a particular data type, dates, numeric values, and so on. And you can also set minimum and maximum values that the user is allowed to type in. With the Range Validator selected, I'll press the F4 key to bring back the Properties panel. I'll go to the Control to Validate. I'll bind it to the same form control as before, Price, and I'll set a different error message. This time, the error message is, Price must be between 1 and 100. Next, I'll implement the actual business rules. I'll scroll down a bit to the Type property, and I'll set the type to a double. Set it to integer for whole numbers or double for fractional numbers, such as a price. And then I'll set minimum and maximum values. I'll click into the minimum value and set it to 1, and the maximum value and set it to 100. I'll save my changes, and I'll run the page again. And you'll see a lot of extra space here. I'll show you how to fix that a little bit later. But now I'll simply click the Insert button, and the message Price is required is displayed. And then I'll fill in a value that's non-numeric and click the Insert link again, and this time I see the error message, Price must be between 1 and 100. So that's how you set up the validators in Design View. Now to do the same thing in Source View, if you prefer, I'll show that I'm going to go to Source View, and then I'll press Alt-Shift-Enter to go to full screen, and I'll locate the Range Validator that I created for the price. I'll select the Range Validator code, and I'll copy it to the clipboard. Then I'll go down to the Template field for the pub date, and I'll paste that code into place within that template. Now I'm going to make changes to the Range Validator that I just created. First, I'll change the ID. It has to be unique within the page. I'll change it from Range Validator 1 to Range Validator 2. Then I'll set the Control to Validate, changing it from Price to Pub Date. And I'll set the error message to a value of Please enter a valid date. When you use the Range Validator to validate dates, the minimum and maximum values must be phrased as dates. I'll put in a broad range of dates, setting the maximum value to 12/31/2100 and the minimum value to 1/1/1900. And here's the critical piece you must change. The type attribute, which was set to double, instead should be set to date. So now I have another validator, this time connected to the pub date form control. When the user fills in the form, if they don't fill the control in with a well-formed date, this validator will trigger and it will show the error message that I specified. Because I didn't add a required validator for this text box, The rule is that the user has to either enter a well-formed date or they can also leave it blank. I'll save the changes and run the page again, and I'll click the insert link and show that I'm only getting the message price is required. But now I'll click into the pub date control and type a value that's not a date, such as the words not a date, and click insert. And now I also see the message, please enter a valid date. Now, as you can see, there are some display issues that are implicit when you add these controls without applying formatting. But I'll show you how to deal with the formatting issues in a separate video. When you place an ASP.NET validator control within a details view control, its formatting is controlled by the container control, that is the details view. And it's a good idea to apply formatting to the validator to make sure that it stands out and the user sees it clearly. For this demonstration, I'll be working in the file title insert validation messages.aspx. In this file, I've created a number of validators and applied them to the various form controls, the price and pub date. I'll start by running the page in the browser and show you the nature of the problem. The details view control that contains both the form controls and the validators has a particular background color. I'll leave the price blank and type in a non-date value into the pub date control. And then I'll click the insert link. And you'll see that the error messages using their default formatting are hard to read against the background of the details view. You'll also see that there's a bunch of extra space between the error messages and the controls themselves. That's because with their current settings, the validation controls reserve space for the area that's going to be needed to display the messages. It's possible to make this more dynamic so that the controls only appear and the form only makes adequate space for the messages when an error condition exists. So I'll correct both of those issues. First, I'll deal with the space issue. Each of the validators has a property called display. When I dragged the controls in Design View, the display property wasn't set, but it defaults to something called static. That means that when the form is initially presented, it reserves the space that might be needed for an error. Here's how we can fix that. I'll go to the first validator, the required field validator for the price control, and I'll add a display property, and I'll set it to a value of dynamic. Now, I'll copy that setting, and then I'll paste it into each of the other validators. I'll select display equals dynamic and press Ctrl+C to copy. Then I'll go to the range validator for the price and paste it in. And I'll do the same for the range validator for the pub date control. Right around line 32 of the file, there's a break tag between the two validators. You'll only see one validator at a time, either the required field validators message or the range validators. You won't be showing both messages simultaneously, so the break tag can go away, and now watch what happens when I run the page. And you'll see that that extra space has been eliminated. Then I'll click the insert link, and you'll see that the form presentation is modified dynamically to make room for the error message. And if I type in a non-date value into the pub date and click insert again, once again you'll see that the space is allocated as needed. So that's the result of setting the property display to a value of dynamic. Next, I'll deal with the formatting issues. It's possible to apply individual formatting options to each control. Let's take the required field validator as an example. I'll place the cursor inside the required field validator tag, I'll press enter, and I'll set a property called back color, and I'll select a color of £EE, which is a light gray. I'll save the change and run the page. And then I'll click the insert link, and you'll see that the error message is now very easy to read. The problem with this approach, though, is that you'll need to apply that same setting to each individual validator control, not just in this page, but throughout your website. It's a lot better to create a single set of rules and then apply them to all validators. And once again, this is where cascading style sheets can help. I'll solve this problem by creating a single CSS class, and then I'll tell each validator control to use that class by setting its CSS class property. And I'll do a little bit of cascading style sheet work. I'll go to the Solution Explorer and locate the file styles.css and double-click it to open it. Now I'll go to the CSS outline panel that appears automatically. I'll right-click and select Add Style Rule. I'm going to be defining a class, so I'll select Class Name, click into the input, and I'll name my new CSS class Validation Error. And then I'll click OK. That creates the Validation Error class declaration. From here, I can either work in the CSS dialog box, or I can just do the code. I know what the code should be, so I'll just type it in. I'll put in background-color and set it to a value of £EE, EE. Be sure if you're typing this from scratch that you include the # before the 6-character color value. And then I can also set other cascading stylesheet properties. For example, I'll set the font weight to a value of bold. So that class is now available to all pages in my website because the styles.css file is linked into each of these pages. I'll save the changes, and then I'll go back to the page title insert validation messages.aspx. I'll go to the required field validator, and I'll remove the back color setting, and instead I'll put in CSS class equals, and then I'll select the class name validation error, which shows up automatically in Visual Web Developer because it's constantly monitoring the contents of the styles.css file that's linked into this page. Now I'll select that declaration of CSS class and press Ctrl-C to copy it to the clipboard, and I'll go to each of the 2 range validators and paste it in. I'll save those changes and run the page again. I'll once again leave the price blank, and I'll type in a non-date value in the pub date to trigger its validation, and I'll click Insert a couple of times, and you'll see that both validation error messages are displayed, and they both have the same background color and the same bold font. So that's how you can centralize the formatting of your error messages. So in this video, I've described how to cause the validation objects to only allocate space dynamically when the space is needed. And I've also described how to define and use common formatting for all validator objects using cascading stylesheet classes and the CSS class property. The ASP.NET Framework includes a control called the validation summary. The purpose of the validation summary is to collect all of the error messages generated by all of the validators within a particular page, and then to display those messages in a single location on the page. For this demonstration, I'll use a file called title insert validationsummary.aspx. In the current version of the page, there are 3 validator controls, 2 of them on the price field and 1 on the pub date. If I simply click the insert link, I'll see the error message for the price displayed, and if I type in a non-date value like XYZ, I'll also see the validator for the pub date displayed. By using the validation summary, I'll collect these messages and display them in a single bullet list below the form. I'll close the browser and return to Visual Web Developer. The first step is to suppress the automatic output of the validator controls. I'll go to each of the validator controls in Source View, and I'll change the value of the validator controls display property from dynamic to none. And I'll do the same thing for the range validator for price, and I'll also do the same thing for the range validator for the pub date. Now, if the form is displayed and the user makes errors, they won't see any messages at all. So here's how I'll replace that functionality. I'll look at the page in Design View, and then I'll go to the Toolbox panel. One of the items in the Toolbox panel is called Validation Summary. Pin the Toolbox panel into place if it isn't already pinned, and then click into the paragraph to the right of the Details view and press Enter to create a new paragraph. Then drag the validation summary and place it in the empty paragraph. Notice that the validation summary by default displays in a bullet list. Now save your changes and run the page in the browser. I'll click the insert link and show that the error message is now displayed below the form. And if I type in a non-date value into the pub date field and click insert, I'll see both of the error messages displayed together. From this point on, everything else is just a matter of simple formatting. If you don't like the extra space below the form, eliminate any extra paragraphs. If you don't like the color, background, or anything else about the way that the control is displaying the error messages, create a cascading stylesheet class and set the CSS class property of the validation summary control to use that class. This way you can create a common interface for your entire website without having to set the same properties over and over. So again, the purpose of the validation summary is to collect all of the error messages from all validator controls that are outputting them in a single page. You have to expressly suppress the output of the individual validator controls by setting their display property to none, and then add your validation summary wherever you want it to display on your web page. In a dynamic data-driven website, it's sometimes useful to be able to create printable reports, web pages that are able to be printed elegantly, but don't include all of the graphics and additional components that are needed on the screen. There are no particular components you use in ASP.NET for this purpose. For example, there's no built-in report class. Instead, you use the existing web form controls, such as the grid view control, to present the data, and then combine those controls with some creative use of cascading style sheets to modify the way the data is presented. For the demonstrations in this chapter, I'll use a website that's a part of the exercise files. Go to the menu and select File, Open Website. Select the Reports folder under CH10 Reports and click Open. And then open the file joined-data.aspx. Look at the file in Design View. You'll see that it presents the website's banner graphic and menu, but little else. The first step to creating a report is to start with a grid view and an SQL data source. I'll go to the Database Explorer, and then from there locate the Titles table, and then I'll drag the Titles table and place it into the page. As always, dragging a table into the page results in creating a grid view and a linked SQL data source. Now, I'm going to modify the SQL data source by modifying its select command. The select command is a query. If you know your SQL, you can hand code the query, but if you're fairly new to SQL, you can use Visual Web Developer's Visual Query tool. With the SQL data source object selected, I'll go to the Properties panel and double-click its header to make it float, and then I'll drag it out so I can see the properties more easily. Then I'll locate the Select Query property. The Select Query is the query that will be executed to retrieve data for presentation on the page. I'll click the button next to Select Query, and that opens the Command and Parameter Editor. Now once again, if you know your SQL, you could hand code it here, but I'll use the Query Builder by clicking that button. When the Query Builder opens, it opens in a small window. I'll click in the lower corner and drag it out to full screen so I can see more of its information. Now, I'd like to join the Titles table with two other tables in the database, the Publishers and the Authors information. I'll go to the top pane of the Query Builder, right-click, and select Add Table. And I'll choose Publishers and click Add. Then, with the Add Table dialog still open, I'll click Authors and click Add again. Then I'll close the Add Table dialog. Notice that when you add these tables, links are created automatically. That's because the names of the columns in the tables are identical. So the Pub ID column in Publishers matches Pub ID in Titles, and so on. Now, I'm going to modify the columns that I want to display from the Titles table. Notice that by default, all of the columns are being displayed. I'm going to deselect all the key columns, Title ID, Pub ID, and AU ID. I'll definitely show the title and the price, but then I'll deselect the pub date and notes. Next, I'll add the author. For the moment, I'm only going to add the author's last name, and then I'll add the publisher's name as well. I'll execute the query and show what the data looks like so far. The return data shows up in the bottom pane, and I can see that I'm retrieving those four columns all joined together. Now, I'm also going to sort the data. I'll go to the title row, and then in the Sort Type column, I'll choose Ascending. This will cause the data to be returned in ascending order by title. I'll execute the query again, check the results, and sure enough, it's in alphabetical order by title. Finally, I'm going to take two of the columns from the authors table and join them together to create a single column with both values. Instead of returning the author's name as two columns, I'm going to return it for reporting purposes as a single column. I'll start in the first column, the one with a header of column, and I'll change the expression like this. First, I'll drag this out so I can see more of it, and then I'll start the expression with AUF name, and then a plus operator, then single quote, space, single quote, then another plus operator, and finally AU_L name. This means that I'm using the value from the AUF name column plus a literal space wrapped into single quote characters plus the AUL name column. It's critical that you use single quotes in this context and not doubles. Then I'll tab over to the alias column, and I'm going to name this column full name. So the result will be that when I get the data back from the server, it will be exposed as a single column with the author's full name. Now I'll click Execute Query again, and sure enough, the full name column contains the author's full name. So that's my query. Now I'll click OK, and that takes me back to the Command and Parameter Editor, where I can see the finished select command. Then I'll click OK, and that takes me back to the Properties panel. Now I finished the work on the SQL data source object. The next step is to modify the grid view. I'll click on the grid view, I'll open the task list, and choose Refresh Schema. This prompt is telling me that I'm about to regenerate the column fields for the grid view, and it will result in deleting any changes I might have already made to existing column fields. That's okay. I didn't customize the grid view yet on purpose. So I'll click yes, and then I'll take a look at the grid view, and I'll see that in fact it is displaying the actual data I asked for. Now I'll save my changes pressing Ctrl S, and then preview the page in the browser by selecting Debug, Start Without Debugging. And there's the result, the actual data displayed on the screen. Now before I complete the video, I'll show you a couple of standard formatting tricks you can use. I'll close the browser and return to the grid view, open its task list, and select Edit Columns. First I'll set the header text. I'll click on each field, go to the header text property, and change it to a value that I want the user to see at the top of the column. For title and price, I'll simply uppercase the first character. For full name, I'll split that up into 2 words of full name. And for pub name, I'll replace that with a string of publisher. And I'll click OK. I'll also deal with the price. When I run the page right now, I see that the price is displayed in a raw numeric format. I'm going to fix that by applying currency formatting. I'll close the browser and go back to Visual Web Developer. Once again, I'll edit the columns, and I'll select the price. I'll go to the Data section of the bound field properties to the Data Format string, and I'll use the following format. I'll start with the brace, then 0, meaning that I want to format the first value, the only one in this context, then a colon, and an uppercase C for currency. I'll click OK, and then I'll save and run the page again, and you'll see this time that the numeric value is formatted as a currency value. In the last step, I'll apply some formatting. I'll go to the grid view, I'll select Auto Format, and I'll choose one of the formats. I'm going to choose this one, Classic, and click OK, and that applies classic formatting to the grid view with a bluish background, white foreground for the heading, and pretty standard text in the middle, and alternating row colors. I'll run the page, and there's the result presenting joined data in a friendly, easy-to-look-at HTML table with alternating row colors and a colorful presentation. Once you've created an ASP.NET page that presents data, you can then start refactoring the page for use as a printed document. Refactoring a page for print has a couple of steps. First, you might want to go into any ASP.NET controls that have explicit style settings and replace those style properties with actual cascading style sheet references. At runtime, you'll be able to have 2 sets of styles, one for presentation on the screen and the other for printing. ASP.NET controls, by default, have explicit style properties. For this demonstration, I'm working with the file displaydata.aspx, which has an SQL data source whose select command joins multiple tables together, and then a grid view that presents the data using one of the auto format settings. Let's take a look at the code for the grid view. I'll select the grid view and then go to source view. Then I'll press Alt-Shift-Enter to go into full screen. In the grid view code, down toward the bottom of the declarations, there are a number of styles. Each of these styles has individual style properties, which, as I've shown in other demonstrations, are translated by the ASP.NET Framework at runtime into style declarations that are inline, which, as I've shown in other demonstrations, are translated by ASP.NET at runtime into explicit style declarations that are inline within the rendered HTML table. The problem with this approach is that if you wanted to change from one set of styles to another at runtime, you would actually have to go in and change each individual property on each grid view control. A better approach is to take these properties and translate them as cascading stylesheet classes. I've already done some of the work. I'll open the file styles.css and show you that this file contains a number of classes named report header, report row, and report alt row. These 3 CSS classes match the settings that are generated by Visual Web Developer when you select a particular auto format. The row style, which is declared up at the top of the code, the header style, and the alternating row style, which are all used in the presentation, have all been restated now as CSS classes. So here are the changes I'm going to make in the actual document. First, I'm going to eliminate any styles that won't actually be used. I'm not going to be using paging in this presentation, so I'll remove the pager style. Similarly, I haven't allowed the user to select rows. That's an Ajax style approach that isn't turned on right now, so I'll delete that. And I'll also remove the edit row style because this grid view isn't used for editing. Then I'll move some of the code around. I'll go up to the row style and select and cut that to the clipboard, and then go back down toward the bottom of the grid view and paste it in. For some reason, Visual Web Developer separates those style declarations. Doesn't matter where you place them as long as they're all within the grid view, and I like to keep them together. And finally, I'll remove one more, the footer style, because this particular grid view won't have a footer. So I'm left with these three style declarations: the row style, the header style, and the alternating row style. Now, I'll replace the individual properties with the CSS declarations. First, I'll remove all the style settings. I'll go to the row style and remove the back color. I'll go to header style and remove back color, font bold, and forecolor. And then I'll go to alternating row style and remove the back color. Now, before I replace those settings with the cascading stylesheet classes, I'll save and run the page. You'll see that the grid view is displayed now with a very plain appearance. By removing all the individual style properties, I'm now rendering the text as just plain old boring text. Now, I'll close the browser, and now let's restore the look and feel. Going back to the styles file, I'll be using these three CSS classes. First, in the styles.css, I'll select and copy the name of the class, report row. I've double-clicked on the name of the class to select it, and then pressed Ctrl-C to copy. Then I'll go back to the ASP.NET page, and in the row style attribute, I'll add the CSS class property, and paste in the name of the class, report row. Now I'll do the same thing for the header style. I'll go to styles.css, I'll locate and select the report header class, and press Ctrl-C to copy. I'll go back to the page, and add CSS class equals, and then paste in report header. And one more time for the alternating row style. I'll go to styles.css, double-click to select report alt row, press Ctrl-C to copy, go back to the page, add the CSS class, and press Ctrl-V to paste, and I'll make sure that the resulting markup in the ASP.NET page is well formed. Each declaration of the CSS class should have an equals, a pair of quotes, and then the name of the class. As a reminder, you don't put in the dot before the class name when you're referencing the class name within your ASP.NET document. The dot only goes in the actual CSS file when you're creating the class. Now, I'll save the changes to all the documents. I'll go back to displaydata.aspx, and I'll press Ctrl F5 to run the page. And when the page runs now, you'll see that the look of the page is restored. I'm now positioned to be able to create two CSS files, one for presentation on the screen as seen here, and one for printing. And it will be up to the browser to switch back and forth between them at runtime, but I'll show you how to do that in another video. Once you've prepared an ASP.NET page for printing by replacing any of the ASP.NET controls style properties with references to actual CSS classes, the next step is to create links to additional stylesheet files. The link element, which is a part of the HTML language, you use the link HTML element to link an HTML page to an external stylesheet. For this demonstration, I'm working in the file printformat.aspx. In this file, the grid view control has its styles already replaced with CSS class declarations. And these CSS class declarations are referring to classes that are actually defined in the external stylesheet file styles.css. And the link element within the head section of the page is where that join happens. Here's the first step. I'm going to press Alt-Shift-Enter to go into full screen so I can see as much code as possible. Then I'll go to the existing link tag, and I'll add a new attribute called Media, and I'll set it to a value of Screen. This is a standard attribute that all modern web browsers recognize. When a web browser opens an HTML page and it sees a link element with the media set to screen, it recognizes that that means that this stylesheet should only be used for rendering on a standard computer screen. Then I'm going to create another link element. I already have a file in place called printstyles.css. It repeats the same CSS classes, report header, report row, and alternating row, but gives them completely different values, and also designates a different standard font family up at the top in the body comma table selector. Instead of Arial, we'll be using Times New Roman. So I'll go back to the page, and I'm going to make a copy of this link element. I'll select those lines, press Ctrl-C to copy, place the cursor right below the link element, and press Ctrl-V to paste. Then I'll make two changes to the new version of the link. I'll change the href attribute, printstyles.css, and I'll change the media from screen to print. Notice all the available options for the media attribute. In addition to screen and print, there's also handheld, which is used by cell phones and other small devices, projection, braille, oral, and so on. So there are my two style sheet declarations. I'll save the change and run the page by pressing Ctrl F5. When the page first appears, it looks exactly the same as it did before, because it's now using the screen style sheet. But then I'll use my browser's print preview capability. In Internet Explorer, you can get to this by right-clicking on the page and selecting Print Preview. And then I'll expand the page, and you'll see that I'm using the Times font now, and all the text looks quite a bit different than it did on the screen. Once you've created this extra style sheet link, you can then customize the look of your report using whatever CSS styles you know how to use. But the technique of using multiple style sheets is a critical element when you want to prepare a page so that it looks different on the printer than it did on the screen. In ASP.NET pages that you want to prepare for printing, there are times when there are elements that you see on the screen that you don't want to appear on the page. In this example, I'm working with the file suppressingelements.aspx. I'll press Ctrl F5 to run the page in the browser, and then I'll show the same page in Print Preview. Notice that the menu, that is, the elements on the page that appear on screen that allows the user to navigate around the website, also appear on the printed page. I'd like to suppress that element so it doesn't appear when the document is printed. There are two steps you have to follow for this. First of all, the element that you want to hide must have a unique ID, and that unique ID can't change each time the page loads. You have to deal with the actual HTML elements, and so you might have to do a little bit of diagnosis on your page to find out how the element IDs are being generated. Let's run the page again. This time, when the page appears in Internet Explorer, I'm going to right-click on the page and select View Source. And then I'll press Ctrl F, and I'll search for the string Home. And I'll jump to the anchor tags that constitute the menu. I'd like to hide this div tag. Notice that it's being generated with an ID of CT103_menu panel. If you're following the same steps on your computer, you might find that that ID is different on your system. And the reason is because this content is generated by the header element, that is, the custom control that I'm using in my page. And if I go back to my source code in suppressingelements.aspx, and I'll press Alt-Shift-Enter to go to full screen, I'll see that my use of the header control right here doesn't have an ID attribute. Because I haven't applied an ID, ASP.NET applies one for me. And if I can't predict what that ID is going to be, then I can't apply cascading style sheet rules to it appropriately. So the first part of getting ready to suppress this entire header is to give it an ID. I'll put in an ID element, and I'll set it to a value of my header. Now, I'll save the changes, and I'll run the page again. And once again, I'll view source on the page, press Ctrl F, search for Home, and now I see that the div tag ID is myHeader_menu panel. This is an ID that will always be the same. So now I'm going to select that ID in my View Source Editor and copy it to the clipboard, because I'm going to use that ID in a cascading style sheet rule. Now, I'll close the browsers and return to Visual Web Developer and get out of full screen. Now, I'll go to the printstyles.css file, and I'll open that code up in full screen. And I'm going to add a new selector into my cascading style sheet file. This is going to be an ID selector. I'll put in a £, and then paste in the ID of my div tag that's being generated when the .NET page is being rendered. Cascading style sheet ID selectors apply to only a single element. You prefix the selector name with the £, just like you use a dot for a cascading style sheet class. But unlike a class which can apply to multiple elements, ID selectors are designed to apply to only one. Then I'll put in a pair of braces, and I'll add the following properties. First of all, visibility, which I'll set to a value of hidden. This means that when I print the document, the menu won't appear. And I'm also going to shrink the menu down to a tiny size like this. I'll put in a height of 0 pixels and a width of 0 pixels. Now this technique won't work on all browsers. I'll show you that on Internet Explorer, the panel size won't actually change. But then I'll show you on Firefox that it does. And then go back to suppressingelements.aspx. In this file's begin state, it already has the links to the multiple style sheets. Styles.css for rendering on the screen, and printstyles.css for rendering on the printer. I'll run the page, and you'll see that when you rendered the page on the screen that the menu is intact and still visible. And then I'll look at the same page using Print Preview. I'll right-click on the page and select Print Preview, and expand the width of the page, and you'll see that the menu is gone. And it's only gone when you actually print the document. Now, on Internet Explorer, what you're seeing is that the visibility element does fine, but the width and height of the elements are still the same. This extra vertical space in the page above the title is reserved for that menu even though it's not visible. But now, I'll close Print Preview, and I'll go into Internet Explorer's address bar, and I'll copy the current URL to the clipboard. Then I'll open up Firefox, and I'll paste that URL into Firefox, and you'll see that the page looks pretty much the same on the screen as it did in Internet Explorer. But then in Firefox, I'll go to the menu and select File, Print Preview. And you'll see that in Firefox, the height and width attributes do work. Setting the height to 0 and the width to 0 pixels each means that the element is completely gone from the printed document. So, to find cross-browser solutions to printing documents from HTML, you'll have to do a little bit of experimentation and research. I do encourage you to test these pages on multiple browsers. Whichever browser your users are going to be using to access your website, you'll want to make sure you have copies of those browsers and that you've tested the pages in all of the different ways that you're planning for them to be used, both rendered on the screen and printed on the printer. The ASP.NET Framework makes it easy to create a report that includes both the output data and the form controls that the user interacts with to indicate which data they want to present. For this demonstration, I'll work with the file selectdata.aspx. In this version of the page, there's an SQL data source with a joined table query and a grid view that's presenting the data. When I run the page in the browser, I see that all of the data from the table is displayed. The first step in creating this sort of filtered report is to create a user interface that the user can interact with. I'm going to use an ASP.NET control called a drop-down list. In HTML terms, it's a select control, but it will be dynamically populated with data from one of the database tables. I first need an SQL data source object that gets the data for that table. I'll place the cursor in the page right before the grid view. The easiest way to get there is to select the grid view and then press the left arrow key. Then press enter to create a new paragraph. If you move the cursor up to the previous line, you'll see that the paragraph is there. Now type in a label, Publishers, with a colon at the end. Select that text and press Ctrl-B to make it bold. Then go to the Database Explorer. Locate the Publishers table and drag and drop it right after the Publishers label. That will result in creating the grid view control. For the moment, you can't see the Publishers label, but that's okay. Just press the Delete key and you'll see that the label is still there. So now we have an SQL data source object that's getting data from the Publishers table. Click on the SQL data source object and scroll up to the top of the Properties view and change the ID to Pub Data Source. This will let you easily distinguish between the SQL data source for the titles and the data source for the publishers. Alright, the next step is to add the control that you want to show the publisher's data. I'm going to click off the SQL data source object so I can see that my publisher's label is still there in the background. I'll place the cursor right at the end of that string and press the space bar to put an extra space in. Then I'll go to the Toolbox panel and I'll locate the drop-down list control. I'll drag the drop-down list into the page and drop it right after the publisher's label. It'll look in Design View like the drop-down list is dropping down to the bottom, but when you actually run the page in the browser, you'll see that the drop-down list control is displayed right next to that label. That's where you want it. Right now, the drop-down list doesn't show any actual data, so I'll go back to Visual Web Developer and configure it. I'll make sure that the drop-down list is selected. Then I'll open the task list and select Choose Data Source. In the Data Source Configuration wizard that appears, I'll open the list of available data sources and select Pub Data Source. For a drop-down list, you select two data fields, one that the user sees called the Display field, and the other that provides the value for the drop-down list known as the Value field. In this table, there are two columns. The Pub Name column is the one you want the user to see. So select that under the option Select a Data Field to Display. And then check that the data field for the value is set to pub_ID and click OK. And now your drop-down list is configured to display the data from the table. Test the page again, and you should see that the publisher list is now displayed when you open that drop-down list. Now we're going to connect the data source for the titles to this visual control. I'll close the browser and return to Visual Web Developer. I'll go to the data source control that's being used to manage the titles. And then I'll go to the Properties view. I'll double-click its header and then resize it, and locate the Select Query property. I'll click the button to open the Select Query, and then click the Query Builder to rebuild the query visually. I'll expand the Query Builder window so I can see more of it. I'm going to filter the data on the pub ID column of the titles table. So I'll go to the titles table and select pub_ID. Then I'll go down to the grid pane in the middle, and I'll resize it so I can see that the pub ID column was added. The purpose of selecting the pub ID column was not to display it, so I'm going to uncheck the option under Output. But then I'll go to the filter, and I'll put in the following filter. Equals, and then starting with an @ character, pub_ID. This defines a parameter in the query. I'll press the Tab key to save my changes, and then take a look at the SQL in the SQL pane. The newly generated query now has a where clause in the correct location that matches the parameter pub ID to the pub ID column of the titles table. I'll click OK to close the query builder. Now click Refresh Parameters, and you'll see that Visual Web Developer detects the new parameter pub ID and shows it in the parameters list. Now we need to indicate where that parameter will be filled in from. Go to the right and pull down the list under Parameter Source, and choose Control, meaning we're going to get the data from a form control. Then pull down the list under Control ID, and choose Drop-Down List 1. This is the drop-down list that's displaying the publisher data. And then click OK. We're almost done. The last step is to go back to that pull-down list that's showing the publisher data, and to cause it to post the page back to the server every time the user selects a new value. After selecting the control, look in the Properties view, scroll up to the top and locate the property Auto Postback, and set it to a value of true. That means that whenever the user changes the value, it will cause the page to repost, and then in the .NET framework on the server, the query will be rerun with the new filter, and the grid view will show only the selected records. Save your changes and run the page in the browser. When the page first appears, it doesn't show any data. That's because there are no titles in the titles table that are matched to the publisher ID for G. But now pull down the list of publishers and try selecting Binet and Hardley, and you'll see that the page reposts, and when it displays now, it only shows the data for that publisher. Pull down the list again, and choose another one, New Moon Books, and once again you'll see the filtered data for just that publisher. Finally, check your preview. If you're using Internet Explorer, right-click anywhere on the page and select Print Preview. If you're working in Firefox, go through the menu, and it will display the currently selected publisher and the selected titles. So in this video, I've shown you how to construct a filtered report, adding an ASP.NET form control bound to a database table, and then binding that control to the SQL data source's select command. The result is that the user can select the data they want to see, and the .NET framework handles all the filtering, all with doing very minimal programming. The ASP.NET framework includes a couple of tools that make it easy to save data persistently between page requests. The ViewState object, which is a part of all ASP.NET web form pages, allows you to place data in an object that's then persisted from one page to another when those pages are posting to each other. And session variables are a place where you can put data that's saved between page requests, regardless of whether the pages are posting or simply redirecting to each other. For the exercises in this chapter, I'll use a website that's a part of the exercise files. Go to the Visual Web Developer menu and select File, Open Website. Locate the Sessions folder under CH11 Sessions and open it. And then open the file filteredreport.aspx. This is a filtered report page. It includes a drop-down list server control that's populated with data from one SQL data source, and when the user selects an item from the pull-down list, the filter is then applied to another data source, which drives the data that fills a grid view. I describe how to build this page in the chapter on reports. I want to use this chapter to describe how the ViewState object works. I'll run the page in the browser. When the page first opens, it retrieves data from the publishers table on the server and populates the drop-down list. When the user selects an item from the drop-down list, the page is posted back, the filter is reapplied, and the grid view presents the resulting records. The ViewState object is being used dynamically by the ASP.NET framework. You'll notice that when the page reloads after the postback, that the drop-down list still shows the item that the user selected. The .NET framework is using this object known as the ViewState object automatically. When you select the item, a property is placed in the ViewState object, and then when the page reloads, it looks in the ViewState and gets the data out. You can actually see the ViewState in your page if you view the page's source in the browser. In the browser, I'll right-click on the page and select View Source. The ViewState object is here. You'll see that it's a fairly heavy object that's placed into the page. And in this page right now, it's storing quite a bit of information. It's storing the name of the page, the data item that the user selected in the drop-down list control, and also all of the data that's being presented in the grid view. This data is all encrypted in a format called base64. It's not readable to the human eye, but easy for the .NET framework to decrypt. The problem with the ViewState object is that it is heavy and it adds quite a bit of size to each web form page. And in many situations, you don't need all that data. You can make your pages quite a bit lighter by disabling the ViewState object in controls that don't really need it. An example in this case would be the grid view. Although you do need ViewState capability in the drop-down list, that is, you want it to retain the user's selection between page loads, you don't need to save all the data from the grid view. Each visual control in the .NET framework supports a property called Enable ViewState. I'll select the grid view object, and then go to the Properties panel. I'll double-click it to make it float, and then resize it. And then I'll go to the Enable ViewState property. Notice that it's set to True by default. I'll change its value to False. You won't see anything change in the visual presentation, but now I'll close the Properties view and run the page again. I'll once again choose an item from the Publisher's pull-down list, and then look at the source code, and you'll see that this time the ViewState data is significantly smaller. Particularly when you retrieve and present large amounts of data, the ViewState object makes your web page quite a bit larger, and on a slower network this can mean that it takes longer for the page to load. One of the ways in which ASP.NET developers tune their websites is to go through the pages and turn the ViewState capability off on those controls that don't really need it. It's also worth mentioning that you can use the ViewState object and add arbitrary properties to the ViewState so that you can pass data between pages. But this capability is limited to the situation where you're using post architecture. That is, you're using data entry forms or the automatic ASP.NET form object and posting back to the server. ViewState does not work when you're simply loading multiple pages using what are known as HTTP GET requests. To persist data between those kinds of requests, you'll need to learn how to use session variables, and I'll show you how to do that in another video. When you need to persist data in memory between page requests that's unique to each individual user, and those pages aren't connected to each other through the web form system, that is, they aren't posting to each other, you can choose to use session variables. A session variable is stored in memory on the server, but a copy of the session variable is stored for each individual user session. And that session, in turn, is managed with cookies. A cookie is a bit of data that's created on the server and sent back to the browser, along with the response to an HTTP request. In the ASP.NET framework, and with many other application servers, session cookies are created automatically. Whenever a page is loaded, the server will detect that a new user session is starting, and it creates a session cookie, known as the user session token, and sends that back to the browser with its first response. The browser then includes that cookie with each subsequent request, essentially reminding the server of which user session is making the request. You can add arbitrary session variables. Each session variable can be of many types, strings, numbers, or even complex arrays containing complete datasets. In this video, I'm going to demonstrate how to create a session variable in response to a button click, and then how to read that session variable in a totally separate page. I'll start at the file sessionvarcreate.aspx. In this page, there's currently a text box control with an ID of textbox1 and a button control with a text label of setVariable. I'll double-click on the button, and that takes me to the button's button1click method. This is the event handler function responding to the click event on the server. Within the server environment, I'm going to create a variable in the session scope. There's an object named session. It's a dynamic object, which means that you can add arbitrary property names. Within the function, I'll say session, and then I'll put in a bracket, and within the brackets, I'll add the ID or the key for the property I want to add. You can use any string value as the key for the property. I'll use a property of mySessionVar. Then I'll close the expression with the closing bracket. Then I'll put in the equals assignment operator, and then I'll assign the value of the session var to textbox1.text. The data typing of this value is a string, because the text property of the text box returns a string. But again, you can put in many kinds of complex data into the session object. Now, after I've stored the data in memory, I'll then redirect to the read page using response.redirect, and I'll pass in the name of the page I want to go to, sessionvarread.aspx. Because I'm using the redirect command, I'm not posting to the other page, and therefore I would not be able to use the viewState object to pass the data. But when I set the value in the session object, I'm storing the data in server memory, and when the other page loads, it'll send that cookie in, and it'll have access to this data. I'll save that page and then go to the page sessionvarread.aspx. In this file, there's a button with a label of read variable, and a label control with an ID of output label. I'll double-click the read variable button, and that takes me to the click event handler for that button. And here, I'll retrieve the value of that session variable. Within the button click event handler, I'll set the output label's text property, and then once again, I'll use the value session bracket mySessionVar close bracket. There's one more bit of code you must include though. The text property of the label object expects a string, but there's no way for the ASP.NET Framework at this point to know that the value I stored in the session with the key of mySessionVar is a string. In C#, you explicitly data type the returned value using this sort of code. Place the cursor before the session object, and then declare the data type of the object using the data type within a pair of parentheses. If you're working in Visual Basic, you would instead use the syntax as string after session mySessionVar. Now I'll save the changes, and I'll run the page initially without coming from the first page. When the page loads in the browser, I'll click the button, and you'll see that the label text property is left blank. That's because that variable is not in session or server memory yet. So I'll close the browser, and I'll return to the create page and run that page in the browser, pressing Ctrl F5. I'll type in a value into the text box, and click the button Set Variable. That takes me to the read page. Then I'll click the read variable button, and you'll see that the value is retrieved and displayed. Now, one of the questions that comes up about sessions is, do they persist between browser sessions? That is to say, if the user closes all of the browser windows and then opens the website again, is that session data still accessible to them? And the answer is no. I'll go back to the read page and load it into the browser again. Notice that I've closed all of my browser windows before this part of the test. And I'll click the button and show that the data does not show up. Here's what's going on. Remember I said that cookies are used to link the web browser session to the data on the server. The type of cookies that are being used here are called memory or session cookies, and the browser doesn't remember those cookies between its own sessions. These kinds of cookies are not stored persistently on disk by the browser. They're just stored in memory. So when the user closes all the browser windows, its session cookies are lost, and therefore the data on the server is lost as well. So data that you place into the session scope or into the session object is remembered between page requests, but only for the duration of the current browser session. When the user closes all of their browser windows, that results in destroying the session cookies that are in browser memory, and the next time the browser goes to the website, a new session is started automatically. Session variables, again, can store many different types of data: strings, numbers, arrays, and many other complex objects. The most common use of sessions is to store things like shopping carts, user information after authenticating the user, and so on. And it's a valuable way to glue together the pages of a dynamic website built in ASP.NET. The ASP.NET Framework supports 3 automatic modes of authentication, known as Windows Authentication, Forms Authentication, and Passport Authentication. Windows Authentication means that you build authentication against the built-in authentication system of the Windows operating system. With Forms Authentication, you work against a database in which you store user information. And with Passport Authentication, you're authenticating users against their passport credentials, a system of usernames and passwords that's stored by Microsoft itself. In this chapter, I'll focus on Forms Authentication. The Forms Authentication model requires configurations to your website in the web.config file, and then creation of a set of pages. In this first step, I'm going to open a website. I'll go to the menu and select File, Open Website, and then I'll open the folder Security. Then, I'll go to the file web.config. I'll open up the web.config file to full screen by pressing Alt-Shift-Enter. When you first create a website, it's set up with Windows-based authentication. Press Ctrl F for Find, and I'll search for the string authentication starting with the tag character. The authentication is set initially with a mode attribute set to Windows. I'll change that value to Forms and save the changes, and click the full screen button to return to regular display. Once you've turned on forms-based authentication, you're then ready to create the user interface. In the remaining videos of this chapter, I'll describe creating a login page with login.aspx, a page to add new users called signup.aspx, and I'll show you how to add logout functionality through the application menu. ASP.NET 3.5 includes a set of components known as the authentication or security components. These components can be dropped into ASP.NET pages to configure a website that you want to be authenticated. That is, that you want a user to have to log into to have access to either the entire website or to various components of the website. For the demonstrations in this chapter, I'll use the security website. I'll build the login form using an existing file called login.aspx. After I open the file, I'll then click the Design button to look at the page in design mode. You'll see that this is a very simple ASP.NET page. It does not include the standard header control that I've used in other parts of the website. When the login form is presented, you typically don't want to present the application menu, for example. So here, I'm only presenting the actual banner graphic at the top of the page, and otherwise this is a completely blank page. The first step to implementing a security system is to create a login form. That's what I'll do with this page. With the file open, go to the Toolbox panel and pin it into place if it's not already set up that way. Then open the Toolbox panel's Login category. You'll see a number of components listed there, including the login view, the Create User Wizard, and others. The first step is to create an object called Login Status. The Login Status object detects whether a user is currently logged in. Drag the Login Status object and place it inside the empty paragraph. You'll see that the Login Status object has two views: the Logged Out view, which is displayed when the user is logged out, and the Logged In view that's displayed when the user is logged in. For the login page, we're primarily concerned with the Logged Out view, what the user sees when they're logged out. Set the Views option to Logged Out, the original setting. Then go back to the Login category and locate the Login component, and drag and drop that and place it directly on top of the Login Status object. You'll see that it drops in above the Login Status, and it creates a data entry form that asks the user for their username and their password. You can select the Auto Format option and choose one of the standard look and feels. I'll choose the Simple look, which matches the formatting that I've applied to other components in the website. And I'll click OK. Now press Ctrl S to save, and then run the page, selecting Debug, Start Without Debugging. The login form asks for the username and password. I haven't actually created usernames and passwords yet, but I can go ahead and type in values. I'll type in my name, David, and then a password, and click Login. There's a good bit of activity going on the first time you use the page. I'll explain what's going on in a moment. But when the login page is finished processing, I see the message, "Your login attempt was not successful. Please try again." So that's the beginning of creating the login architecture. Now here's what was going on in the background. The first time you run the login page, the .NET Framework automatically creates a database. I'll go to the App Data folder, which is automatically created in all ASP.NET websites that are created in Visual Web Developer. And I'll click the Refresh button at the top of the Solution Explorer panel. And you'll see a new file has been created called ASP.NET-DB.mdf. That's an SQL Server database, which is actually being stored locally with the website. Then I'll go to the Database Explorer panel and show that a data connection has been created that connects to that database. I'll open the database file and open its tables list, and you'll see that the database structure has been populated automatically with a number of tables. They're all prefixed with ASP.NET, and then there's an underscore character, and then there's the name of the table. I'll describe the purpose of many of these tables in a later video. But you've successfully created your login page, and you've also successfully created a database to store usernames, passwords, and other aspects of the authentication system. Once you've created a login page and run it for the first time, resulting in creating the authentication database, you can then start adding users. Once again, there's a component in the ASP.NET 3.5 framework for this purpose. For this demonstration, I'll use the file signup.aspx. I'll open the file and then take a look at it in Design View. Notice that once again it's an empty page with just a banner graphic at the top and a paragraph. Next, I'll go to the toolbox, to the Login section, and I'll select the component Create User Wizard, and I'll drag the component and place it in the page. The Create User Wizard component includes fields for username, password, email, and a security question and answer, and it requires that the user type in the password twice. By default, it requires a password that's at least 7 characters long and includes one non-alphanumeric character, such as a £, an ampersand, or something else that's not a letter or a number. Also, in the ASP.NET 3.5 authentication model, the password is case-sensitive. You can choose how to communicate all this to your user. Once I've dropped the component in, I'll then format it. I'll go to the task list and select Auto Format, and I'll choose the same Auto Format option that I used for the login form, Simple, and I'll click OK. Now the two pages have a similar look and feel. I'll save the changes to that file, and then I'll go back to the login form, and I'll select the login component. The login component has a way of creating a link automatically to your sign-up page. With the login component selected, I'll go to the Properties panel and double-click its header to make it float, and then expand it. And then I'll add 2 properties that the user can use to get from the login form to the sign-up form. I'll go to the property Create User Text, and I'll type in the text, Register as a new user. Notice that after I type in that text and press the Tab key, the text I typed in appears in the login form in the Design View. Next, I'll go to the property Create User URL. This is how you designate the page you want the user to go to if they click the link. I'll click into the property, and then click the Browse button that appears, and I'll select the file signup.aspx, and click OK. I'll save my changes, and then run the page, selecting Debug, Start Without Debugging. When the login form appears, I'll click onto the Register as New User icon, and that takes me to the sign-up form. I'll click into the form and type in a username of New User. Then I'll enter a password twice. Remember that the password must be at least 7 characters and include a non-alphanumeric character. Make sure you type the password exactly the same both times. Then type in an email address, type in a security question, and a security answer. The login system has the ability to prompt the user for the security question and then allow them to get back into their account later. I'll click Create User, and when the form completes its operation, the new user information will have been added to the authentication database. The Continue button currently only goes back to the current page. But now, I'll go back and run the login form again. I'll just go up to the web browser URL and go to login.aspx. I'll type in the username and password that I created, new user, and the user password. I'll click the Login button, and I'm taken automatically to the home page of the website. So now I've created 2 of the most critical components for an authentication system, a login form and a way to add new users. In other videos in this chapter, I'll describe the structure of the database that contains the authentication information, and then describe how to lock down the website so when a user tries to navigate to various pages of the website, they're automatically taken to the login form. When you use the login components, it results in creating an SQL Server database named automatically ASP.NET-DB.MDF, and the security framework uses the underlying SQL Server engine that's installed on the local machine to connect to that database, populate it with tables, and then start adding user information. The tables are named automatically. They each have a prefix of ASP.NET _ and then a suffix that describes the purpose. When you create a new user, records are added automatically to 2 of these tables, and as an ASP.NET administrator, it's important to know about these tables and understand a little bit about their structure. First of all, the ASP.NET Users table contains primary information about each user. I'll go to the Database Explorer, to the Tables list, locate the ASP.NET Users table, right-click, and select Show Table Data. And you'll see that when I created the new user, that a record was created in this table with the username. Notice that the username is populated twice. Once however you typed it, and then once as the lowercase version. It's the lowercase version that's used to compare when you log in. This means that the username itself is non-case sensitive, while the password is case sensitive. There are other columns in this table, but you'll notice that there's no storage here of the user's password. That information and other useful bits of information are in a linked table called ASP.NET Membership. I'll open the data for that table as well, and show you that there's also one record here, linked to the record in the users table. The password is stored in the password column, and it's stored in a hashed encoded form that can only be used to compare and not to retrieve. Once again, there are other columns here used for various conditions. There's the email address, the lowercase version of the email address, the password question, and the hashed version of the password answer. If you want to remove a user from the authentication model, first go to the ASP.NET Membership table and remove the record there, then go to the Users table and remove the record there. If you try to remove the record from the Users table first, you'll find you're not able to, because there's a database constraint put in place automatically that makes sure that you don't orphan records in the linked membership table. Other tables in the database structure are used for role-based security and for sharing user information across applications. Those details are beyond the scope of this tutorial. But if you want to learn more about the database structure, read the ASP.NET documentation about the security system. This architecture and the components that I'm using are a part of ASP.NET 3.5 and were not available in earlier versions of the framework. In earlier versions, to implement this sort of authentication, there was a certain amount of programming that you had to do, and in 3.5 it's all been fairly automated. So, in the chapter so far, I started off by creating the login component on a page of its own, and then I created the Create New User wizard on a page of its own and linked them together. In the remaining steps, I'll show you how to configure the website so that when a user tries to visit a particular page, access is denied and the user instead is sent over to the login form. After creating the user interface that allows the user to log in, the next step is to lock down the rest of the website so that when the user tries to navigate to any page of the website, they're automatically redirected to the login page. To see the current behavior, open the file titles.aspx or any other web page that presents data in the site, and run the page in the browser. You should see that the page loads successfully. Close the browser and return to Visual Web Developer, and then open the file web.config. This is the XML file in which you configure your website's behavior. In the file, navigate to the end of the system.web element. If you're using the version that's included with the exercise files, you'll find that element at line 83. Notice in the version that's included with the exercise files that there's a commented out section. This section isn't in there by default. I placed it in there, so it's not taking any action yet. In order to lock down the entire website, you simply create this authorization element. And within the authorization element, you add a deny element with the user's attribute set to a question mark. That means that you're denying access to any anonymous users. To complete the task of locking down the website then, simply remove these comment tokens. And then press Ctrl+S to save your changes to the web.config file. Now go to titles.aspx again, and try running the page in the website. This time you should see that instead of going to the titles page, you're redirected automatically to the login page. Take a close look at the URL in the web browser though. Notice that you're redirected to login.aspx, and a return URL attribute is passed in that references the page you tried to get to. And then log in with the username and password that you added to the authentication database earlier. I'll log in with the username and the password that I used. And then I'll click the login link, and you'll see that the page I originally requested, the title list, is successfully loaded. As long as I keep the browser open, I'll be able to navigate around in the website. If I close the web browser, and then try to reopen a page of the website, I'll once again be redirected back to the login form. This is because the login system is using session-based cookies. Cookies that are only stored in the browser's memory rather than on disk. So when you close the browser's windows on the client, that makes it forget the cookies, and then the next time the server doesn't recognize the user and asks the user to log in again. So now I've created the user interface for logging in, and I've also locked down the remainder of the website so only authenticated users can access those pages. The last step is to create a logout feature, which I'll do in a separate video. In websites that require the user to log in before they can have access to the site's resources, you typically want to create an explicit logout feature. Even though the user can log out by closing all of their browser windows, the users don't always know that, and it gives them a sense of security knowing that there's something they can click on to explicitly log out from the site. For this demonstration, I'll start in the controls file header.ascx. In this file, there's a panel that contains a number of hyperlinks. Right now, the user navigates around the website by using the hyperlinks in the panel starting at line 12. I'll look at the file in Design View, and I'll show you that it has the hyperlinks, and when you're looking at it in Design View, you won't see all the styles applied, so it doesn't look quite the way it will in the whole website. I'll click into the panel that contains the hyperlinks, put in a space bar, a pipe character, which is the character on the same key as the backslash. Just press the Shift key when pressing that key, and you'll get that separator character. Then put in another space. Instead of creating an explicit hyperlink, I'll use another one of the login controls. I'll go to the toolbox to the login section, and I'll drag in a login status object. The login status object has two states. The default state shown here is called the logged out state, and it creates a hyperlink that takes the user to the login page. In the logged in state, it shows a hyperlink with the text log out, and when the user clicks on that link, it logs them out and redirects them back to the login page. Now I'll save the changes, and then I'll open up the file styles.css. In this file, there's a class selector for menu panel. It's at line 16. And the menu panel rules include a width property that's setting the width of that panel to 250 pixels. Because I've added a new hyperlink, I need to make it wider. I'll change it from 250 pixels to 300 pixels. I'll save my changes by pressing Ctrl+S, and then I'll close that file. Now I'll open up the titles.aspx page, and I'll run it in the browser. Because I've locked down the website, I'm not initially logged in, I'm taken to the login form. Notice that the image is broken for the moment. We'll fix that in a moment. I'll log in with my username and password, new user, and the password I created, and then I'm directed to the titles page, or whichever page I requested. And here's the logout link. Notice that the user doesn't see any difference between an explicit hyperlink and one that's created by an ASP.NET control, such as the login status control. And now I'll click the logout link, and that takes me back to the login page. So now you have a way for the user to log in and log out. So now about the image. The image is broken because when you log out, you're no longer authenticated against the website, and the web server is preventing your accessing resources on the website. So in a login form, your best approach is to strip it of all visual elements other than the login component itself. Close the browser and reopen the file login.aspx. And I'll scroll down to the panel containing the image. It's at line 11 on my file. And I'll simply delete the entire panel. So now all I'm left with is the login component wrapped inside a paragraph. I'll save my changes, run the page in the browser, and there's the login form. Any styling that you want to apply should be done directly in the page rather than in the external style sheet. This is because that external style sheet file may not load into the browser correctly when the user isn't logged in, due to the restrictions of the ASP.NET authentication model. But you now have a complete system. The user can log in. I'll click into the form and type in the username and the password, and press enter. As long as I keep the browser open, I can navigate around the website freely, and when I click the logout link, I'm taken back to the login form, and I can then either log in again or close the browser. In order to deploy your ASP.NET website, you'll need to work with Internet Information Services, or IIS. IIS is Microsoft's enterprise-level web server. It's included with many editions of Windows, including Windows XP Professional, Windows Server 2003, Windows Server 2008, and many editions of Windows Vista. In this video, I'll describe how to install IIS on Windows XP Professional. In order to work with ASP.NET 3.5, you'll need to be working with at least Windows XP Service Pack 2, which is the version I'm working on right now. And you'll need access to your Windows Media CD, that is the CD from which you installed the Windows operating system. That's because the installation files for IIS are on the CD, rather than part of the default installation of the operating system itself. From the Windows menu, go to the Control Panel. I'll go to the Start menu and select Control Panel. And in the Control Panel, if you see the Category view, which only has a few options, switch to this, the Classic view, by clicking the appropriate link. Then from the Control Panel Classic view, double-click on Add or Remove Programs. Click on Add Remove Windows Components. It might take a few moments for Windows XP to scan your computer to see what components are already installed. And then it presents this, the Windows Components wizard. Scroll down a bit and you'll see an item labeled Internet Information Services. Check that option, and then click the Details button. The Details button shows a list of the subcomponents for IIS. You'll need to install most of the items that are already selected here. The one that's totally optional is the SMTP service. SMTP stands for Send Mail Transfer Protocol, and it's a service that you can use if you want to send mail from your own server. Setting up SMTP is a fairly complex operation, and there are security considerations that I won't go into here. So for this purpose, I'll just deselect it. But I'll leave all the other items selected that are already selected, including World Wide Web Service, Internet Information Services Snap-in, Documentation, and Common Files. And then I'll click OK. Then I'll click Next, and that causes the installation to proceed. The installation process installs the actual software, and also creates a default directory structure named c:/inetpub/www root. That folder will become your IIS default documents folder, so that if a user navigates to your website and provides just the root folder address, you'll actually be addressing files in the www root location. Once the installation is complete, you'll see this message, completing the Windows Components wizard. Click Finish. Then close the Add or Remove Programs window and return to the Control panel. Go to Administrative Tools, and from there into Services. In the Services panel, scroll all the way down to the bottom, and you'll find an item labeled World Wide Web Publishing. That's the actual IIS service, and you can stop and start your server from this item. Right after installation, it's a good idea to stop the service and then restart it. In some circumstances, you might find you actually have to reboot the computer before you can address your server for the first time. Now, the first time you go into the server, you might see some errors. I'll go to a browser and type in http://localhost. It might take a few moments to address the server for the first time. And you might see this pop-up login dialog. The reason this dialog appears is because the default user that's being used to manage your IIS service is not authenticated for the www root folder. So there's a bit of a setup process to follow. I'll cancel the dialog, and then I'll hold down the window key and press E for Windows Explorer, and I'll navigate to c:/inetpub. The www root folder is right here. This is the folder that by default is secured. I'll right-click on it and select Sharing and Security. In the Properties dialog, look for a Security tab. Now, if you don't see the Security tab, press Escape, go back to Windows Explorer, go to Tools, Folder Options. In the Folder Options dialog, click View, scroll down to the bottom of the options, and deselect this option, Use Simple File Sharing. Then click OK, and then once again right-click on www root and select Properties. This time, you should see the Security tab. Click on it. Then, in the list of group or usernames, go down to Users. Click on it, and then in the Permissions list, click the checkbox under Allow, and then I'll click OK. And you will have granted permission for all users on the computer to access this folder. Go back to the browser, and once again navigate to http://localhost. Once again, you might see the login dialog. That's because by default, you're trying to access a file which is also secured. So there's one more step in the process to testing your server. Press Escape or click Cancel, and then create a new file. I've already created the file that's needed. Its name is default.htm, and I'll open it in a text editor, I'll use WordPad, and show you that it contains the simplest possible web page. It has a pair of HTTP tags, a pair of body tags, and a heading 1 with the words Hello World. I'll take that file and copy it to the clipboard, and then I'll navigate to my www root folder and paste it into place. Then I'll go back to the browser again, and I'll type in again http://localhost, and this time I should see the string Hello World displayed in large text. Don't worry about any security prompts you might see. After the next step, which will be the installation of ASP.NET 3.5 and its integration with IIS, you will be ready to start deploying your websites right away. After installing Internet Information Services on Windows XP, the next step is to download and install the .NET Framework. You can get the .NET Framework from the website www.asp.net. I'll navigate to that website now. I'll go into Internet Explorer and go to www.asp.net. From the home page, I'll go to the section labeled Get ASP.NET Free and click on ASP.NET Framework. And from there, I'll go down to Microsoft.NET Framework, version 3.5. At the time of recording, the most recent version was 3.5 Service Pack 1. Click the link to download. After you've downloaded the file, double-click it to open it. The name of the file is .NETFX35setup.exe. After a few moments spent loading the installation components, you'll see this screen. Take a look at the licensing document, and then if you accept it, click the appropriate icon. If you'd like to send information about setup experiences, you can check this option. I won't. And then click Install. During the installation process, additional files will be downloaded from the Microsoft website, so you will need access to the internet throughout this process. The installation process runs fairly seamlessly, so you can walk away, get a cup of coffee, and when you come back, the installation should be complete. After the installation is complete, it's a good idea to reboot your computer, and then you'll be ready for the next step, actually deploying your website. Once you've installed the .NET Framework, you're then ready to deploy your website. There are a few steps involved. First, you'll place the website somewhere on disk. Then you'll create a virtual directory, an alias pointing to the location on disk of the website. Then you'll go into the Windows XP security settings for the website folder, and you'll provide security access to the folder for the .NET Framework's user. And then finally, you'll go into the IIS administrator and provide anonymous access. Let's go through the steps. I'll be working with a folder called the Night Owl. Now you're going to set up a virtual directory. You can set up the virtual directory initially using Windows Explorer. I'll right-click on the folder, the Night Owl, and I'll go to Sharing and Security. In the Properties view, I'll go to Web Sharing, and then I'll share the folder by selecting that option. This dialog pops up labeled Edit Alias. An alias is essentially a virtual directory name, a pointer to the physical directory on disk. Aliases for the web are typically created using all lowercase, so I'll set my alias as simply Night Owl. The access permissions that are presented by default are the minimum that are needed: read access to get to the files, and script access to execute your ASP.NET scripts. Click OK to save the virtual directory, and then click OK again. Now the next step is to provide Windows XP file access for this folder to the user that's used to run the ASP.NET website. Right-click on the folder again and select Sharing and Security. Go to the Security tab and take a look at the different options. There's security available for administrators, system, and training. None of these three categories include the user that's used to run the ASP.NET website and IIS. So, to easily grant that permission, I'll click the Add button, and I'm going to assign very broad permission. I'll type in the word Users and click Check Names. And I see Bartotech DEE1/users. This means I'm going to be granting these access permissions to all users on the computer, and that's okay. I'll click OK, and then with the new users category selected, I'll select Full Control and click OK. Now the next step is to provide anonymous access through the Internet Information Services Management Console. I'll go to the Start menu and select Control Panel. Within the Control Panel, I'll double-click on Administrative Tools, and from there go to Internet Information Services. This is the Internet Information Services Management Console. It was installed during the IIS installation. I'll go to the tree on the left and open the local computer, and from there open Websites, and then select Default Website. With Default Website selected, in the panel on the right, I'll see a list of all the physical files and folders within the root folder, and I'll also see any virtual directories, including the Night Owl virtual directory that I already set up. Now I'll right-click on Night Owl, and I'll go to Properties. In the Properties screen, I'll click on Directory Security, and then I'll click the Edit button under Anonymous Access and Authentication Control. When you create a brand new virtual directory in Windows XP Service Pack 2, Anonymous Access is disabled by default. I'll check to select Anonymous Access, and notice that now I'll be working with the username IUSR and then the name of the machine. I'll click OK, and then click OK again. And now I'm finally ready to test my website. I'll go to a browser, and then I'll type in the address of the website. Because I'm still working on the local machine, it'll start with http://localhost, and then the virtual directory name that I created, Night Owl. It may take a few moments for the server to respond on the first attempt. It's doing a little bit of back-end processing. But once it's finished with that, you'll see the default home page of the website rendered on the screen in the browser. Once the home page is loaded, you should be able to navigate around to other pages without any further delays. Now, I'm loading a version of the website that doesn't use any database functionality, just to simplify this process. But if you've already installed your copy of SQL Server and set up your database, you should be able to take other versions of the Night Owl website from other chapters of the video series and deploy those instead, and your database access should work right away without any hesitation. So that completes the process of deploying an ASP.NET website using Internet Information Services and ASP.NET 3.5 for Windows XP. In Windows Vista, Internet Information Services is included in the primary installation, but not enabled automatically. To turn on IIS in Vista, follow these steps. Start off in the Control Panel. Go to the Start menu and select Control Panel, and from there click on Programs. In the Programs section, look under the category Programs and Features, and click Turn Windows Features on or off. It'll take a few moments for the Windows Features panel to come to life. It first scans your computer to find out what features are turned on and which are turned off. In the Windows Features list, locate Internet Information Services and open it up. Don't install the entire category. You'll be installing a lot of software that you don't need. Go to the category World Wide Web Services and click that entire category, and then go to Application Development Features and minimally turn on .NET Extensibility and ASP.NET. If you also want to use older versions of the Microsoft Server software, you can turn on ASP or Active Server Pages. Also go to Web Management Tools and turn on the IIS Management Console, IIS Management Scripts and Tools, and the IIS Management Service. Finally, go to Common HTTP Features and make sure that all of the options are selected under that category. You can turn on certain other features such as Basic Authentication under Security, Request Filtering, URL Authorization, and Windows Authentication if you need these features. Click OK, and then take a break. It'll take Windows Vista a few minutes to complete the installation that you've requested. When you're done with this part of the installation, the next step will be to download and install the .NET Framework, and I'll describe that in a separate video. Once you've installed Internet Information Services on your computer, you then need to either install or link up the .NET Framework. If ASP.NET version 3.5 wasn't previously installed, you can download it and install it. Go to this website, www.asp.net. On the home page of the website, go to the Get ASP.NET Free section and click on ASP.NET Framework. Go to Framework version 3.5. At the time of this recording, the most recent version was SP1 or Service Pack 1. And then download the installer. Run the installer, following all the prompts. The process of installing the .NET Framework on Windows Vista in this fashion is exactly the same as for Windows XP. If you haven't already watched that video, watch the detailed video for installing .NET on Windows XP, and you'll see the steps exactly. Now, if you've already installed the .NET Framework version 3.5 as part of, let's say, Visual Web Developer, then you have one step to follow to connect the two together. Go to a command window. In Vista, you can click on the Start button and then type in cmd and press Enter. From there, switch to this directory, c:\windows /Microsoft.NET /framework v2.0.50727. That's not a mistake. Even though you're going to be working with version 3.5, you actually register version 2, and then you'll have access to all of the ASP.NET components from version 2 through the 3.5 version that you've already installed. Now, to connect the components together, type in this command: ASP.NET _ regiis, that's REGIIS, then a space character, then -I for install, and press enter. And you should see the message, finished installing ASP.NET. Once you've done that operation, your installation of ASP.NET 3.5 and your installation of IIS will be connected together, and you'll be ready for the next step, deploying a website. Once you've installed Internet Information Services and configured the .NET Framework, you're ready to deploy a site. For this demonstration, I'll use the folder The Night Owl, which contains a set of website files. I'll copy that folder to the clipboard, and then go to the desktop and paste the folder there. You can place your website files anywhere on disk. In a normal website deployment, I wouldn't place these files on the desktop, but I'm doing it here just for easy visibility. Now the next step is to go into the Internet Information Services Management Console. The easiest way to get there on Windows Vista is to go to the Start menu, and in the search input start typing Internet Information, and you'll see the Internet Information Services Manager application appear. Click the link to open the software, and then maximize it. If you watched the similar videos for XP, you'll notice that the manager in Vista is very different. It's much more graphically oriented, and instead of simple lists, shows you icons for each task. In the Connections section on the left, open the tree and go to Sites. Then go to Default Website. Right-click on Default Website and select Add Application. On Vista, an ASP.NET-enabled website is called an application. The alias can be anything you like, but on the web is typically all lowercase. I'll set my website or application alias to Night Owl. Then I'll click the Browse button to select the physical path. I'll navigate to my computer's desktop and select the folder The Night Owl, and click OK. If you click the Connect As button, you'll see in a dialog that you're automatically connecting as the application user. Click OK to accept that, and then click Test Settings. You should see the message that access to the path on disk is not verifiable. That's okay. I'm going to be showing you how to check security next. Click Close, click OK, and then just minimize Internet Information Services Manager. We may need to get back there later easily. Next, go to the folder on the desktop, The Night Owl. Right-click on it, and select Properties. In the Properties dialog, click Security, and then click the Edit button to modify the security settings for this directory. In the list of group or user names, click Add, type Users, and click Check Names, and then click OK. Simply for the ease of use, I'm granting broad security to all users of the computer. If you want to fine-tune the security a little bit more, you could identify the username that's being used to run .NET and only grant security to that user. With the users group selected, I'll go down to the Permissions for Users pane and select Full Control, and I'll click OK, and I'll click OK again. And now I'm ready to test my website. I'll go to the menu and open Internet Explorer, and I'll navigate to the website using the URL http://localhost/nightowl. After a moment, the website appears, and I can click around in the hyperlinks getting from page to page. If you've gotten this far, that means that you've successfully deployed an ASP.NET website using IIS and ASP.NET 3.5 on Windows Vista. The last step in deploying a website, either on your own dedicated server or to a hosting provider, is to transfer your database structure and data if necessary. Visual Web Developer includes a tool that allows you to create a text file, a script, that describes everything about your website, including its tables, columns, data types, and so on, and even includes all of the data that you've added to the database. When you use the scripting tool, you can choose to export just the database structure or the structure and the data. To get to this tool, go to the Database Explorer and go to the data connection that you're using to connect to your database. Right-click on the database connection and select Publish to Provider. The Database Publishing Wizard has two modes that you can use. Click Next on the introductory screen and select the database you want to work with, which in my case is My Bookstore. In this screen, you select either scripting to a file or publishing to a shared hosting provider. If you're working, say, with a hosting provider and you're renting SQL Server space from that company, they'll give you information that allows you to connect to their database. If you don't have that connection information, you can instead save the structure and data information in the text file. I'm going to place the text file on my desktop. I'll click the Browse button, I'll navigate to my desktop, and I'll name the file mybookstore.sql. I'll click Save to return to the database publishing wizard, and then I'll click Next. In this screen, you indicate certain options. The first option, Drop Existing Objects in Script, when set to True, means that when you run the script, if there are any tables of the same name as the tables that you're about to export, then those will be dropped or deleted from the database. Use this feature with care. The next object, Schema Qualify, generates a script that does not qualify object names. Next, you indicate which version of SQL Server you're going to be using. I'm assuming that I'll be deploying to SQL Server 2008, but there's also support for the syntactical differences that you'll encounter if your target SQL Server installation is version 2000 or 2005. And finally, in Types of Data to Publish, you can indicate whether you want to publish data only, schema and data, which is the default, or schema only, which would mean just the database structure. After setting your options, click Next. This is the review summary screen. After checking all of the options, click Finish. I'll click Close, and then I'll minimize everything to take a look at my desktop. And I'll find the new file, mybookstore.sql. I'll right-click on the file, and then open the file in a text editor. And you'll see that the database file contains all of the SQL commands that are needed to drop the existing structure in the target database, create the new structure, and then populate the database with data, which is done through all of these insert commands that you'll find further down in the file. To use this file, check the video earlier in this video series where I described how to import a database from an SQL script file like this one. So now you have all the tools you need to set up your Internet Information Services installation, install ASP.NET 3.5, and export your database structure and data to an SQL file that you can then import into your hosting provider or your dedicated SQL Server installation.